Welcome to the complete Cisco CyberOps course. Are you ready to master the skills needed to defend, detect, and respond on today's complex cybersecurity battlefield? You've come to the right place. In our connected world, cybersecurity has never been more critical. The financial impact alone is staggering, with global cybercrime damages projected to hit an incredible £8.5 trillion annually by 2025. Every day, organizations face relentless and increasingly sophisticated attacks that target their most critical data and infrastructure. This is why skilled cybersecurity professionals, the frontline defenders in our security operations centers, or SOCs, are absolutely essential. So, what exactly is CyberOps? Cybersecurity operations is the discipline focused on actively monitoring networks, detecting threats, and mounting a real-time response. It's all about the hands-on, day-to-day functions within a SOC, managing incidents quickly and effectively. In this course, you won't just learn theory. You will acquire practical expertise with the industry-standard tools and procedures used to protect modern organizations. At the heart of the SOC is the CyberOps Analyst. This is the vital first line of defense, responsible for maintaining a constant, vigilant security posture. Key responsibilities include the initial triaging of security alerts, a deep analysis of potential threats, and escalating confirmed incidents. You'll become proficient in network security monitoring and the fundamentals of digital forensics, and you'll learn to collaborate with response teams to mitigate attacks and restore systems. A CyberOps analyst is crucial for turning threat intelligence into decisive, actionable security measures. Our curriculum is structured into 20 learning modules to build your skills from the ground up. First, we'll cover security fundamentals, including the CIA triad and common attack vectors. Next, you'll dive deep into monitoring and analysis, learning to interpret network logs, NetFlow data, and IDS alerts. In incident response, you'll apply powerful frameworks like the NIST model and the cyber kill chain. Then, you'll master the essentials of digital forensics, focusing on proper evidence handling and investigation techniques. Finally, we'll bring it all together in the SOC workflow module, covering policies, procedures, and automation. This course is built on a foundation of real-world relevance for maximum impact. You will analyze actual cyber attack case studies, from ransomware outbreaks to advanced persistent threats. You'll get your hands dirty in simulated SOC environments, using virtual machines that replicate live settings. And through effective response drills, you will build the critical muscle memory needed to act decisively and efficiently when an incident occurs. This learning journey leads directly to a powerful, industry-recognized credential, the Cisco Certified CyberOps Associate. Our course is explicitly designed to provide comprehensive preparation for the CBROPS 200-201 exam. Earning this certification validates your expertise on a global scale and opens up significant career opportunities in security operations centers, incident response teams, and other critical handling roles. You will master the critical tools and technologies used by CyberOps analysts every single day. This includes configuring SIEM systems for log analysis, using packet capture tools for network analysis, understanding the basics of malware analysis, and deploying modern defense mechanisms like cryptography and endpoint security. We are committed to providing a superior learning experience. Your journey will include structured video lessons, interactive quizzes, and practical, hands-on exercises to ensure you retain what you learn. So, are you ready to become a cybersecurity defender? Ready to build critical, in-demand skills and launch a rewarding career protecting organizations from the threats of tomorrow? Join us on this essential journey. Your future in cybersecurity operations begins today. Hello and welcome. This is Module 1 of the CyberOps Associate course, titled The Danger. In this module, our main objective is to explain why networks and data are attacked. We'll do this by looking at three main topics. First, some real-world war stories. Second, the threat actors behind the attacks. And third, the potential threat impact of these incidents. Let's begin with Section 1.1, War Stories. First, let's talk about how people can be digitally hijacked. Hackers often set up fake, open wireless networks that look legitimate. These are called rogue wireless hotspots, or evil twin hotspots. If you connect to one, the hacker can intercept your data. Companies are also major targets. A common tactic involves luring employees into opening email attachments that install ransomware on their computers. Once installed, this software begins gathering and encrypting corporate data. The attacker's goal is financial gain, as they hold the data for ransom until they are paid. The threat can even escalate to targeting entire nations. Some modern malware is so sophisticated and expensive that it's believed only a nation-state could create it. This malware can be aimed at a nation's vulnerable infrastructure, such as its power grid or water system. A famous example of this was the Stuxnet worm, which infected USB drives to infiltrate Windows systems and target Siemens software used in programmable logic controllers, or PLCs. That brings us to Section 1.2. So, who are these attackers? Threat actors are the individuals or groups who perform cyber attacks. These attacks are intentional, malicious acts designed to negatively impact an individual or organization. Threat actors include amateurs, hacktivists, organized crime groups, state-sponsored groups, and terrorist groups. Let's look at the first type, amateurs. Also known as script kiddies, they have little or no skill. They typically use existing tools or follow instructions found on the internet to launch their attacks. Even though they use basic tools, the results can still be devastating. Next, we have hacktivists. These are hackers who publicly protest against various political and social ideas. They might leak sensitive information or disrupt web services with illegitimate traffic in what's known as a distributed denial of service, or DDoS, attack. A huge amount of hacking activity is motivated by financial gain. These cybercriminals are focused on gaining access to bank accounts, personal data, and anything else they can leverage to generate cash flow. Sometimes, the motivation is political. Nation-states may hack other countries to interfere with their politics or to conduct industrial espionage. The theft of intellectual property can give a country a significant advantage in international trade. We also need to ask, how secure is the Internet of Things, or IoT? Many connected devices are not updated with the latest firmware, and some older devices were not designed to be updated at all. These situations create huge opportunities for threat actors and security risks for us all. This leads us to our final section, the threat impact. One of the biggest impacts is the theft of sensitive data. Cybercriminals aim to obtain personally identifiable information, or PII, things like your name, social security number, or credit card details. This stolen PII can then be used to create fake financial accounts. Subsets of PII include protected health information, PHI, from medical records, and personal security information, PSI, which includes your usernames and passwords. For a business, the loss of intellectual property is a serious concern. But an even greater concern can be the loss of customer trust that happens when a company is unable to protect its customers' personal data. This loss of trust can be more damaging than the theft of trade secrets. Finally, the impact can threaten national security. State-supported hackers can cause the disruption and destruction of vital services within an enemy nation. Because the internet is so essential for commercial and financial activities, disrupting them can devastate a nation's economy. So, what did we learn in this module? we learned that threat actors can hijack personal information using tools like evil twin hotspots. We identified various threat actors, including amateurs, hacktivists, and organized crime groups. We saw how the expanding Internet of Things creates new vulnerabilities. And finally, we defined the types of data at risk: PII, PHI, and PSI. Welcome to Module 2, Fighters in the War Against Cybercrime. In this module, our objective is to explain how to prepare for a career in cybersecurity operations. To do this, we will cover two main topics. First, we'll explore the Modern Security Operations Center and explain its mission. Second, we'll discuss becoming a defender and describe the resources available to help you prepare for a career in this field. Let's start with Section 2.1, the Modern Security Operations Center. To defend against cyber threats, organizations use professionals from a Security Operations Center, or SOC. A SOC provides a wide range of services, from monitoring and management to comprehensive threat solutions. A SOC can be entirely in-house, or its services can be contracted out to security vendors. As the diagram shows, the core elements of any SOC are its people, processes, and technology. Let's look at the people. SOCs assign job roles by tiers, based on expertise. Tier 1 alert analysts are on the front lines. They monitor incoming alerts, verify if an incident is real, and forward tickets to Tier 2 if needed. Tier 2 incident responders are responsible for the deep investigation of those incidents and will advise on what action to take. Tier 3 threat hunters are the experts. They handle advanced tasks like malware reverse engineering and proactively hunt for threats that are already in the network but haven't been detected yet. Finally, the SOC manager manages all the SOC resources and serves as the main point of contact for the rest of the organization. As this diagram from the SANS Institute shows, Tier 1 jobs are entry-level positions on the front lines. They escalate to Tier 2 for deeper investigation. Tier 2 can then escalate to the Tier 3 specialists, like threat intel, network, or malware experts. The SOC manager oversees the entire operation. Next is the process. A cybersecurity analyst monitors a security alert queue using a ticketing system. The software that generates alerts can often trigger false alarms, so the analyst's first job is to verify if the alert is a true security incident. If it is, the incident is forwarded for action. If not, it's dismissed as a false alarm. If a Tier 1 analyst can't resolve the ticket, they forward it to a Tier 2 incident responder, who may in turn escalate it to Tier 3 personnel. The third element is technology. A SOC needs a Security Information and Event Management System, or SIEM. A SIEM collects and filters data from all over the network, like from firewalls, logs, and network traffic. It then helps analysts detect, classify, analyze, and investigate threats. SIEM is often paired with SOAR, which stands for Security Orchestration, Automation, and Response. Like ASIEM, a SOAR platform aggregates and analyzes alerts, but SOAR goes a step further by integrating threat intelligence and automating the incident response workflows based on playbooks developed by the security team. A SOAR platform gathers alarm data, provides tools to investigate cases, and uses integration to automate complex incident response. It uses predefined playbooks to enable automatic responses to specific threats. These playbooks can be triggered automatically by rules or manually by security personnel. To understand how well a SOC is functioning, we need to use metrics, or Key Performance Indicators, KPIs. 5 common metrics are: dwell time, How long a threat actor has access to a network before being detected and stopped. Mean time to detect, MTTD, the average time it takes to identify a valid security incident. Mean time to respond, MTTR, the average time it takes to stop and remediate an incident. Mean time to contain, MTTC, the time required to stop the incident from causing further damage. Time to control, the time it takes to stop the spread of malware on the network. Medium and large organizations often benefit from an enterprise-level SOC, which is a complete in-house solution. However, even larger organizations may outsource at least part of their SOC operations to a security provider. Cisco, for example, offers a wide range of services, including its Product Security Incident Response Team, PSIRT, its Computer Security Incident Response Team, CSIRT, and Cisco Managed Services. A critical concept in this field is the balance between security and availability. Security personnel must understand that the network needs to be available for the organization to function. There is always a trade-off. Security cannot be so strong that it interferes with the needs of employees or business functions. Now, let's move to Section 2.2, Becoming a Defender. A variety of cybersecurity certifications are relevant for a career in ASOC. These include the Cisco Certified CyberOps Associate, the CompTIA Cybersecurity Analyst certification, various ISC2 certifications, and certifications from GIAC, the Global Information Assurance certification. Beyond certifications, you should consider a technical or bachelor's degree in a field like computer science or information security. Computer programming is an essential skill. If you've never programmed before, Python is a great first language to learn. Additionally, Linux skills are extremely valuable. So how do you get experience? Internships are an excellent method for entering the field. Even a temporary internship provides valuable experience. Temporary agencies are also common. Companies may use them to fill job openings, which can then convert to full-time positions. If you have no experience at all, working for a support desk or call center can be a great first step to gain the experience you need. Let's summarize what we've learned. The major elements of a SOC are its people, processes, and technologies. Job roles include Tier 1, Tier 2, Tier 3, and the SOC manager. A Tier 1 analyst monitors incidents and opens tickets. SIEM systems are used for collecting, filtering, and analyzing threat data. SOAR platforms integrate threat intelligence and automate responses using playbooks. And finally, SOC performance is measured with KPIs like dwell time, MTTD, MTTR, and MTTC. We also learned that there must be a balance between security and network availability. Security cannot be so strong that it interferes with business functions, and we saw that a variety of cybersecurity certifications are available to help you prepare for a career in a SOC.
So this is about Windows. So we are going to actually understand how the Windows is actually laid out. So if someone is like you are really old like me, so you must have seen this MS-DOS back in the days that once we do not have any graphical user interface. So we had those large floppies, 3.5 inches and 5.2 inches. Those were the days, and you only get this command prompt. There was no GUI. So this was the first operating system, the disk operating system. So then once Microsoft came in, they acquired that terminal version of the MS-DOS, and they built a graphical user interface on it. So now we had the graphical user interface, but underlying system was DOS. So we had earlier Windows with which were called NT, Windows 3.1 NT or Windows 4 NT, that were around 92, 93, and we used to run the different commands by opening the command prompt and just typing enter, and we can run anything. So these were the earlier Windows. So there are a few commands that are still applicable nowadays as well. So if you go into your PC and type in CMD, you can open a command prompt, and it is just the same old DOS, just now the enhanced version. And if you want, you can do anything on it as well. You do not need the graphical user interface. For example, if you type in, you can do it with the lecture as well. You just open CMD and try a few commands from here. For example, the dir is used for listing all the files in the folder. If once you have the folder list, you can just change your directory by typing in CD and the folder name. You will be able to change it. For moving back one directory, you can just type in CD space double dot. Similarly, there is copy command, delete command, find command. There are different commands that are there in the DOS. And why we are interested in the terminal commands as an attacker, you saw once we were discussing ethical hackers, that once we have access to a system, we mostly have access over command prompt. We do not have the GUI. We have to just attack the system using command prompt. So these commands help out or help an attacker there where he is actually attacking it. So now, since 1993, there have been around 20-25 releases of Windows. First, we had the 32-bit architecture. Now we have the 64-bit architecture. So the difference between them is that the 32-bit architecture could only map 4 GB of RAM or 4 GB of addresses at a time. The 64-bit extended this possibility, and we can now have a lot more RAM. We now see PCs around 128 GB of RAM or 256 GB of RAM, which increases the speed as well as functionality of a PC. So, and the fun fact is that once Windows 10 was released, Microsoft announced officially that there will be no more operating system. Windows 10 will be the last operating system, and the users will only be updating it, and no new version will come out. But we saw Windows 11 then coming out after a few years. And then for each Windows, we have different versions: starter, home, basic, student, these type of versions. For example, for Windows 10 and 11, we have this Home Pro, Pro Education, Enterprise, Mobile, and Mobile Enterprise. Mostly we have this Windows Home or Windows Pro that are installed on our systems. And if you have the Pro version, this provides enhanced security by default. For example, it enables BitLocker by default on Windows 11 and Windows 10 as well. For the Home Edition have some capabilities restricted. For example, you cannot have a local user account on an Home Edition. If you have a Pro Edition, you can have a local user account. Otherwise, you have to log in with your email account nowadays on your Windows. But if you have a Pro Edition, you can have a local account as well. Then we have different servers as well. Windows Server 2012, Windows Server 2016. So these are mostly used for hosting files, web services, Active Directories, and these services are provided by the Windows Server Edition. So this is just the old GUI of the Windows 10. There's a start button, you know it. There's a quick launch icon, notification area, cycle win, etc. It's just same thing. And once you right click any icon, the menu you see is called the context menu. So this all depends upon the software that you have installed. For example, if you have OneDrive, you will see the OneDrive. If you have some antivirus, there may be some additional items there. Here you can see that 7-zip is visible. It means that 7-zip was installed in the system. And it also depends upon the icon that you clicked. So the options vary. So this is actually the context menu. Then there are a lot of vulnerabilities. We saw in the ethical hacker course that some vulnerabilities are related to the services that are being run on the system, but some vulnerabilities are directly related to the operating system as well. So as operating system contains millions of lines, so it becomes very difficult to assess whether the computer or the operating system is completely secured. A bug in one of the lines can cause a flaw that an attacker may exploit. So we see different type of vulnerabilities and we have some recommendations based upon them that how we can prevent those vulnerabilities. For example, to prevent from virus or malware protection, we must use some antivirus. By default, Windows Defender is available in Windows 10 and Windows 11. You can use that. And then if you do not know some unknown or unmanaged services they are running, you can just check it or disable them from the task manager. You can just click Control or delete, the task manager will open up. We will see later on as well, and there is a startup tab as well where we can disable services. Then there is encryption, that the data should not be visible to the others that are not authorized. I told you that in Windows Pro version we have BitLocker installed that encrypts the complete drive once it is found. Then there are security policies as well. Firewall must be there, that should limit connections to the devices. It limits that which ports are there and which ports are allowed to be connected to. Then we have the file and share permissions. We can set up these permissions. Once you are sharing it, you can just enable the password or you can set who can have access to it. Similarly, there are weak or no password vulnerability that you must actually, the password policy should be there and you should be using some complex passwords. And it is best practice to be logged in as a standard user and only use the administrator account to accomplish certain tasks when only needed. So what is the computer architecture and how it is laid out? So at the bottom layer, we have the hardware. And then we have the hardware abstraction layer that separates the software from the hardware. And it acts as a gateway. So we have the kernel on it, we have the operating system kernel on it, and the different drivers, the kernel mode drivers and the file system drivers. So applications or Windows make use of APIs, Windows API, to talk to the operating system kernel, and the operating system kernel then talks to the actual hardware. So you do not need to be actually talking directly to the hardware, and it also provides us a protection that even if you run some malicious code, it is not directly going to the hardware. It just passes through some checks at the kernel level first. In early Windows, you must have seen errors like blue screen of death. where your complete screen becomes blue and the complete computer just crashes. So if something happens at the kernel level, at the kernel mode drivers or the operating system kernel, your computer just crashes. That's why we advise or the Windows advise that your application or the user level application should be running one level above and should be talking to kernels through Windows API to filter out some malicious inputs. So there are two different modes in which a CPU operates when the Windows is installed there. The user mode and the kernel mode. So your all applications that are installed run in the user mode by default, and the operating system code runs in the kernel mode. And the code that is executing in the kernel mode has unrestricted access to underlying hardware and is capable of executing any CPU instruction. So it can also reference any memory address directly, and it is generally reserved for most trusted functions of the operating system. And any crash in a code running in kernel mode will affect the operation of the entire computer. So conversely, programs such as user applications run in the user mode by default and have no direct access to hardware or memory locations in the RAM. User mode code must go through the operating system to access these hardware resources. So this all provides some kind of isolation, and a crash in a user mode is restricted to the application itself. So now our application can crash, but our computer will keep on running. So we have different file systems on our hard disk or on USB drives that are supported by the Windows. For example, we have the exFAT or FAT32 or FAT16. If you are formatting a drive, a USB drive, it will give you an option to format it with FAT system or NTFS system. So FAT is generally recommended for USB drives because some systems only accept this FAT32 drive. For example, the media players on your in your cars only accept FAT32 formatted USB drives. So this was an old system which has now been replaced by NTFS. So this HFS file system is used by the Mac system. It is not supported by the Windows. Similarly, we have the EXT system. This is supported by the Linux-based computers. And we have the NTFS file system that is supported by the Windows. So we must understand how this NTFS generally operates. So on a physical hard drive, we have different sectors. So NTFS formatting creates important structures on the disk for file storage. So first is the partition boot sector. This is the first 16 sectors of the drive. It contains the location of master file table, and the last 16 sectors contain a copy of the boot sector as well. So on you can divide a hard disk into a number of chunks that are called sectors, and the first and the last one contains the partition boot sector. If there are multiple partitions, it keeps a record of where the C drive is starting up, where the D drive is starting up, and it also contains where the master file table is starting. So the master file table contains the location of all the files and directories on the partition, including the file attributes, such as when the file was created, when it was modified, and if you study some forensics, this is the MFT is the gold mine for forensic investigators because it contains links to all physical locations on the hard drive where actual file is being stored. So if you are searching for some file on your system, it actually looks for the master file table, and from master file table, it identifies in which sector your file is actually written. Then we have the system files. This may contain information about volumes and file attributes, and then we have the file area, where it is the empty space that we see in the C and D drive where our files are stored. So once we format a drive, you must remember that only the record or the links to that data is destroyed. The file remains saved on the drive till the time they are overwritten. That's why if you want to permanently delete some file, you must use some kind of a shredding software, the spot shredding software that securely wipes the complete data. So one important functionality of NTFS is that it provides alternate data streams. So normally we have our Windows or our PCs that are formatted with NTFS file system, and it has an additional functionality called alternate data streams. So what it does is that it can contain metadata about a file. So by using NTFS, alternate data streams can be connected to the file. For example, once you download a file from internet, an ADS is automatically created and it stores the link from where the file is downloaded. But an attacker can also store some malicious code within an ADS that then can be called from a different file. We will see its practical in the next session, how we can create an ADS data stream. But now the file will be changed. It will be written as test file.txt and the colon ADS or anything that you can refer to. And it will not be visible in if you do the dir, but it is still there and you can hide some malicious code in there and can directly run the code from there. So how does a Windows boot? So there are two types of computer firmware that exist. The older ones use the BIOS that was created in the 1980s. Uh, it still works like it worked in 1980s, but as the computer evolved, this BIOS system was becoming old, so we shifted to Unified Extensible Firmware Interface UEFI system. So it was designed to replace BIOS and support new features. So in BIOS firmware, the process begins with BIOS initialization phase. It is when you just turn on the computer, hardware devices are initialized, and a power on self-test called a post is performed to make sure that all these devices are communicating properly and are functioning properly. And when the computer completes the post, the last instruction in the post is to look for the master boot record or MBR on the hard disk. And from the MBR, the system starts to load up. In contrast, while we are using UEFI, UEFI boots by loading EFI program files stored as EFI files in a special disk partition. So that's why sometimes we see some hidden partitions in the system as well. These are there to store EFI files. So a computer that uses EFI stores boot code in the firmware itself, and this helps to increase the security of the computer at boot time because the computer directly goes into the protected mode, and when the and now the user does not have the control. So once a window installation is located, whether we are using BIOS or UEFI, a boot manager.exe file is run, which switches the system from the real mode to the protected mode so that all of the system memory and resources can now be used. So what this file does is that it reads the boot configuration database that is available that contains any additional code needed to start the computer, and then the computer just calls on some drivers and the boot process binaries, and these are all loaded into the firmware and the computer starts. So there are two important registry items that are automatically start once we start the Windows. These are HK local machine and HK current user. So several aspects of Windows configuration are stored in HK local machine registry. You can just type in regedit and you will just fall into the registry editor and you will see different services there. Similarly, the aspects of a current user, for example, about information about your desktop, your icons, these kind of all information is saved in the current user registry editing file. So different entities in these registries define which services and applications will start depending upon the user that is logging in. And they include run once services, and these kind of services. So there is another tool called msconfig.exe. If you run it on your PC, you can run it. It opens the system configuration menu, and you can just manage the services that are starting with a bootstrap or startup. So if you run this msconfig.exe on your on your Windows, you will see something like this. So these are different startup options that are available. For example, normal startup, diagnostic startup, and selective startup. If you are facing some Windows issue, you can just do the selective startup as well. Then there is a boot menu, which indicates which Windows to boot. If you have multiple Windows installed on the PC, you will see different options there. And if you are having trouble with your Windows, you can just click on the safe boot option, and which will boot your PC to the safe boot and restricting some services, and that will help you to troubleshoot it. And these are the services that are running once you log on to the computer. You can enable and disable services from here. But these are some services are system services, so you must be very careful once enabling or disabling services. Then there are startup tab. Now this has been moved to the task manager. If you open a task manager, this is now there. We will see that later on. And then there are some tools that are there, for example, computer management, event viewer, system properties, change UAC settings that we can directly configure from here. So msconfig.exe is a blanket tool that can be used to run different utilities. And you can just shut down your PC properly always. Always, there are different options. You can shut it down, you can restart it, you can hibernate it. Hibernating is that the current state of the computer remains saved, and if we turn back the computer on, we start where we left off. So you can open the task manager by pressing Control or Delete, and there will be different processes that are listed. Each process that is running is made up of at least one thread. A thread is a part of the process that can be executed. You can see that if there is a major application, its different functions will be running in different threads. And all of the threads dedicated to process are contained within the same address space. It means they are sharing the same RAM location. So some of the processes that you will see in the task manager are actually services. These are the programs that run in the background to support the Windows operations, such as wireless or access to an FTP server. And we can open this tab by typing in the services in the search bar, and you will open a menu like this where you can configure the services. For example, you can start a service or stop a service. Then there are memory allocation and handles. Uh, our RAM is distributed in different address spaces, and different processes or threads are allocated a specific chunk of these RAM so that they do not interfere with the RAM or the memory of other processes. So these are actually not the physical locations, but these are actually entry in a paging table that is used to translate these to the actual physical location on the RAMs. So in 32-bit Windows systems, we could only map 4 GBs of RAM, but now in 64-bit PCs, we can go up to 8 terabytes of RAM. And each user space process or a program runs in a private address space separate from other space processes. So it means that Microsoft Word is running in its own chunk of RAM. Microsoft Excel is running its own chunk. Our browser, a Chrome or Firefox, has a dedicated RAM, and they do not interact. They cannot interact directly within RAM, so that these processes are same from one another. So if we are looking to actually see what processes are running and how much RAM is each resource is utilizing, we can make use of Task Manager as well. And then there is another tool called RAM Map. We will be downloading it in the next session. It is a part of Windows internal suite, and which is provided by the Microsoft, and it will tell us how much RAM is being utilized by each process. Then there is the registry that contains all the information about the hardware, software, and applications. The way that these objects interact are also recorded within the registry, such as what files an application opens and all the property details of folders and applications. Registry is hierarchical, where the highest level is known as the hive. So we have the 5 hives, and then there are multiple keys. For example, the current user hive contains information about the currently logged in user. The user's hive contains information about all other accounts. We have the classes root hive that contains about object linking or these libraries, DLLs, where the applications utilize other programs for their basic functionality. Then we have the local machine hive, which contains information about system information. And then we have the current config hive, which contains the hardware profile, like which RAM is installed and what type of CPU is there. New hives cannot be created, but we can add and delete registry values. But we must be having some administrative privileges to run it. And the software that we can use is regedit.exe. So we can just move in the registry just like we move in the file explorer. There are different hives we will see in the next class, and we can just add and delete values, and there are different type of values we can add, give it to some registry entry. For example, the binary value where we can only assign 1 or 0. Then we can assign a number greater than 32 bits or raw data, and then we can also assign string values. Okay, last time we were discussing about Windows. We left a few labs. I told you that we will do them in the next session. So let's start by downloading this Sys internal suite. You can also open this link, Sys internals. You can search on the Google.
Which one? Which one?
Sys internals. Sys internals.
Sys internals.
These are the tools from Microsoft, just like Task Manager, but it has some additional functionality. It is a set of tools, not only one tool. There is a set of tools, but they provide additional information about the Windows.
All right.
Okay.
Should be some download link here. Let me see this one.
Yeah, the top one. That one,
Yes.
yeah.
My interface is really different now. Sys internal utility index.
Yeah, Sys
No,
internal
just
suite.
so it just type in the search bar and search
Yeah,
with
yeah, I've got
download
it.
Sys internals.
Is the first one to download? Download Sys
Yes, yes,
internal suite.
yes. This is the first one.
Okay.
So we will see a few applications from here. There are a number of applications here. There is one tcpview.exe.
In the download.
Yes,
The 64-bit one or the 32-bit one?
you can run anyone. Doesn't matter.
Okay.
And here you will see a number of connections that are going out. In the ethical hacking course, I think we discussed about a netstat command on the command line. But this tool is also very useful that tells you that which process is connected or listening to which IP address. For example, this one is connected to this IP address. Chrome, this remote address is this one. So these are the different applications that are running on my system and are making connections to these remote IP addresses. So this
Mm-hmm.
helps you trace if there is some Trojan going on or there is some keylogger that is sending information over the internet to someone else or the attacker. So this is one of the easiest method to look for any suspicious application. Similarly, if some application is listening, it means that it has open connection and it is listening for connections. For example, if 3389 port is listening on my PC, I know that if you search for 3389 port, what port is this? So it is for remote desktop protocol. It means that RDP is enabled on my laptop. Maybe I didn't want to enable it, but uh, in the background or automatically it is enabled by the Windows, and I don't want it to be enabled. So this is one quick way to check if something is enabled. So there are number of applications that are running here. So if you open anything, for example, Edge, and let's browse to some website, and in the web we should see Microsoft Edge coming in, this one. So it has established connection over IPv6 protocol to the remote terminal, the remote server. We can also filter it with TCP IPv4, TCP IPv6, and if UDP traffic is going on, we can filter this traffic from here as well. So this is one utility that can be very useful. The other utility that can be useful is Process Explorer. Uh, this one is actually a big brother of Task Manager that you see in the Windows, but it gives a lot of information regarding the services and the processes that are running. This is the main uh, window of this, and you can see that it is giving us the hierarchical layout, that which service is running which service, and if there is some child services, then it will also list down these. For example, this is Microsoft, and Microsoft Edge has these services started.
Where are all these files? Are the file we downloaded, or where are they?
Yes, in the downloaded this internal suite, and then you extract it.
But that's a zip file actually.
Yes, just extract it.
Right.
Yes, extract and then use it. And you can also just like Task Manager, you can just kill the process tree and it will be killed. Moreover, if you want to know that if some service is a virus or not, or you don't know about a service, what you can do is you can right click it and you can click on check virus total. So what it will do is it will automatically submit the hash on the antivirus's website, that is virus total, and it will tell you whether it is a virus or a Trojan or not. For example, here it has told me that out of 78 antiviruses, none has detected it as a virus because it is a utility, Microsoft Word and legitimate utility, so it has not been detected as a virus. So if you find something suspicious, and if you want to know that whether uh, it is some kind of a Trojan or a malicious activity, you can just right click it and click on check virus total, and its hash will be submitted, and you will get the results back. And if it is 0 by 78, it means it has not been detected. This is the main website, virus total. It was its hash, and this website actually checks on different antiviruses. For example, AVG, Vedu, or these kind of antiviruses like Bitdefender and check whether this file has been detected as virus or not. So this was Microsoft Word and it has not been detected as some malicious file. So this is one utility of that.
What do you say again? What is the point to get if that one is suspected virus?
Yes, for example, if you suspect, for example, if you don't know that what is binlogon.exe, what it is doing on my system,
Yeah.
a quick way to check is that you just send it to VirusTotal,
Yeah.
and it will tell you that it is a virus or not. Although there are some many system files you see here as well, which you may not know whether they belong to system file or some other utility, but you may get some information from the description as well, and then you can just submit it to VirusTotal, and without even if you don't have the antivirus installed, or if you do not trust the antivirus, you can just upload the virus manually on the VirusTotal. But a quick way to do is, if something is running, you can just send it directly from here to VirusTotal. It will check whether this is some malicious file or not. So it becomes very useful. And similarly, it also tells you about different processes tree. For example, I've opened this command terminal and I want to ping google.com. So it must now be visible somewhere here. Dash E was the flag. So it is running here, the command prompt, and it has called this process from the cmd.exe to execute our ping command. So you can actually see these. For example, we can see this ping here. You see here, command.exe called this conhost.exe. That is some kind of Windows host or Windows 5, and then it executed this ping utility. So you can actually see which process has started which process. So sometimes, for example, you run some application, it runs multiple programs. So you can actually see the layout which is running what. Okay. In addition to command prompt in Windows, we have the PowerShell. So this has higher privileges than command prompt, and it has some additional functionality with it. But its commands are a little bit different than those you run on the command prompt. And mostly these commands are also just like the Linux version. For example, in Windows we do the dir, but on PowerShell we can also do just ls. So although it is the Linux command, but it also works here. So a few commands of the Linux also works here. Similarly, if you know some command utility command from the CMD, but you do not know the actual command over what command you can run you can perform the same functionality with the PowerShell. You can just use this utility get alias, and it will tell you what command you can use uh, in lieu of this on the PowerShell. So for translating commands from CMD to PowerShell, you can use this utility. Similarly, we have the same commands here like netstat. If you want to see the routing information, you do the netstat/-r. It will tell you the routes, what network destination you can reach, and which is your default gateway for that. So the commands are a little bit similar to the command line. So these are just general information. The basic utility that we do have in the Windows in every system is this task manager. Just like in Process Explorer, we were able to see the processes in details, but a summary is also available if you do not have that for Process Explorer. And one quick thing you can do is you can go into the Startup tab, and it will tell you which files or processes are run when the system starts. And it will tell you what are the status, whether it is set up as auto start or not. For example, my VMware is set to be enabled automatically. It means that whenever my Windows start, it will automatically be started. For example, my Grammarly will be started, my IDM Internet Download Manager will be started, Microsoft 365, I have disabled it. So by time, there are a lot of applications that add themselves to this list. And if your boot time is becoming slow and slow, you can just come here and disable them from here. For example, I can just click on anything and disable it. So it will be disabled. Now it will not be started automatically. Although you can start it manually once you have logged in on the Windows, but it is very good thing to do that you just disable the services that you do not need every time when your Windows start, because it will slow down your boot process. Similarly, you can just look here regarding the information about the CPU, memory, hard disk, and different processes. You can just uh, sort them with what process is taking much memory. For example, here my Google Chrome is taking a lot of RAM, and that may be some kind of an issue for me because I'm not using it, but still it is utilizing around 1.5 GB of RAM. Similarly, you can check which application is using my CPU the most, which is the meeting link. So it is uh, uh, well defined. Similarly, you can see which is utility or the process is using my disk space. So all this information is available on this task manager. There is another utility called Process Explorer. I think it was Resource Monitor. Sorry, Resource Monitor. You can search on the search bar Resource Monitor, and it will also give you in detail the utilization of CPU and memory by different processes. So it helps to troubleshoot if something is creating issues and your computer is not running at the optimal uh, speed and is giving you issues. You can just come here and check which process is actually taking up your RAM or CPU or hard disk. So you can actually troubleshoot it and close it and see if performance approves. Similarly, you can go into the network tab and see what process is sending how much data over here. For example, it is Cisco collab host.exe, so I can just well judge that this my net meeting is sending data. Then you can just see that Grammarly is sending data. Although it is just used for checking the spelling, but it is automatically sending a little bit of data to its servers, which is a little bit privacy concern, but I'm just ignoring it. Similarly, Chrome.exe is sending data. This uh, antivirus services is sending data. So you can actually look for who is sending data to whom. Similarly, you can see the WhatsApp is also enabled, so it is also connected and is sending data outside. So it is uh, a good utility to monitor your traffic, your resource allocation to troubleshoot any issues. These are the just same things. So I think we just covered till 3.2 in the last session. So now let's see about something about Windows configuration and monitoring. So it is the security best practices that you should not be running your services as Windows. So once you are logged in as a normal user, you can just right click it and open it as administrator, just like as shown in the slide, and your process will be running in the administrator privileges. Similarly, in we were running CMD or PowerShell, but if we want to run some privileged process, for example, netstat command that you want to run to check the open connections, it is advisable that you run the CMD with the administrator privileges. You can just right click it and open it as the administrator. Just like that, you just search for CMD and right click and open it with administrator privileges. So now comes the local users and domains. So when you install Windows, it will ask you to list down the account that you want to use. So once you shut it down and boot it again, your customization settings, your access permissions, and file permissions remain the same. So similar to a user, if it is a multi-user system where there are a number of users involved or are using the same PC, mostly once it is a server, it will be used by a number of people. So we create groups. We create groups and we add the users to different groups. For example, we can make a group marketing and add 4 users in it. Similarly, we can add a group network administrator and we can add a number of people there as well. And we can actually assign different permissions to these groups. For example, the network administrator can have permission to execute CMD as administrator. So these permissions can be actually tailored. To manage the groups, there is a small utility. You can just on the task bar, you can type local user manager.msc and a screen just like as shown in the slide will open up. And here you will see a number of users. There are some users, if you run this command on your PC as well, you will see a number of users as well. Because there are some default users, for example, the guest user is default, the administrator group is default, although they may be disabled. For example, the guest user will be disabled. You can just enable it from here. You can just make groups here, add users to the group from here as well. So this utility local user manager.msc is used to manage users. Then we saw the different command line interfaces that are available to us. CLI is available, cmd.exe. Similarly, we have the PowerShell. They are used to execute commands on shell. We just are not going into detail of the command line. And then there is one utility that is often ignored on the Windows, that is Windows Management Instrumentation WMI. It is used to remotely manage a device by an administrator. So what happens is that WMI is enabled on different PCs in an organization, and the administrator, while sitting in his office, can connect with WMI to any PC in the environment, and he will get a CMD on that. It is a command line utility that he will get, and he can just manage it. He can change the configurations from it, and he will have overall complete control over that PC remotely while sitting in his office. So similarly, from the attacker point of view, it is also very important, because if an attacker can get access to WMI interface, he can just uh, run different commands over there. For example, he can just add a user, he can just backup and restore, he can just change any security settings, or he can just change the password of a user and try to log in. So we need to be aware if WMI is enabled on your PC or not. And WMI, if you check on Google, WMI port, it runs around on 135 port and port 445. So these are the ports are the same that is utilized by the file system. So it becomes very difficult to identify if WMI is running or not, and you need to manually check the details. The second tool that an attacker normally uses is the net command. You can also use this command to list down the users, groups, and different configuration settings on your PC. For example, run CMD and use the command net help, and you will get a list of all the commands that can be run. And you can use different commands like net accounts to set the password, net session, net share to check for managed resources. Similarly to if you want to start a network services or stop network services, you can just use this command line utilities. These command line utilities are essential because in most of the cases, when an attacker gains access to your system, he will be using these utilities uh, because normally he gets a command line access and not the graphical user interface. So he will be using these utilities, and we must know what can be done with each one. Then we have the task manager, which we saw that it provides a lot of information about the software that are running, and there are a lot of tabs. For example, uh, there are processes tab that lists all the processes that are running, performance that gives an overview of CPU, memory, and disk, history, startup. Startup is important. I will advise you to just check uh, what services are running on your PC and disable them if you feel that it should not be running. For example, I disabled Grammarly on my PC. Similarly, you can disable any service that you see should not be run when the system starts. Then you can also see what users are logged in your PC. If it is a multi-user system, you can actually make out if some additional user is there. There is some details tab, services tab, and everything is there in the task manager. Then also we saw the resource monitor. It is there to give you detailed information about the processes. So if your computer is not behaving properly or is slowing down, you can just come here in the resource monitor and check which processes are using much of your hard disk, CPU or network or RAM. So it has 5 different tabs. The CPU, which lists down the process ID, the number of threads which process is running. If there are a number of threads that have started by a process, it also means that there is something wrong with it. Similarly, you can actually check the average CPU utilization. You can check the statistics data about how much each process is using the RAM, the disk allocation, the network allocation, the read and write things as well. So you can actually just make out these things. Next comes the networking part. Uh, in Windows, the Network and Sharing Center is the main program that handles all kinds of networking, including the local area network that is connected through Ethernet as well as the uh, wireless connectivity that you connect with. So if you want to share some files here, you have to come here and enable the sharing process as well. Once you connect with it, you can also come here and check if something is configured properly or not. For example, if your computer is able to get an IP address or not, and you can check different options for your network adapter. For example, uh, you just right click on this Ethernet adapter, go into the properties, and you will get something like that. Here you can check IPv4 settings. If your computer is not getting properly internet or you're not getting internet on your PC, you can actually come here and check what settings are enabled. For example, if you click on this IPv4, you should see something like that. If your PC is configured to use the IP address, static IP address, you should have to manually configure it here. Some organizations limit you to use one IP address and do not automatically allocate you the IP address. So you have to manually configure the IP address over here. You have to select the option, use the following IP address, and then you do all the configurations here. You have to specify the IP address, subnet mask, and default gateway for sure over here. So next, there are two utilities that are NSLOOKUP and NetStat. We know that DNS, domain name system, is used to translate the website addresses to the IP addresses. So if you want to know whether your PC has the actual IP address of some website, or if you want to know the IP address of some website, you can come here and just do nslookup cisco.com, and it will tell you about the IP addresses. Similarly, for the NetStat, it lists down the same IP addresses, the foreign addresses, and on which port the connection is established or listening. So NetStat is a command line utility, and TCP view that I showed you in the start is a GUI based utility that can be used to check uh, the actual network connections. So sometimes we have shared resources over a network, especially in the enterprise networks, we have some shared files. So what we do is that we just use this naming convention, server name, share name, and file, and we can actually get the resource. So once you just enter the server name, its query is also resolved with the help of a DNS. The query is sent to the DNS to find its IP address, and if DNS is not working, then NetBIOS protocol that also functions on port 135 and 445 by default, it comes into place and gives the IP address, and then the shared is accessed. So this is SMB protocol that comes into play while we are accessing some shared files or folders over the network. Similarly, for remotely accessing a system, just like WMI, I told you in the start as well, which is a command utility, to access it as a GUI, we have remote desktop connection. So you can enable it. It functions on port 3389. I showed you that the port was opened on my PC. So now anyone can use this remote desktop connection, and it is this application is available on every Windows system by default. So you can go into the search bar and search for remote desktop connection, and it will open up. Now you can enter the actual IP address and the username that you want to connect to. So you must be having some username and password for the remote system to able to make connection to it, and some GUI based interface will open. So it is the native Windows client, just like if you're using TeamViewer or some third-party softwares like AnyDesk. This is the native client that you can also use. What it is a licensed one. So if you have Windows Pro version, Windows 11 Pro, only then you will be able to make a connection over the internet. Otherwise, you can use it to make connections over the local area network mostly. So if you, for example, in an enterprise, if an administrator wants to get a remote view of a computer within an organization, he can use this one as well without any internet connection using local area network. The Windows that we install as a user are mostly desktop installations, but we do have Windows server flavor as well that we can install, and we can host different services on it. For example, we can host a web server on it, we can host a file sharing server on it, and it can be used to host an Active Directory server, which is used for remote authentication. So we have Windows Server 2022, Windows Server 16, and it all started from Windows Server 2000. Now let's just discuss something about Windows security. So NetStat, we have seen many times that it lists down the connections that our local PC is making with the remote site. So if you examine NetStat and you see some program is running, you can then copy the name from here and open Task Manager and see the process ID of that process, and then you can just kill it from there, and then you can just try to eradicate it completely from the system. Similarly, if you observe something that has started a reverse connection, you can just open Task Manager, go into the Startup tab, and see if it is there, if it is listed there as well, and just disable it. So these utilities can be used in conjunction to stop any malicious activity. We can just open our command prompt with administrator privileges. We need administrator privileges because we are just actively monitoring the connections, and then we can run the command -abno, and it will list down all the processes and process IDs as well. Now these process IDs can be useful because you just copy it, open the task manager, and then just see it. Other thing that we can utilize if some incident has occurred on your PC or not is Windows Event Viewer. Whenever there is something happens on a Windows, for example, if some user logs on, or if even if you enter a wrong password, it will be logged in, and everything is available in the Windows logs, and you can use Event Viewer. Just search for Event Viewer on the taskbar, and you will see a screen like this. So here we have two categories: Windows logs and application and services logs. And a built-in custom view of Windows events is also available, which shows all critical error and warning events as well. But we are mostly interested in the security events that are found under the Windows logs on the first tab. So these contain the actual logging in attempts by any user. For example, if someone is brute forcing SSH or RDP protocol, then there will be a lot of uh, wrong password events that will be stored over here, and you will be able to judge from which source IP wrong attempts are being made and at which time. So you will be actually judging it. Then there is a Windows Update Manager. So Windows actually updates now and then and just patches zero-day vulnerabilities. And if you are using Windows 10, you must be getting some notifications that the support is finishing on in October. So Windows 10 will no longer be updating. That's why you have to shift to Windows 11. So if you're not getting the updates, it means that you are actually just will not be secured, and you will not be getting the security patches to just patch the zero-day vulnerabilities, and your system will be vulnerable. So it's essential that you keep the Windows update enabled, and you just install these updates as and when they arrive. Then we have a program called Local Security Policies. So this is just to enable or disable some rights for the users. For example, you can just add a policy here for the minimum password length, or you can add a policy that the password of any user, of all the users, must expire after 60 days. Or if it is a multi-user system, you can modify a policy of a user that he should not be able to run PowerShell or command prompt. So this all can be judged, or it all can be set from this local security policy editor. Normally we do not use this, and it comes useful once our computer is joined with an Active Directory server in an enterprise. Then an administrator can actually manage these policies remotely from the Active Directory server. So there are a number of policies, for example, the password guidelines, etc., the firewall rules, user rights, and ability to restrict the files that a user or groups are allowed to run with the app locker. So everything, you can find policy for everything that a system can do over here, and you can enable or disable it. Then is the Windows Defender that comes built in with the Windows 11 and Windows 10, and it gives you a little bit protection about antivirus, adware, and phishing and spyware. Although it works well, but usually we also have some third-party antivirus. But once you install a third-party antivirus, Windows Defender is automatically disabled. So at one time, only one antivirus will be functioning. Either your third-party antivirus like Norton or your Windows Defender that is inbuilt. Now, it is very essential to know that, for example, if you have a Norton antivirus and its license got expired, so Now, what is happening is that neither the Norton antivirus is providing you the protection nor the Windows Defender is enabled. So better is to uninstall the Norton if it is expired or if it is not working properly and rely on Windows Defender. So it is a complete free software, but you can also install antiviruses from McAfee, Symantec or Kaspersky. Then there is some firewall also that is available on Windows, and it is able to just block the access from some IP addresses. For example, you can modify here some rules, outgoing rules as well and incoming rules as well. For example, someone from these IP addresses must not be able to access my PC. You can just modify the rules and turn it on, and now those IP addresses will not be able to access it. Similarly, we can have an outgoing rule here as well. For example, if I want to just disable access of Facebook.com, why not just add it to some kind of restricted IP address list? You get the IP address of Facebook.com server and add it here. So this was Windows module, and just give me 2-3 minutes where I upload the slides for Linux module for the next module here as well. So next module is regarding the Linux basics, and I hope you have installed the Cisco CyberOps VM. Shiraz, were you able to install it?
Yes, I did that. The first software, which the Oracle VirtualBox,
Yes.
I am operating in that system. I install that file. I import that file in that system, Oracle VirtualBox, because it was not
Oh,
working in VMware workstation.
okay, that's good. So,
Yeah, it's only working on VirtualBox anyway.
Yeah.
okay, I have installed it on both. It's working for me.
Mm.
Okay, now let's start the Linux module. And Kali Linux is one flavor of a Linux software. So it is an actual operating system that was created in 1991, and we have around hundreds of flavors for it because it is an open source software. No one actually controls it. Uh, so anyone can modify its code and publish his own version. So that's why we see different operating systems that are based on Linux. So not only Kali Linux, we have Parrot OS that is based on the same Linux flavor. Uh, the Cisco CyberOps VM that you just set up is based on Ubuntu that is also open source. Similarly, your Android mobile phones are actually based on Linux software. Similarly, our different IoT devices, for example, the routers, switches, the underlying architecture is basically a stripped down version of Linux. So it is actually a set of software that is open source, which you can just actually modify them and set up as your own requirements. And that's why we see it around everywhere. So the value of Linux comes from being open source, so any person can acquire Linux at no charge, modify it. Similarly, its CLI is very powerful. The Linux was actually not designed to be used as a graphical user interface operating system. It was designed to be based on CLI, so its CLI is very powerful, and administrators and other users can actually utilize it to perform different utilities. And the user has more control over the OS. So he can just uh, move it as a escalate a privilege as a root user and then just play with the kernel or other operating system stuff as well with using the command prompt or play with the drivers while remaining in the command prompt as well. Moreover, you also have better network communication control as well. For example, once we were doing Nmap scanning, we were able to do the SIM scan or advanced type of scans by just escalating our privileges to sudo, and we do not have to modify each packet manually because in the background, Nmap had access to system resources or the system network communication protocol architecture, and it was able to modify the packet headers in the background itself. So it has more control. It provides more control over network communication as well. So in the security operation center, Linux is very important because of the flexibility that it provides. Similarly, a the other VM that we have not yet downloaded and set up is Security Onion. That is a special version of Linux that has all the tools of Security Operations Center already set up. We will be utilizing it in our last modules as well to actually interpret different events. If you see in the screenshot, these are all the real-time events that are actually being detected by the SOC software that is running on the Linux operating system. So we have one version of Linux called Security Onion that has all these tools built in for us, and we do not have to do anything else. So what tools we need once we are operating a security operation center? First we need is a network packet capture software. So to analyze the packets, you should be having a copy of the packets as well. So one software is Wireshark that should be able to capture all the traffic. Similarly, uh, there are other softwares as well like T-Chart that can capture network traffic and provide insights into the actual flow of data. Similarly, No, we require some malware analysis tools as well to safely execute the malware and see if it is some kind of malicious software or some malicious activity is going on. So we need some malware analysis tools as well. Third tool that we need is some kind of IDS. So what connections are being made to systems and whether these connections are legitimate or malicious, this will be detected by the intrusion detection systems. Then we need the firewalls, the log managers, because we will be collecting a lot of events from different organizations. So once there is some SOC software like SIEM solution that is running on our Linux server, all the systems that are there in the enterprise, they will be sending their copy of the logs to our main server. We saw in the last lecture that Windows Event Manager, we have some security logs. So once some SIEM solution is configured on the network, all Windows systems, the Linux systems, the routers, switches will send a copy of their logs to these SIEM solutions. And so we are getting a lot of logs. So we need some log managers to actually store the logs in some format so that they can be correlated and utilized as well. And the SIEM solution is the main software that will provide the real-time analysis on these alerts and log entries generated by our different systems and devices. Then we need some kind of ticketing system, which in the first lecture we saw that there are different tiers of SOC analysts, like tier 1, tier 2, tier 3. So they require some ticketing system. So tier 1 analyst will mark an activity to tier 2 if he feels that it should be escalated. Similarly, the tier 2 analyst will mark it to tier 3, and then these alerts will need to be closed as well. So we need some kind of a ticketing system as well. Then we need a lot of other tools as well. For example, if we are going to perform penetration testing, this is a screenshot of Kali Linux that we have packet generators, we have port scanners, we have proof of concept exploits, and there are a number of tools as well that we can utilize. So we have been using Kali Linux as well. So the commands are approximately the same in all distribution of Linux. So this is a screenshot from Cisco CyberOps VM. So if you want to check the username, which uname or the system name as well as the architecture, you can just run a command uname-a and it will list down the architecture. That is a Linux computer. Ubuntu is there, current time is this. Similarly, we can run commands like ls-l documents. It will list down all the documents from here. And these are the different commands that we have already been using, and some we will be using in our next lectures as well. Move command, copy command, change owner command. These are the commands that are there in the Linux system. You do not need to actually remember them all. While you are using it, you actually just search for it, and then after some practice, you will start remembering these commands. Important ones are sudo, that is used to escalate the privileges to the root user if you are just doing some process or you are running some process that requires administrative privileges. Then ifconfig command is used to check the local network configuration, for example, the local IP addresses that are provided to your interface. Shutdown command is used to shut down the system. iwconfig command is used to check the wireless network card information. For example, the ifconfig is used to list down only the IP addresses, but if you want to know more information about your wireless interfaces, you can use the command iwconfig. And this apt-get is used to install any software. So installation of software in Linux is very simple. You just use the command apt-get and you mention the software name and it will automatically be installed. You do not know to actually go into internet, download it, and then double click to install it. You can just install it with just simple one command apt-get and nmap will be installed. Similarly, we have different commands like change password. We use the password command. Cat is used to list down the contents of the file, and man opens the help page. These are some file and directory commands. ls is used to list down all the files. cd is used to change the directory. We have make directory command, copy command, move command. rm is used to remove the files. So these are the file and directory commands. So as we will be using Linux, or an attacker will be using the Linux in the command prompt mostly, so we need some ways to actually edit the text files as well while remaining in the command prompt. So while we do have some GUI based editors as well in the Linux, but the most popular ones are the ones that we can run while remaining in the command prompt. And one of the most popular one is the nano editor that you can actually run. And this is very important because if you only have, for example, you have SSH into your victim machine, you do not have the GUI, you just run a nano and you can just make a file, you edit some text files over here, over there, you can copy the hashes from there and it will help you to actually edit the text while remaining in the command prompt. Similarly, you know that we can actually play with the system files as well. For example, if you have got access to a victim machine and you want to actually change the DNS settings, so there is one file called etc host file that contains the manual configuration about which IP addresses points to which website address. So you can actually go in here, go over there, and you can edit this file, add facebook.com, and add your phishing website IP address over there. So automatically the user will be redirected every time to a phishing website if you change the manual entry in the etc host file. And you can do it while remaining within the command prompt using these command-based editors. This is the layout of it. It contains a list of IP addresses and the websites that they map to. So Linux is actually a client server based, works on client server based model. Most of the servers in the real world are based on Linux. Approximately 90% of the servers are based on Linux systems. So and these servers will be providing different services over the internet. For example, email server, file server, a web server. So they will be providing these kind of services. For example, most of our websites are hosted on Linux-based servers. And these servers can be accessed on different ports that we saw earlier as well. If it is a FTP server, it will be the port 20 and 21 will be opened. If it is allowing secure shell SSH access, the port 22 will be open. If telnet is enabled, port 23 will be open. And we can have mail server as well on port 25, a DNS server as well on port 53. And these are the different common ports that we often see on Linux servers. These are all the ports as well. So depending upon the configuration or the services that administrator has enabled, we can see different ports. Then we have the client software. Just like our browsers are web clients, just like Chrome and Firefox are web clients that can access a web server, we need different clients to access different type of services. For example, if we want to access FTP server, we need some FTP client. If we want to access SSH service, we need SSH client. So these are the different clients that we need. And we can install these clients on our Linux based systems as well with apt-get command. So as you know that now all the servers are mostly based upon the Linux systems. So there will be a lot of services that will be running on the servers. So in Linux, everything is considered as a file, and each service will have some kind of configuration file, which will list down the settings, for example, the ports, the location of the resources, and authorization details. For example, you can find authorized users that are able to access telnet. So everything will be given in the configuration files. And if some server is running, for example, in the screenshot, Nginx server is running, that is a web server, you can just Google the default location of the configuration file. Otherwise, most of these configuration files are located in the etc directory on the Linux host. Similarly, this screenshot indicates the configuration file of network time protocol. It is also located in the etc directory. It lists down the servers that your system will access to get the local time or the updated time. So mostly these configuration files will be in the form of option is equal to value format. For example, a web server IP address that maps to some IP address. Similarly, if something is enabled or not, for example, a user, and you will see its option like enabled or disabled. This screenshot is from Snort. So if some port is enabled or disabled, you will see a port number over here, and then in front of it, it will be written enabled or disabled. So from the defender point of view, if you are running a lot of services, then we need to harden the devices. So we need what methods we can utilize. We can actually just make the configuration for the password that we can define a password policy that the minimum length is this and it should expire at this time. We can configure or disable remote login features. We can disable the vulnerable services. For example, we can say that telnet is always disabled, but if you want the remote access, you have to log in with SSH. Similarly, you can just enable or disable the system services, and operating system updates are extremely important to maintain a hardened device, as we already know. as these updates contain security patches and fixes that should be always be done. So these are a few basic uh, practices that must be followed. For example, we have to ensure physical security. We have to minimize the installed packages. It should not happen that you are not using some utility and you just install it there. For example, if you are not using some utility like Microsoft Word or Microsoft Office, with time, its vulnerabilities will be discovered. And if you are not using that software quite often, you will not actually know that what damage that software is causing behind the scenes. So you must always check what services or what softwares you have installed in your system and whether you actually need them or not. If you do not need them, just remove it. Similarly, you should always use SSH and should not use Telnet. You should use the keep. You should always keep your system updated. Disable USB auto detections and auto runs. Enforce strong passwords and always force periodic password changes and keep users from reusing the same password again and again. So there are all, just like in Windows, we also have log files on Linux, which are categorized as application logs, event logs, service logs, and system logs. So there are a number of these log files as well. We will see a few of them. For example, this messages log contains the activity information. If some user logs in, logs out, we will see the information over here. Similarly, auth.log that involves user authentication mechanisms. For example, if some user is using SSH or not, secure log is enabled, auto logins, boot log, boot information. So there are different type of log files over here, and the major folder that we see is where log folder. So all logs are over here by default. So this is a screenshot from messages folder, and each line represents a logged event, which is given with the help of a timestamp. So each event starts with a timestamp, and then the detail of the event is given. Now let's just see some file systems that are used with different systems. So first we had this ext2 file system that was the default file system in major Linux distribution. Now it has been phased out and it has been replaced with ext4 system. So ext3 was also is also an old system. Now we see the partitions that are formatted with ext4 file system. Then there is a network file system that allows sharing of files over the network. Similarly, we have the CDFS that was used for optical disk media. It is actually in use with all the CD disks that we see nowadays as well. So they are formatted with CDFS file system. Then we have the SWAP file system. It is used by Linux when it runs out of the RAM. So Linux has a facility that it can dedicate a partition as the swap partition, and it can use that partition as part of RAM. So if your system has a little bit less RAM, you can make a swap partition, and that will be utilized as RAM as well. And once the content in the RAM exceeds its limit, it will be moved back to the swap partition, and only the active content will stay in the RAM. Then we have the HFS file system that is used by the Mac systems. And Mac is also based upon the Linux architecture. So everything starts from the Linux architecture and is built upon it. Around 90% of devices utilize the same things. The iPhone, the Mac, everything is based on Linux. Then we have the MBR that we see in the Windows. So these were the different types of file systems that were there, and Linux is very flexible. So it can mount file systems of different types. For example, you just remove a hard disk from your Windows system, attach it with your Linux system, then there are different commands with the mount option that can help you to mount it as a folder, as an additional folder in the Linux computer as well. So we have the mount command that helps us to do it. In Linux, everything is a file and the permissions are defined in three categories: the user, the group, and uh, all other users over the file system. For example, if you run the command ls-l over this file space.txt, the first entity or the first entry will tell us that whether it is a directory or a file. If it is vacant, then it is a file. If it is a directory or a folder, a D will be written here. Then the next three characters, read, write, and execute, this RWR will tell us that the owner has all these three permissions, which are read, write, and execute. Then the next three entries, read, write, execute, is telling us that the owner's group has these permissions over this file. For example, this in the screenshot, the analyst is the real user or the real owner of this file, and he is member of the group staff. So analyst has read, write, and execute permissions over this file, but the group staff has read, write permissions, but they do not have the execute permissions over this file. And then the last three entries uh, gives us the permission of rest of the users. For example, the rest of the users can only read the file and the rest are not enabled, which are given by dash dash. So this is how the Linux stores the permission, the owner's permission, the group permission, and the rest of the world permissions. So the first dash means the file. This is a file. The first set of characters, the first read, write, execute is for the user's permission, for the owner user permission, and he can read, write, and execute the file. The second set of characters is for the group permissions, which is given as read, write, dash. It means the group staff owns the file, can read, and write to it, but he cannot execute it because he doesn't have the execute permission. Then the third set of characters is for other users or for the rest of the users, and they only have the read permissions. They cannot actually write it or execute it. These are also given by numbers. If it is 0, it means it has no access. If it is 1, it means it execute only. Write only, it means the 2. Read and write execute, the 3. So we actually see this representation as well. So if we see 777 as a permission mentioned for a file, it means everyone has read, write, and execute permission for it. Then there are hard links and soft links. These are just like shortcuts in Windows. So symbolic links are created with the command ln, and you have one file and you can have a shortcut to it. But in Linux, there exists a hard link as well. What is the hard link is actually a shortcut to the actual memory location or the hard disk location. Even if the original file is deleted, uh, even if the original file is deleted, the shortcut can still access the original content from the hard disk. So there are two actual link types. If you use -s, it will create a soft link. If you do not use the -s flag, it will create the hard link. And the hard link shortcut can actually directly access the hard disk and retrieve the content from it. So this table shows the actual benefits and differences. So locating hard links is actually difficult because they are actually linked to the hard disk location, the physical location, not the actual file name. And we can actually list down the symbolic links by ls-l command, and we will see what shortcut links are available. And hard links are limited to the file system in which they are created, because we are actually mapping the physical location of the hard disk. So they are, if you copy the files over, so they will not be applicable. Now let's see a little bit about Linux graphical user interface. So the graphical interface present in most Linux systems is based on X Windows system, also called X11, that provides a basic framework for GUI. And then we have different tools installed over this system that are called GNOME or XD Desktop, that runs on top of this system and provides a graphical user interface. So this is the left screenshot is from GNOME Windows Manager, and the right is from KDE Windows Manager. So on the same system, you can actually switch between KDE and GNOME category of desktop. These are different packages, and your complete desktop experience will change. This is the main Ubuntu interface. Just like that, we have the F menu, the top menu, the task manager here as well. So over the time, the Linux have adopted a few uh, graphical properties of Windows and incorporated them in their graphical user interface to be able to just facilitate the users. So these are just different things in the graphical user interface. Then let's just see how we can install and run applications on a Linux system. I told you that installing software on a Linux is very, very easy. More easy than the Windows system as well. You can just use simple command apt-get command and just list down the package name and the command, and it will install the software. So we are on Debian Ubuntu. We can use the commands apt install, apt remove, apt get update, or upgrade. Upgrade is used to upgrade the complete Linux, or update is used to update the packages. In the GUI based interface, we also have a Linux updater as well, but normally we are using apt upgrade command to upgrade our complete software. So a process is any program that is running on a system, and forking is a method that a Linux kernel uses to allow a process to create a copy of itself. So in a multi-user system or a multitasking system where there are different processes running, for example, a Word file is opening, a document is opened, a text editor is open, uh, uh, Paint is open. So these are the multi processes that are running, and these processes may be doing different tasks at one time. So they will fork. For example, once I showed you in the Windows the task view, we saw that only I opened only one Chrome browser, but there were around 10 Chrome processes listed in the task manager. So what is happening is that the Chrome is making a copy of itself and has shifted some of the uh, requirements to the other process. For example, if I open a new tab, a new fork will be created that will be independently handling the RAM and CPU processes and user input. So we see a fork and we see different forks of the same process. And actually, these forks are somehow independent processes but are listed as a group in the task manager. So in Linux, we can use a command called ps that will list down all the running processes. Similarly, we can use this kill command to kill any process. The top command is used to just sort the running processes that whatever is utilizing the maximum amount of CPU should be listed on the top. So here is the output from the top command. And anything that will be utilizing the highest number of resources will automatically come up in the output. So it is a misconception that viruses do not affect the Linux systems. Although the number of viruses, trojans that are designed for Linux systems are very less, but still we can see a little bit of viruses or worms that may be affecting us. We have different utilities in the Linux as well to check for these viruses. For example, we have the check rootkit utility that can be used to automatically check whether there is some uh, rootkit that is automatically installed in a system. Then we have something called the piping. We can use the output of one software or a one process as an input to the second process. For example, here we can use ls-l and then we use this pipe symbol and then we can use the command grep host. So from the output of ls-l, grep will automatically filter out uh, the command that will contain the host word. So we can actually combine different commands within while remaining on the command prompt and pipe output of one to another input. Okay. So we were actually on the Linux module. Actually, we finished the operating system section. So just going to go a bit faster on the labs because we have already done these in the ethical hacker course. So these are just some how we can navigate the Linux terminal. So have you installed this uh, cybersecurity lab VM? This one?
The one you told us before last week, I think.
Yes, yes. It's the
Yeah, yeah.
Ubuntu base. Yes. It's based on Ubuntu, just added a few stuff. The Cisco has added a few stuff here and there, added a few tools. So it gives us a nice flavor. This is the actual based on Ubuntu, and Ubuntu is the most used Linux operating system in the world. The Kali is used for pen testing, but Ubuntu is used by the normal clients or normal users.
Right.
So the commands are same, just like in Kali Linux, the commands are same. If you want to check your present working directory, you type in pwd and it will tell you what is your current directory. Similarly, you could have opened this analyst home GUI based folder. It is the same folder here. Get the home folder. And to list down the files, we type in the command ls. This lists down all the files, but if you want to get more details, we have the option to add -LA flag. Okay. Now this LA flag also lists down the hidden directories. So, and anything that starts with a dot is hidden by default on the Linux system. So these are all hidden directories or files that are hidden and can only be seen if you type in this -LA command. And as per our tools, getting help is very easy. Normally, what we can do is we can type in a command and type in -H. It will list down the help menu. Just type in -H with it, or if you want to type in the complete help, you can type in --help, and it will also list down the help menu. So there are two methods to get help. The simplest, the short help, that is nmap -help or -H. Normally they work, they both work. But sometimes if you want to get a detailed manual page of some command, for example, if we have a command called copy, and we want to know all the parameters that it can support, and we want all the manual pages of it. We also have one command or tool called man. You type in man, man, that stands for manual, and you type in the command. For example, copy, and it will open up the complete manual of that command. It will be very detailed, explaining everything about uh, uh, a tool or a command that can do. So we can type in man ls, and you can see that -A stands for all, -B is for escape, -C what it can do, -D is for directories. So we can actually go through it in complete detail if we want to get some, we want to read the detail of some tool or a command. So it comes pre-built with Linux-based systems. Similarly, we had a command to make directories called makedir, and we can type in new folder and it will make a folder. If I type in ls, you will see that new folder has been created. If I want to move into that folder, I can type in cd, which stands for change directory, and I can move into that folder. And if I want to make a file here, I can use different editors, and the basic one is Nano, and we can type new file .txt. What it will does is it will create a new file with the name new file.txt, and it will open an editor where we can just add some text or add some details. Just like that, it has opened a new terminal where we can type in some text. For example, we can type it is a new file. To save it, we have to press Control plus O, and it will ask you whether you want to save it to file or not. And if we press Enter, our text will be saved in the file. And to exit it out, we have Control X. If we type ls again, you will see that new file.txt is available here. We can also see its contents on the screen with the cat command. We can type in cat new file.txt and the text will be here. Okay, now we also have a small tool called echo. If we want to append something to a text document, for example, this is the second line, and you can just use these symbols, greater than symbols, and type in the file name. Okay, what it will do is it will automatically add this line after the first line. Let's just try it. And if we try to read again, and you can see it has been appended to the original file. So this echo is very helpful once you are doing something very fast and you need to just append some password or some text, short text to the existing file. For example, you may be having a word list of passwords and you want to add or append a new word to it. For example, if you want to add a word to RockQ dictionary, you can just echo it out and save it.
Amar, by default, yeah, if you make dir, which folder are they going to?
I don't think so.
When
It will make.
not like Windows, isn't it?
Yes, it's not like Windows. It will ask you what you want to create. It will create a folder where you are here in the terminal.
Okay, wherever. Okay, yeah, got it.
Yes. So if I'm in the new folder, it will create the folder here.
Inside the new folder, yeah.
Yes,
Okay.
yes. So if you want to move back, you can just type in cd double dot. You can check current working directory. And actually, if we move into the root, we can do it by cd /. And if we do ls, these are the actual folders on the Linux operating system that sits in just like in the C directory. We have Windows or user folders. These are the main folders in the Linux system. And for example, our configuration files normally are there in the etc folder. Some user configuration files are in the user folder, and so on. For example, there may be some logs that may be in the opt folder or maybe in the war folder. We will also see those. So this is the actual root directory over here. If we want to move back to our home, we can use this cd and this tilde sign that is just beneath your escape key on the keyboard, and it will automatically move it to your home directory. And you will see here as well that this is home directory. If you are seeing this one, this forward slash, it means you are in the root directory. So at one time, there are a number of processes that are running on our Linux machine. These Linux servers are deployed everywhere. Normally, you are using Windows as client systems, but most of the servers, 70 to 80% of the times, they are based on Linux operating systems. So it means that many users will be logged on to these systems and doing different stuff. And if we want to know what currently is being run on any system, what we can do is we can type in the command ps-elf. Okay, if this is ps is the simplest command that tells us what processes are running, and let's see if we can. Okay, this elf should be working. Okay, this is not working here. Maybe on the current if it will work. But the ps is the one command that you can run and see what processes are running. For example, we are in the command prompt and it is telling us that bash is running and this is the process ID 1637. And if you want to kill any process, or this is just like the task manager where you have the IDs. For example, if I can directly kill or exit out a process from here, I just need to give it ID. So now if I press enter, it will try to terminate this process 1637 and our command terminal will be closed. Okay, it should have been closed, but it's not closing. But it is how it's working because we are in the same terminal. Maybe that's why it is not closing. Otherwise, we can just close everything from here. Just you type in kill and this command and it will close down. Similarly, let's just try other flags for this command. This is ps-ejh. What it does is it lists down processes and their sub-processes in a tree-like formation. What I mean to say is that if you look here, this is the main process and these are its child processes. Sometimes once you run a program, it spawns different processes as well. So these are all that are spawned by it. For example, we ran bash and we type in the command sudo. It also executed another process called sudo and then it ran this ps. So this is how the hierarchy works. So this also shows us if some process is spawning another process, and we can also use it to trace any malicious activity. That if you open Microsoft Word or some text editor and it spawns some bash terminal, you immediately know that bash is not supposed to be started by some word editor. So it can help us to trace any anomalies as well. And these are the different things that we can see. Then we already know the netstat command. It lists down all the connections coming in or coming out or going out. We are interested in these that are listing. So you can see that this VSFTPD is listening, the user has been, this SSH is listening, these 3-4 processes are listening. And if there is some malware in your system, it will also be listening here. And if some connection is made, you will also see that. So it is running on port 22, it is listening on port 23, it is on port 21. So you can just check which processes are listening on what ports. And you can just kill those if you see that these are dangerous or these are not required. So this is FTP, that's why it is running on port by default on port 21. Okay, sometimes if some process is listening or there is a server, just like in ethical hacking course, we saw that there was some telnet server, and if we want to connect to it, we can use the simple telnet command. You just give its IP address and the port number, and it will try to connect with it. For example, now I have tried to connect with this IP address, which is my own local host IP address. And because Telnet service was running, SSH service was running on port 22. And so I tried to connect with it and it gave me this information. Now, this information is very important because it is revealing the banner of the service that is running. And this is the same banner that I will uh, utilize to find out other vulnerabilities of the system. So, for example, I can just go into search exploit and search for search open exploit open SSH 8.9 P1, and it will list out all the vulnerabilities of this system. So we can utilize Telnet utility to connect to any port that is listening and try to grab the banner. Similarly, there are many log files that are stored on our Linux system, and we are mostly interested on the files stored on the other server logs. So the logs are mostly saved in this war folder, and there are different type of logs depending upon the servers on the server and the services that are currently running. There will be different type of logs that will be saved there. For example, this log stash dash tutorial.log is a log from a web server. And if I press enter, you will see that who has attempted to get which resource from your server. For example, this lists down all the IP addresses, at what time someone tried to access it, and which resource they were trying to get. And you will see that they were trying to get this website address and which client they were using. They were using this web spider. It was some kind of web spider that was just spidering out the complete internet, and it just happened to uh, crawl your website as well. Similarly, if you're looking for some specific client, you can sift through it. For example, here some iPhone just opened this page on this date and from this IP address. So we can just scroll it down, sift through it, and see who is trying to access which website. Similarly, once you are accessing some website, you are just sending out your data of your client, even your iPhone model, your client, your operating system version, and your browser version. And that is logged on the server side as well. So there are different kinds of logs. Every application has logs, some log file associated with it. And these are the logs that are utilized to get to know if some attack has occurred, and we try to find the source. For example, this is the log file of this is configuration file of Nginx, and it uh, can reveal sometimes it can reveal the log files where it is storing the logs. For example, here you can say that it is storing the access log at this access.log file and error logs at this file. So if even if we don't know the exact location of a log file, we can try to find this configuration file in the etc folder and then try to see where it is storing the logs. And then we can just go through these logs. And these are the same logs that are sent to some SIEM or SOAR solution. And uh, uh, basing upon these logs, these SIEM solutions generate alerts. Similarly, if you want to just check a few entries from the log file, for example, if you want to check this access.log file that we saw earlier on here, and we want to see the last entries from here, we can use this tail command. And if we press enter, let's see. So there is nothing in the logs for now because no one has accessed it. If someone has accessed it, we will see the entries here. So here, so in this manner, you can just go through some logs and see what is going on and who is accessing your website. Okay, the next module is regarding the network protocols. So have you gone through some introduction to networking course or the CCNA before coming to ethical hacking?
I know a little bit. But this
Yeah,
is
just
while ago.
just little, yeah.
Okay,
Not much.
okay, this contains nearly the same information from those courses, just to give just it's a reputation. So we have networks of different sizes. They range from simple home networks. We can just have ad hoc networks as well. We have small office home networks, and the businesses and large organizations also use their own networks that may spawn over different cities or countries to just exchange different information. So, uh, and once and the largest of them is the internet, that is the network of networks where everything gets connected and the information is exchanged. So, everything that is connected to a network, we classify it as a host or end devices, just like our computers, mobiles, or devices. And the servers are computers with excessive amount of hardware that can provide some services. So a client are just simple computers, and the servers are just computers with heavy resources and that can provide some service. For example, you can see that there are web server, file server, or email server. These are different servers, and you have different software that are installed on the host system. Like if you want to access the web server, you need to have a web browser like Edge, Chrome, or Firefox. If you want to access an email server, you need to have some Outlook application or some mail application on your host system. So you need specified applications on your host system, and that will just fetch the information from the server and display it on your client. And these servers will be listening on specific IP addresses or AND ports. If if it is a file FTP file server, that it will be listening on port 21. If it is a web server, we connect it with it port 80 or port 443. And if it is an email server, then we can connect with it port 25 or just like that. So these servers are listening on different ports, and you as a client make connections to it uh, using that specified IP address or ports. Similarly, you just create a session at school, at while gaming, you need a server. These are just small things. And this is how a network should look like, or how the internet looks like. There are different technologies that are involved while a data transmits from client to a server. Now, it is independent of the media type that is there. For example, there may be multiple media types. There may be Ethernet cables, there may be fiber optic cables, and there may be under the submarine cables that you hear a lot, and some connections may be based on wireless, Wi-Fi, satellite systems, but internet is not bothered about them, and it just ingests every kind of technology. So there are different tiers of ISPs, internet service providers. The tier one, there are tier one networks that are the giants in different countries. Then they outsource their resources to tier two ISPs, and that, so for example, there may be an ISP called Neotel or a PTCL, and then they may outsource it to your tier three networks or tier three ISPs like Bateen.com or something like that. So there are normally uh, different ISPs. Tier 3 ISPs will get connected to Tier 2 ISPs. Tier 2 ISPs will get connected to Tier 1 ISPs. And there will be an internet exchange point. Normally, for example, it may be in Pakistan and India, there may be only one internet exchange point where all the traffic is routed from one ISP, Tier 1 ISP to Tier 2 ISP, or different, or it may happen between two Tier 1 ISPs as well. And there is supposed to be some routing protocol that must be going on. These are all routers, similar to the routers that we see in the offices. There is no new technology here, just routers with a lot of bandwidth or a lot of capacity. So, and there are different routing protocols that are running. And for the internet, it is normally BGP border gateway protocol that is running, and that is ensuring that our traffic gets routed swiftly between different ISPs. So to send out a traffic, we need different protocols so that the sending side encodes it properly and the receiving side can decode it properly. So these are just rules that govern what type of communication we are going to carry out and how to understand that communication. So at each level, there will be some protocol or some rule that will define that how much traffic you can send, how you need to just encode it, at what format you should do it, and what will be the message delivery options, who will ensure that data actually reached its destination or not, or when do you need to retransmit it. So this is all a set of rules that everyone must understand, that is for all the entities that are involved in some communication. So so how the computer will communicate, it will be decided by the network protocols. They will dictate the message encoding format, encapsulation, size, timing, and delivery. And we have different protocols for it. For example, we have HTTP, the Hypertext Transfer Protocol that is utilized in the web applications or once we are just browsing websites. Then we have the TCP and the IP protocol. So the message structure will specify how the message is formatted or structured, how much data it will be there, and then the path sharing will define how will you actually know where to send the data once you send it. What we mean to say that we just give out the destination IP address, but how that IP address has to be reached is defined or is judged by the routing protocol. If you start from the first router, it will send the data to the next router, and then it needs to decide which router it must send to the it must send the data to reach the destination. So this information is shared with the help of routing protocols, and for internet it will be BGP. In your local network, it can be OSPF or RIP. There are different protocols that are used for sharing this path information. And we need this information because we want to just minimize the latency. We want to send our data as fast as we can. Then we need to share some information as well, whether our packet or our data reached the destination or not. If there was some error, we want to know it. So we have some information sharing. It normally it is done with the help of ICMP packets that just like pinging. Once you are just do the ping command, it tells you that whether that destination is reachable or not. This is just information sharing. And then there may be some session management. If you there may be some session management if you want to establish a session first, or if you want to just stream the data. For example, if you are watching a movie, you do not need to establish a complete session. But if you want to send a file, you may want to establish a session first so that nothing is lost. Then comes the TCP/IP protocol suite, which is the most important suite, and it defines where different layers are and how these layers communicate with each other. So it consists of 4 layers. If we start from the bottom, we have the network access layer. It contains all your cabling as well and all your Ethernet addressing as well. So your ARP protocol, the ARP protocol, the Ethernet protocol, your Wi-Fi protocol, or the physical protocols all will be working at this network access layer. Then at the next layer is the internet layer that is responsible for routing all the traffic. And here we will be having the IP addresses. At network access layer, we will be having the MAC addresses, but the internet layer works or operates on IPv addresses. We can have IPv4 address or we can have IPv6 address. Then the ICMP packets also are there in the same layer, and the routing protocols are also operates on the same layer. We have OSPF, BGP, and similar type of protocols here. So this layer is responsible for all the routing of our traffic. Then we have at transport layer, the TCP and the UDP protocols. They ensure the end-to-end delivery of the packets. Here we have the port number. If we are sending a file, we may be sending it to port 21. So this port 21 will decide which application that is going to receive your data. So here we have this TCP and UDP with their port numbers who will be ready to receive the data. If you want some connection oriented service, you use TCP, and if you want some connectionless service, then you use UDP. Next, we have the application layer where all the applications operate. For example, HTTP traffic, the DNS traffic, the DHCP traffic, the mail, file, every protocol that a client uses to send or receive data from a server operates in the application layer. So these four layers must be remembered every time. So these are different protocols that are there. For email, we have SMTP, Simple Mail Transfer Protocol, POP3 and IMAP. Simple for file transfer, we have FTP, SFTP, TFTP. These are all used for sharing the file exchange, for sharing different files. For exchange of web and web services data, we use HTTP or HTTPS, and rest is just the API that we can use to fetch the data from some other resource. So different type of protocols are there. Transport layer for connection-oriented service, we use this TCP, and for connectionless, we use this UDP protocol. At the internet protocol layer, we have the IPv4, which we normally use. Then we are just getting started with the IPv6, which uses 128-bit address. And then we have something called NAT that translates the private addresses to the public addresses that we will see in some next module as well, how it operates. Actually, we are running out of IPv4 addresses, so the solution we came up with IPv6, but as IPv6 is not yet fully implemented, so we utilize NAT to just utilize private addresses in our local network, and then we translate them into a public IPv4 address with the help of NAT protocol. Then for messaging, we have this ICMP, and for routing, we have OSPF, BGP. BGP is used for internet, and this OSPF or EIGRP, these protocols can be used within your own local area network or WAN networks. Then we have some protocols at the network trust layer, the Ethernet and WLAN, that are the physical protocols, and ARP is used to translate mapping or to provide mapping of IPv4 addresses to the MAC addresses or hardware addresses. This hardware address is actually the MAC address. So it translates IPv4 address to MAC address. So when a message is sent from a source to a destination, it must follow some form or structure, and it will depend upon the protocol that it is using, the type of message, and the channel that will be utilized to deliver the message. So this is similar to just like we are sending some postal document or some post. We have to just fill in the details like sender location, the sender details, and the recipient detail as well. So we have to fill in the complete details. Similarly, we have to fill in these details on each packet. On the network layer, the IP packet is responsible for routing it. So you can see that we have the destination IP address where our destination is, and we have the source IP address. So this is just the IP header, and these are just additional information, the version information, the flow label, and these are just additional information. But to make it work, we need these two, which are the destination IP address and the source IP address. These are the essential parts. and this will be the uh, we can say the IP layer header. Every layer will add its own header, just like that. There, these additional headers are then used to provide additional services, just like it can be used to provide the flow control, how much information should be sent, at what speed, if you are if our packets are being dropped rapidly, then the flow control can just pull out the speed. So it will start sending the packets at a slow rate. Similarly, we can make out how long the response is there. We can make out the different access methods, whether you are sending it on a wireless network or a wide media. We can actually make it out. And there are three methods that we utilize to send out the traffic. First is the unicast, that is the most used one, that we send packet to only one destination. For example, if I am talking to a Facebook server, I will be only sending traffic to the Facebook server. Then we have the broadcast. If we want to send traffic to the all hosts on the network, for example, in case of an ARP request, we are sending the request to everyone on the network that who contains or who owns this IPv4 address, then it is called the broadcast. And if we are sending to multiple hosts but not all, then it is the multicast. It is one to many delivery option. That is, and multicast is just built in IPv6, but it's normally not used in IPv4 networks. We are mostly concerned with this broadcast where we are sending packets to everyone, or the unicast where we are sending data to only one host. So what is the benefit of using a layered model? We can just add or drop protocols within this each layer. We only have to be concerned about individual layers. We don't have to just exchange or interchange everything. For example, you can keep the HTTP protocol same, but you can just add a new technology at the physical layer. For example, we received the fiber optics networks uh, are becoming popular, have been becoming popular in the latest in the last few years. So we just add them at the physical layer, but we didn't need to change anything on the top layers. So first we saw the TCP/IP model. This is the actual model that is implemented, but to make it easier to understand, we have some reference model as well that is called the OSI reference model. It is not physically implemented, but we use it to refer it and to define the services that are provided by the each layer. And if you look closely, this looks like same. In the, for example, in TCP/IP model, the application layer is there, but in OSI model, there are three layers that define these functions. For example, application layer, presentation layer, and the session layer. So the function of these three layers have been merged into the application layer and in the TCP/IP model. The transport layer is same, the network layer is same, but the name has changed from network layer to internet layer. And then in the TCP/IP model, we have the network access layer, whereas in the OSI model, we have the data link or physical layer. So these the functions of at these two layers, data link and physical layer, have merged in the network access layer in the TCP/IP model. So to just discuss the functions independently, we use the OSI reference model. These are the 7 layers from the OSI reference model. Physical layer defines the mechanical, electrical, and functional means. It means that it defines all the cabling, the Ethernet cabling, the fiber cabling, everything is there. Then the data link, we have the frames exchanging data with the help of MAC addresses. At the network layer, we have the individual packets that travel with the help of IPv4 addresses or IPv6 addresses. At the transport layer, we have the segments. It ensures end-to-end delivery with the help of port number. At session layer, just creates or manages the sessions between different hosts. Presentation is used to exchange data between different application layer services, and it is responsible for encoding or decoding of data. And the application layer are used for the process-to-process communication, for example, HTTP, FTP, etc. So this is just a brief intro to OSI reference model. Similarly, we have this TCP/IP module, that a protocol model that we have already seen. We have only 4 layers here, and rest of the layers have been merged into these. Now let's see how the data encapsulation takes place. So if we want to send a lot of data towards our target, we need to break it down. So in theory, a single communication such as video or an email message may contain large attachments, and it could be sent across a network from a source to destination with one massive uninterrupted stream of bits. However, this will create problems for other devices that will need to use the same communication links or channels. So what we do is that we divide the data into smaller, more manageable chunks, and we send them over. So we use a process called segmentation, and it is the process of dividing a stream of data into smaller units for transmission over the network. Segmentation is necessary because data networks use the TCP/IP protocol suite to send the data, and each packet is sent separately. It is just like similar to sending a long letter as a series of individual postcards. And for example, if you are sending a large file, it will be segmented into smaller chunks, and these chunks can follow different paths to reach the target. So it will not be guaranteed that every chunk or every segment will follow the same path. It will depend upon various parameters, the routing protocol, and if you're sending data from Pakistan to USA, it may follow different routes. And it provides us many advantages, including increased speed because large data is segmented into packets. Large amount of data can now be sent over networks without tying up communication links. This allows many different types of conversations taking place at the same time. Otherwise, our single channel can be bogged down, and it also increases the efficiency. So while transmitting data using segmentation, there is a possibility that our data will reach in some other order. For example, if we send 1, 2, 3 packets, and they may just reach in different order. So we need some mechanism to just ensure that we can just recompile them or reformat them in the same order. That's why we have some labeling over there. And the TCP is responsible, the TCP as a protocol is responsible for sequencing the individual segments. So segmentation is done at the TCP layer or transport layer, and it is also responsible for reassembly of packets. And this chunk of data that we're talking about is called a protocol data unit. And at each layer, we have given it a different name. For example, at the application layer, we generally call it the data. Once we break it down, we call it the segment, and it is done at the transport layer. And at the IP layer, we call it a packet where it is being routed with the help of IPv4 addresses. And then we have the frames at the data link layer or the Ethernet layer. And then at the lowest level, at the physical layer, we have the bits that are being used to transmit over any media. It can be wired media or the wireless media. So we have three different kinds of addresses. We have the MAC address, which is also called the physical address, and it is at the data link layer. Then we have the IP address or the network layer address, and at the transport layer, we have the protocol address, that is the port number. And these three addresses are required to effectively communicate or make some connection. So we have the MAC addresses, the IP addresses, and the port numbers. Okay, so once the data is being sent, every layer adds its own header, and we can say that the data is being encapsulated at each layer. And once it reaches its destination at each layer, from the lowest layer, the header is removed and passed onto the above layer. And this is how the data is de-encapsulated. And once it reaches the application, the only thing remains is the user data. First, the Ethernet frame header is removed, then the IP header is removed, then the TCP header is removed, and the application receives the data. So there are multiple headers that are used in encapsulation and then de-encapsulation. Okay, in your VM, there are also some virtual networks that are established, and there is a small script that can be used. Wait a second. That can be used to create a virtual network, and we can then try to check the communication or capture the packets and analyze them. There is a small script that is there that creates this mini net topology that is creating some virtual devices within your own VM. So the script that has been provided will create these three hosts, host 1, 2, and 3, and that are connected via switch 1 to the router, and then similarly host 4 is connected to the other router, to the other interface as well. And you can observe that at each interface of a router, there will be different networks. For example, at this network or at this layer, at this port, this network is working, and at this port, this network is working. And the main task of the router is to just route the traffic between these two networks. And we can create this network with the help of this simple command that is available in your lab manual. So there is a small script that is there. We just run it. And it will create the same network. We will see something like this. This will be just replicating this diagram. And what we can do is we can just uh, open new terminals within these host context as well. Just type in the command xterm h1. A new terminal will be opened and you will see that its heading is, or its title is node h1. Similarly, we can use xterm h2 and we have this node 2 as well. And we can type IP address to check its IP address, and its IP address is this 10.0.0.12. And if you want to check its IP address, it will be 10. This one 10.0.0.11. So this is .11 machine and this is .12 machine. And similarly, as we know, we can use Wireshark to observe the traffic. Let's just run Wireshark on this host 1. Just like this first interface, no traffic is still going on. What we can do is we can generate some traffic with the help of ping command, ping-c. Let's just send 10 packets to 10.0.0.12. And as soon as we start sending the packets, we can now capture them here. So we can utilize the simple mainnet within this within our VM to send out some traffic and analyze them. Similarly, let me just quit it. On the Linux system, we have some command called traceroute, which I think we have already seen as well. And we can use it to map our path. I told you that there are the different routers that will be involved in routing our packets. So in Linux, we have this command traceroute, and in Windows, we have the command traceroute. Okay, it is just tracing it in IPv6 addresses. And if you are using some VM, some destinations will stop you from accessing the route information from virtual machine. So let me show you from the Windows machine. So what I can do is I can type in trace-4cisco.com so that it traces the IPv4 addresses. So this is my local router that is there. And there are also some online applications that can help you to do that. For example, you can type in online trace route. We can just Let us try this one. Cisco.com and traceroute. So it is back, and this is the complete map that where the traffic generated and how it reached the destination. So it started from here, moved to this country, and then it reached its destination. So this is the complete IP map that which IP addresses were involved and how our traffic was routed. So there were on 16 routers involved here, and from 9 to 16 they were all from Cisco. You can see. So maybe this is some kind of internal network, their internal network. And our request was generated with the help of formerly Node system, that is a cloud service provider. So this system or this website is hosted on Linode, and our request was generated from here, from this IP address, and it reached this Cisco. Don't know why it is not working, but it should give you the trace route here as well. Just like that, it now has reached my ISP. It is slow, but it will give you the complete route similar to that. So let's go to the next module, which is Ethernet and Internet Protocol. So Ethernet is actually the protocol that is used once we are connected with the Cat5 or Cat6 cable, and it operates on the data link layer, and it is just called IEEE 802.2 or 802.3 standard, and it supports up to 100 Gbps. And what important information is there? It has this source MAC address and the destination MAC address. The rest is just additional information that is used to communicate, and the maximum size it supports is 1518 bytes. So a segmentation that will occur at the transport layer will follow this standard. The segment will not be greater than 1518 bytes. And it cannot be less than 64 bytes as well. So if it is less than 64 bytes, some random information will be just pushed in. But the important information is this: it contains the source MAC address from where the information was generated and the destination MAC address. And this destination MAC address will be the MAC address of the next hop. It will not be the ultimate, it will not be the MAC address of the ultimate destination. Normally, in our case, once we are sending the data out, this destination MAC address will be the MAC address of our router or the default gateway. And it will keep on changing on every hop. So this is just information about the header. The preamble is used for synchronization, the destination MAC address, the source MAC address, and the type identifies the upper layer protocol that is encapsulated in the Ethernet frame, like it is an IP packet or what. And the data field is the actual data, and then the frame check sequence. If there is some error here, it will create an alert. And this is the MAC address format. It is 48-bit binary values, and normally we see them in the form of 12 hexadecimal digits. And there are different notation or different forms that we see these MAC addresses represented. They may be with dashes, with colons, or with the period. And everything that flows over the Ethernet follows the standard, and we see these 48-bit MAC addresses in the source MAC address as well as in the destination MAC address. So this is how your actual physical system can be traced back. If they know their MAC address, they will actually know who the vendor is, and it can be traced back to you. So what is IPv4? IPv4 addresses operate at this network layer. Every device on the internet or on the network needs to be configured with an IP address. And it encapsulates the PDU from the transport layer into a packet, and it does the actual routing part. From how the packet will be routed to the destination is the goal of this network layer and the IP protocol. So it is at the routing at the central address, which gives the addressing like 192.168.32.11, and it does the addressing part and routes the traffic. So it takes the data from the transport layer, including the segment header and the data part, and it encapsulates it into the data field and adds its own header, the IP header. And mind you that the IP header contains the destination IP address and the source IP address, from where that is used to route all the packets. So the IP addressing is connectionless. There is no connection that is established. Establishment of connection is the responsibility of the TCP protocol at the transport layer. So it will just send out the traffic, and it will try to deliver the packets with the best effort. So it is not, the packet delivery is not always granted, but it is tried. If you want that every packet should reach its destination, then the TCP protocol at the transport layer will come into play, and it will ensure that your data reaches its destination. And it is also not dependent upon any media. Your packet can move over the fiber interface, the Ethernet interface, the wireless media, or the satellite media. It will not bother the IP protocol how it is working, and that will be decided at the Ethernet layer or the network access layer. So this is just connectionless analogy, and similarly, the network is connectionless. The data is just pushed out. It is best effect. The packets are routed to the network quickly. Some packets will be lost in the way, and they can be retransmitted with the help of transport layer. It is media independent. There can be a copper Ethernet, serial cable, optical fiber, anything can be there, and it is able to just send out the packets. So this is the main header, and I told you that the basic information that we need is the source IP address and the destination IP address. Then there are different additional fields, the version, the header checksum, the total length, flag, and so on. Now comes the IP addressing basics. This is the most important part. So the IPv4 address is a 32-bit address. That defines a network and a host on the network. So we have a network portion and a host portion. The network portion defines the complete network or a complete subnet. And it will be same for all the hosts in the network. For example, you may have seen the networks with 192.168.0.1, 0.2, 0.3. The first three digits, 192.168.0, remains the same. Similarly, in networks 172.16.0.0, you may have seen that a few digits will always remain the same. These few digits that always remain the same constitutes the network portion part. And how it is calculated, we will see it in the next section as well. And this IPv4 address needs to be unique. Okay. And the default gateway address is the address of your router, the immediate router. It will also be on the same network. Then comes the subnet mask. This subnet mask actually defines how many bits in the IP address represents the network part. So, and it constitutes of only two things, ones and zeros. Is a consecutive sequence of 1 bits followed by a consecutive sequence of 0 bits. So you will see something like this, 255, 255, 255.0, and all the ones will represent the network part and all the zeros will represent the host part. So a subnet mask is used to differentiate between the network portion and the host portion from an IP address. So how we can calculate this network part from the host part? You just type in your IP address, convert it to some binary digits. Similarly, you convert your subnet mask into binary as well. And then just AND them. Okay. If you AND these, only the binary addresses where both ones will be there, that will remain there. So what will be the answer in the example shown? That we will get 192.168.10.0. So the network address will be 192.168.10.0. So we will call it the network address. And this 10, this host portion, the 10 is actually representing the last host. And sometimes we, instead of the subnet mask, we see a prefix length. And the prefix length is nothing but actually the number of ones. For example, here the number of ones are actually 24. 8 plus 8, 16, 16 plus 8, 24. So sometimes instead of just subnet mask, you will see a prefix length that is denoted by a slash followed by the number of bits set to 1. So you will see something like that, 192.168.10.10/24. So this is just a table that can be actually used to convert these. So if the subnet mask is 255.0.0.0.0, in binary, the first 8 bits will be 1. And similarly, the prefix length will be 8. Here it will be 16, 24, 25, 26, 27, 28, 29, and 30. So it can be anything. So I told you that we need to AND these, and if you remember, 1 and 1 is 1, and rest everything becomes 0. 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0. So we can just logically and the subnet mask and the IPv4 address, and we can get the network address. Just like that, this is also the same example. 1 is 1, and 1 is equal to 1, and there's 0 1, we get the 0, and this is how we get the network address. Okay, why this IP address and the network address was required? Because this defines a complete network, and we need to split a network into different parts called subnets. Why? Because on a local area network, an R broadcast is R request is broadcasted. So there are a number of broadcast messages that work within a simple local network. And if a network is too large, if it contains thousands of hosts, that broadcast messages, there will be a number of broadcast messages and it will choke the complete network. So to reduce these broadcast messages, we limit them. We subset a network into multiple subnets, and we segregate them into different broadcast domains with the help of subnetting. So if you look at the diagram, the first diagram shows you that in the LAN 1, there was a network of 172.16.0.0/16. So only this 172.16 was the network part and 0.0 was the host part. So there were a number of users that were supported, and there are 400 users. So there was a large broadcast domain. So there were a number of broadcast messages that were being sent. What a good network admin will do, he will create subsets of these networks. So in the second diagram, he has used a subnet mask of 24. So first network is 0.0 and the other network is 1.0, 172.16.1.0. And 200 users have been distributed on the right side and the 200 users have been distributed on the left side. And these two networks are combined with the help of a router. So only router can just route the traffic, and now the communication can also take place between these two local area networks, but it also reduces the broadcast messages within the network. So we can do it with by location. For example, normally we see it, but subnetting is done on the basis of floors, or on the basis of departments, or on the basis of device types as well. For example, servers can be put in on one subnet, the printers can be put in on the other subnet, or host can be put in on the third subnet. And by distributing a larger network into logically dividing them into multiple subnets, it's also possible to use different access control lists to just apply some policies, some security policies. For example, this host can access this printer. So this becomes also easier if we distribute a larger network into smaller networks. So there are different type of IPv4 addresses. This class A addresses that start from 0.0.0.8 to 127.0.8, and there are 16 million host addresses. So you see that only the first octet, there are 4 octets here, and only the first octet is used for the network path, and the 3 octets are used for the host part. So for each network, there may be 16 million host addresses. Then we have the class B, where we have The two octets, normally we have the two octets that are there included in the network, and we have 55,000 host addresses. Then the class C that we normally see in our networks, where each can support only 254 hosts, where only the last octet is used for the host network part. And then there are some additional classes as well that are experimental that we normally do not see them. So 50% of all the IPv4 addresses are class A, then 25% class B, and then the rest is shared with class C, D, and E. Then we also see some private address blocks, and these private addresses are not routable over the internet. So these addresses can only be used over the local area network, and our routers are designed in a manner that they will not route the traffic or to these from the internet. So that's why you normally see these IP addresses on your local devices, and some kind of a network is there on a router that is translating these IPv4 addresses, the private IP addresses, to the public IPv4 address. So that's why we see 10.0.0 network or 172 network or 192.168 network. That's why we have all the devices normally in like a PC laptop that are operating on any one of these ones. These are not routable over the internet. So if someone is trying to directly communicate with these IP addresses, the ISPs will block this. So there can be multiple networks using the same IPv4 address, but on internet, we need unique address for everyone. So they are stopped from accessing the internet. If they want to exchange the data with the internet, they need to have some mechanism over here at the at their router level that can translate it to IPv4 address of the public IPv4 address. That is the net. That is the function. That is how the net functions. It translates the private IP address to the public IPv4 address. Then we have the default gateway, which is the default route. So if you want to communicate with the internet or some remote host, you just send your traffic to the default gateway that in most of the cases will be your router, and that will route your traffic to the destination. So the default gateway will be a router which has a local IPv4 address in the same address range as the host on the local network. It can accept data into the local network and forward data out of the local network, and it routes traffic to the other network. So it will be some kind of a router that is sitting at some central place, and you will be sending your all data to it, and it will be routing the data towards other networks. So that's why you see that PC1 and PC2 are configured with the default gateway route is there always in your IPv4 setting. Similar in the case of IPv6, there will be a default gateway. If default gateway is not there, then you will face issues in the connectivity. So you can just see the routing table of your Windows system with the command route print or /r, and it will list down if you want to access some network how you can do it. It will list down the network and the next hop address. And on most of the cases, it will be your gateway. But similar on the router, there will be a routing table that will keep a record if there may be different interfaces of it, and it will keep the record if some packet is destined for this IP address, it should send to which next hop router. So all information is saved in its routing table that is updated with the help of a routing protocol like BGP or OSPF. This is a screenshot of netset-r command. You can see that it has the network destination and the gateway. So normally it will be your default gateway. So what is IPv6 then? So we had this IPv4 addresses that were 32 bits and they were actually being exhausted. There are so many devices over the internet that we ran out of IPv4 address. So we came up with a solution that let's introduce new IP addressing scheme that is 128 bits. So this was a huge jump from 32 to 128 bits. But what happened is that it is very difficult to remember these 128-bit addresses, and we are still people are still using these 32-bit addresses, and some companies have totally shifted on IPv6 address like Microsoft, Facebook, or LinkedIn. The exhaustion IPv4 exhaustion date was previously predicted in 2012, but with the help of NAT that multiple devices can just share one public IPv4 address, we have just extended its lifespan, and now both of the schemes are still being operated. But in future, we will be totally shifting to IPv6 addressing. So this is the main addressing format of IPv6 address. Okay, so IPv4 addresses are 128 bits in length, and they are distributed in 32 hexadecimal values and 4 hexadecimal characters at each interval. So we have now 16-bit segments over hex text. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 octets, we can say. And in each octet, there are 4 hexadecimal characters. So that accounts to 128 bits. So the preferred format for writing an IPv6 address is you type in these 8 octets, you write them in the sets of 4 hexadecimal characters. And to help write these or understand these, there are some shortcuts. So for example, they say that leading zeros can be omitted. You can just remove these. For example, 01 AB, we can just remove it and we can write in 1 AB. Similarly, if it's 0800, we can remove the leading zero. But the rule applies to only leading zeros, not the trailing zeros. We cannot remove the trailing zeros. We can only remove the zeros that lie before this hexadecimal character. Similarly, if some hexset, or you can say the octet, is comprised of only all zeros, we can just remove all these zeros and replace them with the double colon. But it can only be used within only once and within that address. For example, there was uh, a 000 here, and we can just remove this. And there were also 000 again, so we replace once with the once we replaced it once with the zero and the second time with the double column. So it's our choice that we want to where we want to place these columns. So there can be a prefix length just like in the network. We in the IPv4 address we had the network part and the host part. Here we have the prefix part, which is 64 bits, and it was same just like the network part. The 64 bits are used for the host part. Today we have on module 8. We were talking about IP addressing in the last session. Today a little bit we will talk about the MAC and the IP, how they are translated. So there are two primary addresses that are assigned to any devices once any device is on local area network. The first is the physical address, the MAC address. This is used for Ethernet network identification card NIC to NIC communication on the same network. So your devices are actually talking to each other with the help of these MAC addresses, and this is actually the hardware address of the network card that is installed in your laptop where you plug in your Ethernet cable. The second is the logical address, the IP address, and this is used to route the traffic from source to final destination. And this is used to identify the address of the original source device and the final destination device. And these addresses may be on the same network or may be on a remote network. Once a packet originates, the destination and the source address always, the source IP address and the destination IP address always remains the same. Whereas the MAC address keeps on changing as a packet or data travels from one hop to another network. So how do we identify actually the IP address? So here the DNS system, the domain name system normally comes into play. For example, we have discussed that once we put in cisco.com in our web browser, a DNS resolution takes place and it translates into IP address, and then only then we can get talk to Cisco servers and browse the website. So everything needs to be translated back to IP address, and then the hop-to-hop communication will take place with the help of logical addresses. So, but when the destination IP address is on a remote network, the destination MAC address will be the address of the host default gateway. So this is shown in the figure. So router examines the destination IPv4 address. If it is on the local network, then well and good. Then it can send it with the help of MAC address. If it is some remote address, then the packet will be sent to the default gateway. So we need to add this default gateway MAC address. So how this IP address get translated to the MAC address is once we are within the same network, It is with the help of a protocol called ARP, ARP. So every IP device on an Ethernet network has a unique MAC address or an Ethernet address. Whenever some data is sent, there are two essential elements to it: destination MAC address and the source MAC address. So the R protocol is there that provides the basic resolution of IPv4 addresses to the MAC addresses, and every device on a network maintains an ARP table just in the form of a cache, and it contains the entries that translate IP addresses to the MAC, MAC addresses. So when a packet is sent to data link layer from the IP layer, and it is to be encapsulated into an Ethernet frame, the device first goes to its table in the memory to find the MAC address that is mapped to the IPv4 address. This table is not stored on a hard disk, but it is in the RAM, and it is in the form of a cache. The sending device will search its ARP table for a destination IPv4 address and the corresponding MAC address. And once it finds the MAC address, it just frames the packet with the help of that MAC address. But if the destination IPv4 address is on a different network, then the source IPv4 address or the device will search the R table for the IPv4 address of the default gateway, and the MAC address of the default gateway will be added to the actual frame. So as we have discussed that it is in the form of a cache table that is stored on each device, there is some expiry that is involved with it. Normally these ARP entries expire after 15 to 45 seconds. This will depend upon the operating system that some device is using. So how a switch populates its ARP address table is a very interesting phenomena. As soon as some MAC address, as soon as some packet is sent to a switch, it searches for the source MAC address and just add it to the table that this packet came from this port and this IP address. So if you are on a router, you can use the command show IP ARP, and it will list down all the entries on your system. But if you are on a Windows PC, you can use ARP-A command, and it will list down all the entries of the MAC addresses and the IP addresses that are currently cached. Now, ARP is very essential protocol, but by design there are a lot of issues with this ARP. So once a device needs to add a MAC address to its table, it doesn't know where the device exists. So an ARP request is broadcasted over the complete network. So the ARP request is received and processed by every device on the local network. And if you are in a home network or a very small business network, these broadcasts will probably have minimal impact. But if these broadcasts are occurring very frequently, they can choke your whole network. That's why we are actually segmenting our network with the help of VLANs and subnets so that these broadcast domains remain separate because ARP requires broadcasting the packets and we cannot just have a lot of broadcast packets just choking our network. For example, if you in the morning you start your complete network, you switch on all your PCs at once with the help of a main switch. Every device comes online and it is looking for other devices on the network, then your network can easily choke. Then there is no authentication in the ARP protocol. A threat actor can use ARP spoofing. This is the same mechanism that we discussed early on with the help of where we are performing man-in-the-middle attack, that the attacker can broadcast false ARP replies and can spoof himself as a gateway. So he can act as a gateway, he can just send out ARP replies, malicious ARP replies, and other devices will think that the threat actor is actually the gateway, and every packet will be routed through the threat actor, and certainly it will cause into the mirror attack, and he can see every kind of traffic on the network. This was a very small module. Let me load the other one. So the next module is regarding the transport layer. So application layer programs generate a lot of data that must be exchanged between source and destination host. And it is the transport layer that is responsible for logical communication between applications on the different hosts. So this layer is responsible for establishing temporary sessions between two hosts and some kind of mechanism to ensure reliable transmission of information for an application. So the transport layer is the link between the application layer and the layers below. And transport layer doesn't need to know about which type of host is there or the type of media that the packet will take during its path or the congestion of the link. It only ensures that our data reaches the desired application. So internet layer is there to route the packets to the destination, and the transport layer ensures that it is fed to the right application with the help of some port numbers. And there are two protocols that we use at this layer. If we need some connection-oriented service, we use the TCP protocol, and if we do not need any connections, we can use UDP for broadcasting the packets. So the transport layer has many responsibilities. At the transport layer, each set of data flowing between a source and a destination is called a conversation and is tracked separately. So there will be multiple sessions. You can be browsing multiple web pages. You can be having a chat application open. You may be streaming services. You may be browsing Netflix. So a host may have multiple applications that are communicating across the network simultaneously. And similarly, the network access layer may have a limitation on the amount of data that can be included in a single packet. So the transport layer will break down these packets into smaller segments and will be responsible for sending these data across and then collecting them and rejoining them. So this is the first responsibility of the transport layer, that is the segmentation. So it is its responsibility to break it down into properly sized blocks, and these may be called the segments or datagrams. This is the same mechanism that we have discussed. It will reassemble them once the package reach its intended target. The transport layer also has header information containing binary data that is organized into different fields, and they ensure different functions in managing data communication, including the different session information, or how these packets are going to be assembled, or they sometimes also ensure some priority flags as well. So some data can be referred or transported early on because it has some priority flag set. So there are some flags inside this header that can ensure the data is transmitted faster or reliable, depending upon the application that you are using. Then, as we know that the transport layer, we have different ports, and these ports identify the actual application. For example, in the diagram, you can see that if it is a mail, it will be using port 110. If it is an HTML page or a website, you are browsing a website, you will be connected to the port 80. If it is HTTPS, it's port 443. And if it is IRC, Internet Relay Chat, it will be port 531. And different applications have dedicated ports on the transport layer, and they ensure that the data stream reaches its intended application. So sending some type of data, for example, if you're browsing different services and you're also streaming, it may happen that your streaming service can consume all the available bandwidth because it supports it. For example, Netflix may support 4K streaming, and it may try to send all the data at once, but it will choke down your bandwidth and your other services will not operate. So what this TCP layer does, it does the multiplexing part. It tries to send different type of packets at the same time, multiplexing them on the same media, so that different services can share the same pipeline. So it ensures that you can receive or you can just browse different services at once. So, moreover, it also ensures error recovery and transmission of damaged data difficulty. What it means is that we discussed in the IP layer, there is no error recovery mechanism if some packet is dropped in the way or it is lost. It is the responsibility of the TCP layer that ensures that the data reaches its intended uh, host, the target, and if some packets are dropped or lost on the way and it is using some TCP protocols, then they can be resent at the time if the application requires it to be complete data. For example, if you're downloading a file and some packet is lost on the way, we need the complete file, so we can request, the TCP layer will request the sender that send this particular packet again as it has not reached. So if we sum up, IP layer is only responsible for addressing and routing of the packets, and it does not exactly specify how the delivery or transportation of the packets will take place. It is the responsibility of the TCP protocols that specify how the message will be transported between different hosts, how they will be segmented, how they will reach their intended application, and to accomplish that, it includes TCP and UDP protocols. There are two protocols, and as different applications have different requirements, so this TCP IP layer provides these two protocols. If you require some connection-oriented service, you use TCP. If you use some streaming service, you can use UDP. Now let's just discuss something how this TCP protocol actually works. So what is the difference between TCP and UDP? So TCP is a reliable, full-featured transport layer protocol that always ensures that full amount of data reaches its destination. It first establishes a session and then the data is sent. It also includes some flow control mechanism. If your data, the loss of data packets is increasing with the time, it will just slow down the sending of data so that the packets are not lost. For example, it may happen that your connectivity is over the satellite, which is having some issues due to weather, and your packets are being lost. A lot of packets are being lost. Then it will just reduce the speed of sending the packets to ensure that delivery of packets is being taken place. So it will transmit any unacknowledged data. With each data packet it sends, it will ask for the acknowledgement from the recipient. And if it doesn't receive the acknowledgement, it will resend the packet. It will also ensure that the packets are properly segmented and some sequence number will be allotted to each packet. And in order to maintain this state, a TCP first establish a connection between the sender and receiver. That is why it is called a connection-oriented protocol. This is the main TCP header. We have the source port, the destination port, the sequence number that is used to trace down what segment is there. It is in the sequence. Then we have the acknowledgement number, which contains the address of the last packet that it sent. So we have the window, which defines how much data is being sent in each frame. And then we have the application layer data that may vary depending upon the on the networking that we have, whether we are using some gigabit interfaces or Ethernet interfaces with 100 Mbps. The other protocol is UDP, which is a simpler transport layer protocol than UDP. It does not provide additional benefits like reliability, flow control, or connection oriented. It is just like fire and forget mechanism. You are just streaming the data, everything is being sent out, and whatever you can get is good enough. Normally, it is used for live conversations. For example, if you are talking on this WebEx, if some packet reaches late, like half an hour late, it will not matter because the conversation has already ended. So it is just like that. If you're watching some movie, if some pixel is lost on the way, it will not matter because the pixel has to be there at a particular time where you can actually stream it. So it is used for UDP is actually used for streaming services or where you are actually talking to each other or the live conversation is having live chat, something like that. So it is known as best effort delivery protocol, and there is no acknowledgement that the data is received at the destination. No X packet is sent, and it is just like placing a regular unregistered letter in the mail. If it reaches, that's good. If it doesn't, you cannot trace back where the packet is lost. So its header is very simple. You can see that only the source port and the destination port is there. Small checksum is there, and length and application layer data. There is no segmentation involved. There is no acknowledgement, no sequence number. Just simple header that is used to just send out the data. So this is the how a communication is actually taking place once you are sending something. So a PC is simultaneously requesting FTP and web services. If you can see in the middle, there will be different source port and the destination port involved. The FTP client source port is 1305 and the destination is 21. Similarly, for the web, there will be a different source port which is 1099. It is the source ports on the client side are random that can be chosen from 65,534 ports. There are total these much of ports, and any port number can be chosen by the client. But the destination port numbers are fixed. Normally, like web, we have the port 80. For FTP, we have the port 21. So these port numbers are actually talking to each other. The traffic is being routed through IP addresses, but the ports are actually defining where this traffic is actually going. So if you see at the bottom of the diagram, you see the destination MAC address, the source MAC address, source IP, destination IP, source port, and the destination port. And the IP pair, we source IP and the source port, the pair of it, we call it the socket. So a combination of an IP address and a port is actually a socket. Once we talk about sockets, it's actually combination of both, which ensures that the packet reaches its destination to the required application. Next, we are going to talk about some protocols that provide some network services to us. First is DHCP, Dynamic Host Control Protocol. So this dynamic host configuration protocol is actually used to hand out the IP addresses over a network. Whenever you are connected to a network, just like if you are connected to a Wi-Fi address, you are using DHCP that automates the assignment of IPv4 addresses, subnet mask, gateway, and other IPv4 network parameters. You do not actually have to open your network settings and just add static IPv4 address or a gateway IP address. You are automatically assigned these addresses by the Wi-Fi router or the LAN network. So in the background, this DHCP service is running and it hands out the IPv4 addresses, and that's how we can communicate. And we don't need to bother about configuring our own computer once we are moving from one network to another. So whenever you are connected to a network, the DHCP service is connected. You request DHCP service that give me an IP address. The DHCP server chooses an address from configured range of addresses called a pool. It already have some pool with it, and just like that 192.168.2.0/24, so it can hand out 254 IP addresses. It keeps a record which IP address has already been allocated, and it will allot you a free IP address from that range. On a larger networks or where you are actually there are variable number of users or a variable users, we normally tend to use DHCP. But in some business networks, the business owners may just disable DHCP and tell you to manually assign the static IP addresses so that they can have complete control over what is happening. So how the DHCP operates is very simple. When an IPv4 device boots up, it will try to connect with the network and it will broadcast a DHCP discover message, which is there to identify if any DHCP server is there. And if DHCP server is there, which is normally our Wi-Fi router or a LAN network router, it will just reply with the DHCP offer that will contain the IPv4 address. And if the client is satisfied with the DHCP offer, and if he wants to adopt that IPv4 address, which it normally does, it will send the DHCP request message, and the IP address will be finally allocated to the device. And the device will send an ACK message that it has configured its IPv4 address. Next is the DNS. We have talked a lot about the DNS. So domain name system provides a translation between the website address and their IP addresses. So the web servers that we often connect are using names like Cisco.com, but we actually require their IP addresses. Why we are using these names instead of the IP addresses? Because these are easier to remember, and the underlying IPv4 addresses or the server IP addresses can actually change. So Google may decide that they don't want to use this web server, the physical web host, and they want to move all the data from USA to UK. They can actually do that, and they can just make a small entry in their DNS system, and their website will be actually automatically routed. So there are multiple uses of using some DNS, but the DNS system was developed to provide a reliable means of managing and providing the translation. But there are a lot of issues with the DNS. The DNS is being used for attacking servers, like for carrying out different type of attacks, like DNS amplification attack, DDoS attacks as well, because there is no authentication mechanism inbuilt between in the DNS. Anyone can just go ahead and query a DNS server for some IP address, and which can be easily manipulated. So the DNS consists of a hierarchy of generic top-level domains, which contains com, net, org, government.edu, and other country-level domains like Brazil.br. For UK, we have the UK, etc. And then we have the second-level domains, which are actually owned by organizations. For example, nus.com or the google.com. These are actually the second-level domains. And then we may have the third-level domains as well. For example, marketing.google.com, games.google.com, similar to that. And then so on. We may have multiple levels of domains. And once we want to resolve a name to an IP address, the process is very simple. First, your local cache will be checked to see if mapping is there. If it is not found, your DNS server will be queried. Normally, the first DNS server you send your request is your local router, your Wi-Fi router or something like that, which will forward that to main DNS server of the second level domain, or the first level domain that will send to the second level domain and the third level domain. So it will be a recursive query that will be sent, and eventually it will reach the DNS server or our target, and we will get the IP address. So how this is happening, the user types a fully qualified domain name, which is the website address, into web browser. A DNS query is sent to the designated server for the client computer. The DNS server matches this website name with the IP address, and it will send the response back to the client. So now we have the IPv4 address. Then what we can do is the client will send the request to browse that website over that IP address, and the package will be routed. Similar to DNS, there is some other protocol. There is one other protocol that is similar to it, that is WHOIS protocol, and it is used to identify the owner of some website. So when an internet domain or a website is registered and mapped to an IP address on the DNS system, the registrant or the owner must supply who is registering the domain. Okay, so this information is kept as a record, and uh, that defines who has bought, for example, who is the owner of google.com or who is the owner of facebook.com, and that this information is publicly available. Normally, what hackers are looking for is that, for example, if there is a website called telenor.com, I am more interested in finding the owner that has access to the admin pages of this website. So what I can do is I can perform a WHOIS lookup and see who is the owner's name and what is his email address, and then I can try to send some phishing email, try to break his password, try to gather more information about him, so that I can perform some other complex attacks. So normally it is the starting point for an attacker. Then comes the NAT protocol. As we have discussed, that the number of IPv4 addresses are very limited, and they were set to uh, be exhausted somewhere between 2013 and 15. But we are still managing to use these IPv4 address, and we have not yet transformed over to IPv6. So this is because of the NAT protocol that translates private IP addresses to the public IP addresses. So a single public IPv4 address can be shared by thousands of devices that are configured with private IPv4 addresses in the network. So how it happens is that if you see at the diagram, there is a router that is configured with a public IP address, but rest all of the devices are configured with the private IP addresses that are not routable over the internet. So now these all devices, when communicate over the internet, their source will be originated from the NAT enabled router public IP address. So they will all be using the public IP address of their main router, and so they actually don't need, these devices actually don't need or their own uh, public IP addresses. This is being done with the help of port numbers. How? Because every time some data is being sent, the router assigns a random port number to each request, and once the data is received from the destination again, it can actually map those port numbers and send the data back to the source originator, which is also called, this process is also called port address translation. So for every device, the router keeps a table where different ports link or map to these private IP addresses within our network. Once the data is being sent, the table is being populated. Once the data is received from the destination, the router matches the port against the private IP addresses and routes the traffic to the actual destination that sends the data. Next is email protocol. Email is actually a store and forward method of communication. Email clients communicate with the mail servers to send and receive email. These mail servers communicate with other mail servers to transport messages from one domain to another. So an email client is actually not communicating directly with the inbox. There is multiple servers that are involved, and that may store emails uh, emails till the time when the inbox does not come alive. So, for example, if our iPhone is not yet connected to the internet, the email is not lost. It will remain stored on the server, and once we are connected to the internet, the email is downloaded to our device. And there are a number of protocols that are there to help us. Okay, so for sending emails, we have SMTP. And for receiving emails, we have POP or IMAP. So when you send an email, the client uses this SMTP protocol to connect to an SMTP server at the port 25. There is some format that your message should follow, and the message will be stored by the SMTP server, and it will be routed between different SMTP servers till it reaches its destination. Then POP3 protocol is used to retrieve a mail from the mail server. So once your iPhone is connected to the internet, it will try to reach its local mail server with POP3 protocol over port 110, and it will ask if some email is there. If some new email is there, if some new email is there, the new email will be sent to the client. Similar to the POP3, we also have IMAP, which is a newer protocol. In the POP3 protocol, once the email was delivered to the mailbox, it was actually deleted from the mail server. But in IMAP protocol, a copy of the email will still remain on the server. So you can use multiple email clients. For example, in the form of Gmail, you can use email on the Gmail web client or on Outlook.com, and you can have the same email on multiple devices. But early on in the once we were using POP3, once you retrieve some email, it got automatically deleted from the server. Next is the HTTP protocol that we normally use to browse the internet. Once we type in a URL into our web browser, the web browser will establish a connection on port 80 or port 443 to the website, and then all the files will be downloaded to our web client. For example, the index.html is normally the file that we receive once we open the home page. We are actually sending the GET request. Once we are entering a URL and press enter, our GET request is sent, and we ask for the index.html page. In response, the server sends the HTML code for this web page to the browser, which is responsible for rendering them rendering it to the correct format, and we see the website, the beautiful website on our web client. So there are different parts of a URL. First, we have the HTTP, which specifies the protocol. Then we have the actual website address. Sometimes we have the port number as well, like this port 8080. If it is not given, then it is specified by the HTTP or the HTTPS. If HTTP is there, port 80. If HTTPS is there, port 43. Then we have these directories or files, or we call it the path. Then after the question mark, there is a query. It is just like a variable name that you can input. For example, you can input that give me document ID this one and the format this one. So these are just like the variables in a programming language that can actually modify the response from the server. Then this fragment is actually the bookmark. You may have seen on different websites, once you click on some link, your website automatically goes down and takes you to the exact path or the exact heading where you want to go. So this is accomplished with the help of this fragment, which specifies the exact location on the page where you want to go. Then if you are want some security, you may use HTTPS, which uses authentication and encryption to secure the data. And even if there is some man in the middle attack, the attacker will not get to know your data, and he will only see the encrypted traffic that is flowing from his device. Then we have some HTTPS versions, which are just upgraded versions of TLS 1.2. And credentials information is always transmitted over HTTPS in current environment. Let's zoom. So this is just a brief summary of what we have covered from network network portion of this course. So there are different kinds of network devices. First, we have the end devices. They may include our laptops, our mobile devices, or anything that we are using. The end device is either the source or destination where the message is being sent or who is sending the message. And to distinguish every device on the network, we have different type of addresses. First, we have the hardware address or the NIC address, the MAC address. Then we have we need to have some IP address, and if these two addresses we have for our client devices, and if we are using some server model, if we have some server that is serving some web pages or email communication, then we also need to have port numbers for each of the applications. Then to route our packets over the internet, we have the routers. The routers operate at layer 3, which is the internet layer, and they maintain something called routing tables with the help of some dynamic protocols like routing protocols like BGP, EIGRP, OSPF, RIP. These are the different protocols, and they populate their routing tables. So they will see from where this traffic is being originated with the help of source IP address, and where the packet is actually going with the help of destination IP address. And based upon the destination IP address, the router is able to make a decision regarding the next hop or the next router where the packet needs to be forwarded. So the routing process uses network routing tables, protocols, and algorithms to determine the most efficient path to forward some IP packet. And they update their routing tables if some link goes down with the help of routing protocols that immediately provide the information to the router which can update its table accordingly. So the routers have two primary functions, the path determination and the packet forwarding. So which path each packet must follow depending upon the destination, and then uh, how it should follow, it should forward it. So it maintains the routing table as discussed. It can be built manually as well. You can actually go into the configuration of the Cisco router and you can just say that whenever you receive a packet to this destination, send it to this one. So if you see at the diagram, there are some uh, routes that are written, and it is written that it is directly connected. And if you see the last line, you will see that it is start from S, which means it is a static route. And if some route packet is for 3.0 network, you have to forward it to 2.2. It has been configured manually by the administrator because it starts from S, which means it is a static route configured by the admin. So as the packet is being forwarded to the next hop, it will be encapsulated within a frame by the data link layer, which is a layer 2 frame header, and it will be forwarded to the next layer. It will add the MAC address of the next hop to the frame as well. So from hop to hop, the destination MAC address changes, but the destination IP address will always remain the same because it is being used to determine the complete path where the packet is being going on. So the routing table which each router has different information. First, it has the directly connected routes. If you have 4 different local area networks, you can actually route the traffic between them by connecting them to the 4 different ports on the physical router. So these will be considered as directly connected routes. So these 4 subnets will be shown in the routing table as directly connected routes. Then you can have some static entries and some dynamic entries for the remote routes. If your router receives a packet from some local area network that is being routed over to some remote network, just like the internet, it entry will be made as a remote route. So this diagram illustrates the directly connected networks and the remote networks of router R1. So network directly connected to the R1s are the 3 networks directly, the 2 local area networks, and the router, the interface between point 2 to 5 and the point 2 to 6, this network. So 3 routes are directly connected. But if you want to send the traffic to 2.0 or 1.0 on the right side, then these are the networks that are remote to R1. So these first 3 networks, the 2 on the left side and the middle one, which is directly connected to the R1, but the rightmost 2 networks are the remote networks for the router R1. Then we have other devices as well. We used to have hubs, bridges. Now we only have the LAN switches. These hubs and bridges were very old technology. this is just like Ethernet hub was just like a repeater or an electric extension that we have in the house. That whatever is sent uh, on one port will be broadcasted over all ports. But it limited our transmission capability because every data is being sent to everyone. So we need to be aware that only one host should be sending a data at one time. So we invented something called bridges that is just like a switch, but with only two interfaces, the two ports. That on one side of a network will remain separate from the other side of the network. That was to separate the collision domain. Because if every device is sending data at same time, some collisions will take place and our data will not reach its destination. So hub was one collision domain, bridges just distributed these collision domains into two collision domains, and now we have the LAN where each device is connected to a different physical port on a switch. We have now 24 port switches, 48 port switches, etc. And now each device has its own collision domain. And now we don't have any issue that they are not sharing any physical media at once and they can independently send data to the switches. And how the switches are being operated, they switches maintain a table called a switching table. So which contains the entries which translates the MAC addresses to the physical ports. So there are different type of tables in each device. You have to remember. So first, we have the R tables that translates IP addresses to the MAC addresses. But in switches, we have the switching tables that translates these MAC addresses into physical ports. So if a frame is received for a MAC address, the switch actually knows which port it should send the data out. So it will be only sent to the required destination and it will not be broadcasted to the all. This switching table is also called the MAC address table, and it actually just lists down where each MAC address is connected on the physical port. And each switch is actually configured to dynamically learn these MAC addresses. Once you send a packet, the switch sees the source MAC address and it updates its table. For example, this computer A send a packet to computer D. Once it enters this port 1, the switch will just enter the entry for the MAC address A and map it to the port number 1. Now it knows that whenever any packet is coming in for this A MAC address, it should always go out to the port 1. So it is always dynamically updating its MAC table. So it may happen that you just remove this PCA from this port 1 and enter and plug it in the port 2 and you send a packet, then it will automatically dynamically update its MAC table. So it doesn't need to be static as it is dynamically being updated. So if how the data is being forwarded with the help of this MAC table. So whenever a packet is coming in, it will look at MAC table, and if some static entry is there, it will forward the message out of only that port. And if there is no entry here, it will just broadcast the message. So it is the default behavior of a switch that if there is no entry in there, it will just broadcast it. And this default behavior is actually utilized by the attackers. They try to flood this MAC table or clear it out so that every packet going in or going into the switch is broadcasted to everyone so they can listen it. So this is a technique is utilized by the attackers that they can flood the MAC table and every packet will be going into the all devices including the attacker's device, and they will be to just they will be able to receive all the communication and make some useful uh, information out of it. Then we have the virtual LANs that we already discussed. We can just add the VLANs according to some organization level, organizational hierarchy, or we can have some physical distribution like floor 1, floor 2, or floor 3, and they are used to segment the broadcast domains so that our network is not choked down due to these broadcast forms that are happening, especially for the R broadcast. Because once we are switching on all the devices, they will be just sending out the request to ask for each IP address to the MAC address translation, which is some broadcast message. Similarly, the DHCP broadcast is a message. DHCP request is a broadcast. So to limit the number of broadcast messages in a network, we actually segment a network into different VLANs. Then comes the Wi-Fi communication or the wireless communication. So instead of cables, we are using the radio frequencies, and it is called 802.11. So we are connected to a wireless access point, and for the wireless access point, we actually have the Wi-Fi MAC address, that is the MAC address of our Wi-Fi card. And our Wi-Fi card is actually being connected to the access point with the help of some RF media or the radio frequency band, usually in 2.4 gigahertz or 5 gigahertz. The major difference between the wired network and the wireless LAN network is the collisions. Once you are emitting something over the wireless media, you may face interference. For example, if a lot of devices are transmitting over the same wireless media over the same frequency, there will be collisions and no one will be able to understand each other. So there are special protocols called SISMA CDA that detects if the wireless interface is free for that particular frame of time, and only then the packet is sent. So it limits the speed of Wi-Fi networks. That's why we actually face some latency once we are using Wi-Fi instead of Ethernet card. The Ethernet, the people that game that are considered about that are very considerate about the speed they are getting and the latency, they will always use the cabling to their PC or the laptop. They will not rely on the Wi-Fi media. So WLANs are half duplex, means that only one client can transmit or receive at a given time. It is a shared media, it is the same shared frequency. We cannot have separate frequencies where access point is talking to each client on a separate media. It will just increase the cost. So WLAN or the Wi-Fi use carrier sense multiple access with collision avoidance SISMA CA protocol. It will just sense if the Wi-Fi interface is free or that frequency is free for that particular movement, and then only the packet will be sent. So if you have around thousands of clients in a smaller building using the same Wi-Fi network, you will be chalked down and your internet will never work. So that's why the offices mostly have LAN networks where you are actually just connect the different devices with it. So a wireless client will listen to the channel and see if it is idle. The channel is also called a carrier, and it will send a ready to send message to the access point to request a dedicated access, and only then once it receives clear to send message, it will send the message. And all transmissions are acknowledged because there are greater chances of collisions and data loss on a Wi-Fi media. That's why we always have acknowledgement that our packet has reached its destination or not. Uh, we did the Nmap in detail in ethical hacking course. We are jumping into attacking portion of this course, so just to give you an overview or revising the Nmap. So Nmap was a scanner that can be used to scan the network, and it can identify us the other systems that are there in the network, what are the ports or the services that are running on that system, or we can even go further and check the operating system or a target system, or what are the service version numbers that are there, because everything then maps from OS versions and service versions back to the vulnerability database, CVE database, and we can find out the vulnerabilities in our target system. So for any tool, if we want to get its help, there are very simple commands. We can do -h, but using this -h flag gives us a summary of the commands. It doesn't give us the detail or the complete manual page. If we want to know the detail of some attack or some scanning technique, we can open its manual page as well with the command man. So man stands for manual, and we can type in our tool name, for example, here Nmap. And here you can see that it is a very detailed explanation. It is a complete manual how it will show the results, what are different techniques. So if you want to study anything in detail, we can actually open the manual page. So if you want to quit it, just press Q. So let's just try a few scans. So if you remember what this command will do, you can tell me what this -a flag stands for. Any of you
I can't remember.
remember? Yes.
And I can't remember. Just
Okay. So we did that using -sv. We do the version enumeration. -sc SC was checking with default scripts, having some additional information, and -O was for capital O was for checking the operating system. So -A combines all of these three. It checks the version, it checks the operating system, and it runs a few scripts, additional scripts that Nmap thinks that are very essential and can reveal a lot of information. So it is just on all rounders kind of a flag that combines three flags. And this T is to tell the speed. So we have a scanning speed ranging from 1 to 5. So the default speed is T3. If we don't give any flag, it assumes T3 speed. But if you want to do a little bit faster, we can do T4. And if we want to do go faster, more faster, we can do T5. And if we want to go slow, we can do T2. So T4 is a little bit faster scan. And this scanme.nmap.org is our target. So let's just this n is small. And if there is one more flag that is -B, that is for verbose output. If we want to see what scanning is being done for now in the live action, we want to see the live action, we can add this flag. Because sometimes if we are scanning the live targets or live websites, it is not going to show. It is not going to show us the results for some time, and we may get confused that whether our scan is running or not. So it is better that you add this flag as well. So you see that it is now providing us real-time information what Nmap is trying to do, and as soon as it discovers some ports, it displays that. So it doesn't wait to complete the scan and then show the results. It shows the results live as soon as it is scanning the a target. So it says that it is scanning 4 services on one host, and then after the scan is complete, we get our normal results back. So there are a number of ports that are open. 422 is for SSH, and because we added -A flag here, so we are getting the additional information, which is the version number. Similarly, this is from a script. This output, this is port 80. This is version number. These are a few scripts that ran and that gave us the results. That the HTTP website title is go ahead and scan me. There are other few ports also open, and it also did the OS enumeration, and it find that our target is Linux-based system, and this is its kernel or its version. So these are just a few commands that we can run to find out what is services, what are the services that are running on the target, and what are its version number. Moreover, we can use Nmap to identify the devices in our network as well. For example, if I do ifconfig, we have this network. So if I want to identify that is there any other device that is up in my network, for example, there are other systems, we can run this command /24, we can scan the complete subnet. So it says that only one system is running, and it scanned 256 IP addresses and only one host was up. If it was a complete network, a bigger network, so we will see different services and what ports are open on each system. So this was just a basic reminder for Nmap. Next is, if you remember Wireshark, you can just run it with the command Wireshark. So if we run our Wireshark on our interface, it will start capturing every packet that is coming in or going out from our system. So this is, it also shows the protocol, that is NTP, ICMP. These are the protocols that are going out or going in. And if we generate some traffic, for example, if we try to open our web browser, let's see what happens. And you see a lot of traffic already started going on. What is happening that as soon as we open the browser, there are different extensions that are installed. browser is just trying to contact with its servers and try to make the connection. For example, if we filter it with the DNS traffic, we see that it has already started looking for some IP addresses of websites. For example, here you can see that it has queried that it needs the IP address of detectportal.firefox.com. As soon as we open Firefox, it generated a DNS query, and this our DNS server is this 2.3, and it was generated from 2.15, and it asked for IPv6 address for this. Similarly, it asked for IPv4 address for this one. A is for IPv4, and this tetra A is for IPv6. Similarly, there are different domains that are there, and it is asking for their IP addresses, just like in there. For every DNS query, we may see some response as well. Here it is the response, and if we click here, there are additional records, like it says that these are the records that it is providing. This is the CNAME record. It is answering it. Similarly, here are the IPv4 address that has been returned for this product.moz.aws.net, something related to Firefox portal or Firefox servers. So as soon as we generate some traffic, we start getting the DNS or other traffic in the version. For example, if we let's do Wikipedia, and as soon as I click it, you can see that a query was generated, and here we have the response that Wikipedia has this IP address 103.102.166.244, and then our traffic has started flowing through that website. We can just see it with HTTP, filter it with HTTP, and we will see the traffic. One important thing is that we can also see the complete traffic that is flowing on by clicking on some packet and going on to this link follow and HTTP stream. And here is the complete traffic that is going on. This was a request, then this response came out. Again, this request was sent, and this response came out. So we can just follow different HTTP streams by just clicking on this right click and selecting follow TCP stream or HTTP stream or whatever. So this is just a brief intro of Wireshark and Nmap. So our next module is attackers and their tools. So before we start, who are the attackers and what are their motives, we need to understand what is a vulnerability, what is a threat, and what is an asset. So an asset is anything that can be tangible or intangible that is important for us. It includes our computer systems, our data, our reputation, anything that we want to protect or anything that is of value to us is an asset. And any potential danger to an asset or a data or a network is a threat. So if we have an asset, just like some data, and if it can be breached or it can be stolen, then it is a threat. An attacker attacking a system may be a threat. And what is a vulnerability? The vulnerability is a weakness in the system or a design that could be exploited by a threat. So a threat can be a hacker, and vulnerability can be some weakness in some software, just like if Eternal View in Microsoft Windows 10, the earlier versions, that was the vulnerability, and attackers exploited that. An attack surface is a sum of all the vulnerabilities that are available in the system, or which a system suffers from, and that can provide a way in for an attacker to exploit. So what is an exploit? Exploit is the mechanism, the actual mechanism, the on-ground mechanism that an attacker or a threat actor employs to leverage a vulnerability to compromise an asset. So the exploit may be remote, meaning that attacker may be remotely sitting and he may just send some code. For example, he may some a crafted packet, just like we saw in Metasploit, that we can just load our exploit with load and then just run it. It will just remotely execute it and it will give us the access to the system. And it can also be a local exploit, meaning that in systems once they are hacked, normally an attacker gets a local user rights. He is not the admin or the root user on the system. So what he can do, he can just check for any vulnerabilities in the local system once he is on the system to escalate his privileges from user to the root. So that is a local vulnerability. A risk is the likelihood or the percentage of the probability that a threat actor will be able to exploit a vulnerability. So we have already discussed that it is not essential that a vulnerability exists, but it can also be exploited. If it is, for example, we may be using Windows XP system in our environment, but we may isolate them from the network. So a vulnerability exists in the system that we are still using an older system, but we have somehow managed or somehow secured it that it can never be exploited by the attacker because it is not connected to the internet, so the probability goes down. So wherever we have found some vulnerabilities in the system and we know that there are some risks, so as a defender, we can do 4 things. First is we can try to reduce it. We can try to patch the systems. If we are using some older systems, we can try to just update them, apply some security patches, apply some antiviruses. So we are trying to actually deal with the vulnerability. And the second thing is that we can just accept the risk. Why we are accepting the risk? That we have already discussed the example that there may be systems that we cannot phase out because of the cost involved, and we can just accept that this vulnerability exists, and if something bad happens, then we are going to accept the consequences. The third is the risk transference, which is a newer thing that is just getting in the market, that there are cyber insurance companies that try to copy their data, try to keep a backup of all of your data, your systems, and you just give them the insurance amount. And if anything happens, they are liable for the damages, or they will be able to recover your data. So this is risk transference. The fourth is the dangerous one, risk avoidance. So if you are not ready, or if your CEO or your management is not ready to deal with any vulnerabilities, they say that, okay, there are vulnerabilities in there, you are just telling a lie, or the attackers are not that sophisticated, this is not a vulnerability, then it is just like you are closing your eyes on some danger. So the risk avoidance is the most dangerous thing to do, and you have to do these three things. You have to reduce the risk, you have to accept the risk, or you have to transfer the risk. Then there are a few terms that there may be some countermeasures. We may take some actions to protect our assets from mitigating a threat or reducing a threat. We may apply some patches, we may just buy some security products. The second is the impact, the potential damage that organizations will be faced with if a threat is able to exploit the vulnerability. This may impact us financially as well, and this may affect us in the reputation wise as well. For example, if there's a Black Friday sale and Amazon goes down, so it is going to affect the reputation of Amazon, and any other competitors can benefit from it. So normally, hacker is a common term used to describe a threat actor. But before that, now we have started using the attacker as some negative term. But before that, in the past, the hacker term was used for a clever programmer developing a new program or that had a clear understanding of underlying code, or a network professional that uses sophisticated programming languages to ensure networks are not vulnerable to attack. So a hacker may not always be a negative person in the true sense. We have different type of hackers: white hat hackers, gray hat, and black hat. These terms you will be just listening in your life. So why we are studying this ethical hacking course under Cisco CyberOps, we are just targeting our profession as white hat hackers. So these are the ethical hackers that use their hacking skills, their programming skills for good, ethical, or legal purposes. We are just going to test our systems or the client system and patch them so that there are no vulnerabilities or there are no threats. Then there are gray hat hackers. There are individuals who are just testing the site, or just we can say hack the sites, but not for financial gain or the personal gain, or not with the purpose of making a damage. For example, there may be some activist that may just add a banner to a website. So actually his purpose is not to gain something. His purpose is to give out some message. Or there may be a hacker who just try to hack a website and then he reports it. But as he didn't have the written permission, so he will not fall into white hat hackers. So we studied in the ethical hackers as well that ethical hacker has a written permission to do the pen test. So if you're doing a pen test without the client permission, even if you're doing it to secure the network, you fall into gray hat hacker. But if you are doing it for the malicious purpose, for gaining personal access, personal gains, or some kind of financial advantage, you fall into black hat hacker. So the hacking started really in 1960s before we had the personal computers. There were phone hackers that were able to exploit some tricks with the phones. They were able to make long distance calls without being logged into the system. So they could just mimic a tune using a whistle, and they could exploit the phone switches to make free long distance calls. Then they were in mid-90s, they started monitoring programs where they were trying to exploit the complete exchanges, the uh, advertisement boards, the fax machines. So they started hacking those. Then there are different types of threat actors. Script kiddies are the hackers that are teenagers or inexperienced hackers that doesn't know what to do or what a running a script actually does. They know a few tools, they have this Kali Linux, they have this Parrot they just run everything against the target without knowing the actual architecture or without some systematic approach. Then there are vulnerability brokers. So these are actually the gray hat hackers who attempt to discover exploits in the systems but without the permission of the client. Once they found some vulnerabilities, they report them to the vendor or the clients for prizes or rewards. But as they do not have the permission of the actual client or the vendor, they cannot be regarded as the ethical hackers, and they fall into gray hat category. Then there are activists which rally or protest against different political and social ideas. They may just add a banner to a website recruiting people for some agenda. Then there are cyber criminals. These are the black hat hackers who are either self-employed or working for large cyber crime organizations, trying to cause damage or trying to do some attacks like blackmailing or cyber espionage. Then we have state-sponsored hackers. They are threat actors who steal government secrets, gather intelligence, sabotage networks of foreign governments, terrorist groups, and in corporations. So there are different types of threat actors as well. So we saw that this cyber criminals have gone ahead in numbers than the actual criminals on street. So they are trying to make money with any necessary means. They may be working independently or they may be working with the groups or the organizations, and their actual motive is to steal money from others, and they can steal billions of dollars from consumers and businesses every year. They operate some underground economy, and with the advent of Bitcoin and cryptocurrencies, the work of cyber criminals have actually gone up. Now they can just trade without leaving any traces. They can just do the blackmailing, get the money in cryptocurrency that cannot be traced to them. And so the business of cyber criminals have actually benefited with the advent of these cryptocurrencies. So as threat actors target home users, small to medium businesses, large businesses, an individual or a small company cannot deal with the threat actor individually. It is a shared responsibility. Why? Because for example, in case of a DDoS attack, a small company or a small organization cannot have resources to mitigate that. In denial of service attack, in distributed denial of service attack, there are different victims that are being exploited to send multiple requests. So it becomes the responsibility of all of us, or all of the organizations, that they ensure that their systems, their IT devices are not compromised and are not part of a botnet so that they can be used for attacks. So attackers actually perform these attacks by third parties. So we have to ensure, or every organization has to ensure, that their systems are not compromised, they are not part of some attack, they are not part of some botnet, and they have to do it in a combined manner. Then there are indicators of compromise. Once an attacker or some malicious person is able to hack into a system, is able to send you some virus, bomb, there are some indicators of compromise that can help to identify the malware. We have different solutions like VirusTotal, where you can just put in the IP address. It will tell you the reputation of an IP address, the reputation of IP addresses, the domain names are all being recorded. So if some domain or an IP address is being used for malicious purpose, so there are larger organizations like Cisco Telos, or there is VirusTotal that maintains the list, and you can just go over their website. If you find the IP address in your network or in your system, you can just check the IP address and see whether this has been used in attacks on other systems or not. In addition to indicators of compromise, there are some attack patterns with which you can actually identify who is behind the attack. So there is a MITRE organization that is just keeping track of techniques that the attackers use, and they just list them. For example, there may be an attacker group that is actually starts his attack by compromising Word files, embedding some JavaScript code in it, and sending it across. So with the help of the normal techniques that the attacker group uses, different attackers are just listed down, their techniques are listed down, and which helps to identify the strategies that or the group that is behind an attack. So there are different agencies that share this information. You must have heard that there are different certs in each in each country, and these countries also share this information. Similarly, there is a US Cybersecurity Agency. They use some automated indicator sharing system. There is a European Union agency. Similarly, there are different agencies around the globe that are trying to build cybersecurity awareness, and they also share intelligence that if some attack goes on in a country, the indicators of compromise, the indicators of attack, the threat actor techniques and procedures are shared across in the form of threat alerts. So there are different cybersecurity awareness programs that are run, including social media safety, updating privacy settings, device app security, keeping software up to date. These are just the general things. Safe online shopping, Wi-Fi safety, and protecting customer data. There are different alerts or different advisories that are provided for these topics mostly because these are the major things that are the victim of attack. So attacker use different type of tools to actually implement the attack. So in the figure, if you see across, you can see the sophistication and the technical knowledge. The tools are becoming more sophisticated with time, and the technical knowledge needed to actually understand the tool is becoming less and less. Back in 2004, 2005, we didn't have Metasploit in the Kali Linux, or we didn't have the Kali Linux even. We had the Backtrack one distro that was there. Now we have multiple attacking distros, Linux distros that are built in with a lot of tools, and the tools are becoming more and more sophisticated and automated. And we do not require much technical knowledge to just use them. We can just practice them to understand their underlying architecture, and we can just use them. So attackers are benefiting from the technological advancement. There are different type of tools that attacker can use to test the network, to test the systems, and we are also using the same tools to perform the network pen test, so that we get some real idea how our network security is based upon. So these are some just category of tools. We have the password crackers like John or Hashcat that we have used. There are wireless hacking tools to attack wireless networks. For example, we have AirCrack, Gitmap. We have network scanning tools like Nmap. We have used that. We have packet crafting tools. There are Scapy or HPaint. We have packet sniffers. For example, we have used the Wireshark. Then we have the rootkit detectors. These are the different defending software that can just check if some rootkit is installed within your operating system. And then we have some fuzzers to test for different types of inputs, forensic tools, debuggers, encryption tools, and a lot of other tools as well. Then we have different type of attacks as well. Eavesdropping attack, where we are actually trying to sniff the traffic and see what is going on. Just like we are eavesdropping on phone calls of some person, we can eavesdrop on passwords that are flowing in the network. Then there are data modification attacks, that is the attack on the integrity of the traffic that is going on. For example, we may change some terms, we may change some data in an Excel file or generate a new file even. Then we have the IP address spoofing attacks. Then we have the password-based attacks like dictionary attack or the brute forcing attack we can use to crack into the password. Denial of service attack to affect the availability, and the middle attack to just an attacker position himself in the middle of a network, listening to every traffic that is going on. Compromise key attack, just like if you lost your physical key. Similarly, if you lose your cryptographic key, your private key, you can listen to the traffic even if it is encrypted. Then we have the sniffers to listen to the traffic. So let's go over the common threats and attacks. We have already seen much of these attacks in ethical hacking course and the Cisco CyberOps mission module. So what is a malware? So malware is a code or a software that is designed to damage, disrupt, steal, or inflict some other bad legitimate action on data host or network. So it is just a bigger term, and the viruses, worm, and Trojan horses make part of malware. So malware is some umbrella term, and then we have its types. First is the malware. First is the virus. Virus is a type of malware that can inject itself into some other program. So we have seen that viruses corrupting our image files or our document files. So they are able to just attach themselves to legitimate programs and corrupt their functionality. And it can spread from one computer to another. So A simple virus may install itself as the first line of code in an executable file, and they can spread with USB memory drives, CDs, DVDs, or email networks, or network shares. Then there are Trojan horses. Trojan horses are the software that appears to be legitimate but may contain malicious code. Normally, these are found in online games, and they may appear to be some kind of antivirus. For example, you may have heard that your computer is compromised. Download this antivirus, or just click the download or install it. It looks like an antivirus, but behind the scene, it is actually a virus in itself. So it is a Trojan horse, and they may be classified according to the damage they are causing to your system. For example, we have some Trojan horses that are used for remote access. What we mean is that it opens a port on the system, or it just connects to a server, and the attacker may gain full access to the system. Then there are some Trojan horses that are just there for data sending. You may be playing a game on the system. It may appear as a game. And in the background, it may copy your all documents, Word files, Excel files, and sending it to a centralized server. It may be destructive. It may just delete some files or corrupt something. It may be a proxy that routes your traffic to some other system on the network or an online system. It may be some FTP, denial of service, keylogger. So we have different type of Trojan horses that do some illegitimate things or malicious things in the background while appearing to be a legitimate program. Then there are worms. But their basic functionality that a worm provides is that it is able to replicate independently. It doesn't need to get attached to another executable. It is an independent program, and it is designed to replicate at a very large scale. So it can run without a host program, and once the host is infected, the worm spreads rapidly on the network. So there's an example that in 2001, the code red worm initially infected 658 servers, and within 19 hours, it had infected over 300,000 servers. So they are designed to replicate at a very faster rate than the viruses. Similarly, we had SQL Slammer worm. That was the worm that ate the internet. It was a denial of service attack that exploited some buffer overflow vulnerability in the Microsoft SQL server, and the infected servers doubled in size in only 8.5 seconds. You can just imagine the speed with which the worms actually propagate. So there are three components of a worm. First is the enabling vulnerability. How it exploits the thing is the vulnerability. For example, it may be an email attachment, an executable file, or a Trojan horse, or a vulnerable system. Then, after gaining initial access to a system, how it propagates is the propagation mechanism. And then the third is the payload. That is the actual malicious payload that performs some actions and that does some damage on the infected host. And worms are self-contained programs. Do not need some host or some other some executable to run, as we have discussed. It just copies itself from one port to another and the cycle begins. And this mechanism is so employed that it is very difficult to detect. And worm never stops propagating till the time we have the complete patch, all the systems that are available on the internet or on the local network that are patched, or we have actually rooted out the worm will never stop. Then we have the ransomware that become very famous within the last 5 or 6 years, and they became famous because of the we got Bitcoin or other cryptocurrencies. Now, what happens is that hackers exploit some vulnerability. They send out some malware that encrypts the data over the complete system. They encrypt your essential files and then they ask for some extortion money. And the extortion money is required to be paid in some cryptocurrency, so it is untraceable. So attackers just use different techniques. For example, they can use social engineering. They can pretend to be social technician, make random calls. They can tell you to visit a website. They can tell you you may receive some emails with a download link. You open it, and as soon as you open it, it has only one task to encrypt the data on your hard drive, and then it asks for a key. And the key will cost money, and the attacker just asks for the extortion money. Then we have other types of malware as well. For example, we have the scareware that, for example, you get a pop-up that your system is infected with thousands of malware and you need to install this software for now. So this is a technique called scareware where users are forced into performing some actions by making them afraid or by just inducing anxiety or the perception of a threat. Then there are phishing, which is revealing, which is just fooling the people around, just telling them to reveal some sensitive information. For example, they may receive emails from the bank asking for their passwords, for their PIN code, etc. Then there are rootkits. Rootkits are installed on compromised system within the depth of the operating system. So these are loaded before the operating system completely loads. As antiviruses load above the operating system, they are at a layer higher than the operating system. They are not able to easily detect these rootkits, and they provide some kind of mechanism to the attacker to keep the access to the compromised host, and they cannot easily be deleted or get rid of. Then we have spyware that are used to just gather the keystrokes or other information from the system. Then we have the adware. That's why we have pop-up blockers in the web browsers nowadays. In initial days, there used to be some extensions, or once you visit a website, there are a lot of pop-ups, with a lot of you are thrown with a lot of ads. So these viruses or these malware and just show you a lot of ads. They earn the money with the ads, and your actual PC bogs down. So what are the common indicators of compromise if you are infected with the malware? So you may see some strange files, programs, or desktop icons. Sometimes the extensions change. Your antivirus you may get an alert that antivirus is off. computer screen is freezing, emails are being sent without your knowledge, your files are being deleted or modified, you are seeing the change in the extension, their system is slowing down. If you open the task manager, you see your CPU is always at 90%, your RAM is always full, you have problems connecting to the internet is very slow, you have unknown processes in the task manager, unknown ports open, and strange computer behavior. These are all things that indicate that something malicious is going on. So we have different type of attacks. The first one is the reconnaissance attack, where we are trying to gather the information. And how we gather the information, we have actually seen it. There were 5 attack patterns or 5 steps of an attack. The first one was the gathering open source intelligence from the internet. Then you just scan it, you identify the devices over the network, you identify the host, you identify the version. These are just performing the port scans with the help of Nmap that we have already seen. Then there are access attacks that can be done. We can just try brute forcing our passwords in. We can use Hydra. We can use burst intruder to just brute force HTTP passwords. Then there are spoofing attacks. There are man-in-the-middle attacks. We can just do some DNS poisoning or R poisoning, sit between the server and the client and listen to all the traffic that the client is sending. There may be port redirection attack. These are all related to man-in-the-middle attacks, where you are actually just sending the traffic somewhere and you sit in between and try to just send the traffic at some other port or some other client. Then there may be buffer overflow attacks. These are the attacks that exploit the programming vulnerabilities. Whenever some software is run, a buffer is created in the RAM. And within that buffer, if you try to send a lot of data, it may overflow the assigned capacity to it, and it may overflow to the critical components or the critical systems, the critical programs running in other portion of the RAM. So it may infect the kernel, or it may just directly gain access to the sensitive component or the sensitive data that is already available in the RAM. Then there are social engineering attacks. We already have seen that, pretexting, where a threat actor pretends to be someone else. Phishing attack, the spear phishing is a targeted phishing attack. Spamming, sending a lot of emails, sending a lot of SMSs that may contain harmful links, malware, or deceptive content. They may be quid pro quo, when an attacker requests personal information in exchange of some gifts or money. Baiting, he may leave a USB outside your door. You pick that up, you insert in your PC, and you get the malware. Tailgating, when a threat actor quickly follows an authorized person. Shoulder surfing is when a threat actor tries to look over and see what are you typing on your system. Similarly, there is dumpster diving, when a threat actor goes through all the trash that you have dumped in the dustbin. This is normally done by the spies of other countries or employees of other companies that are your rival. So cybersecurity is as strong as its weakest link, and human in the weakest link in the organization, and there should be constant cybersecurity training within an organization to create a security-aware culture. Then there are some network attacks, denial of service attack, where you're sending a lot of traffic, distributed denial of service attack, where you are sending a traffic from a lot of hosts, you are utilizing some botnet to send the traffic. You are just overwhelming the quantity of traffic that your server is able to control or to respond to. There may also be maliciously fault packets that may actually go in and just damage your system or damage the TCP/IP stack and actually shut down the system. So then there are distributed denial of service attacks. We have the zombies or the bots, and we have the handlers that bots connect to, and an attacker just issues command to the handlers. Handler issues command to those zombies, and these zombies then just can send a lot of traffic to a victim, and a victim is overwhelmed with the traffic and he cannot respond to every request and bogs down. These videos are available on your Cisco Netcat, and you can just see them to understand how these attacks actually work. So if there is a memory leak flaw in some system or in some program, the attacker can just try to exploit it to gain access to the system and also gain some sensitive information as well. The other is the ping of death. For example, you have seen that every packet has some specific data feed, and you cannot send more traffic to it than the specified limit. What if you send a lot of, you're sending a ping that is supposed to be very small, but you have sent a lot of data with it. The system may not be able to handle it and crash, so which will also result in some kind of denial of service attack. Then there are some evasion methods that are used to evade antiviruses or firewalls. They may use some encryption, some tunneling mechanism, or they can send a lot of traffic that your firewall will not be able to handle and your resources will be exhausted. Or an attacker may send the traffic at regular intervals by fragmenting a packet, and it will not be detected by the firewall. Then he may play with the headers, pretending to be some other packet. For example, he may pretend to send ICMP packet, but in the payload there may be something different. Similarly, there may be a traffic substitution attack. By obfuscating the data in the payload, he may just use Unicode, or he may use the base 54 encoding, and your antiviruses or the security solutions will not be able to understand what is the traffic actually going on. Similarly, there is traffic insertion. Someone is sending the data to a server. You just do the man-in-the-middle attack and insert some one or two packets of your own to just exploit the systems. Then there is the pivoting attack. Once you gain access to a system in an organization, you can use that system as the pivoting machine, and you can use that to scan other systems in the network as well. And you can use that system to attack further systems within the network. That is called the pivoting. You use a compromised system in the network and then use that system as a jump host to other systems. The rootkits, as I told you, that under the kernel of an operating system and are difficult to identify by the and eradicate by the adversaries, so they may hide the malicious activity to attacker. Similarly, the proxies, an attacker can just design a malware that automatically sets a proxy on the system. So what will happen is that whenever your system is trying to access the internet, the traffic will be routed to the proxy, and the attacker will be able to gain access to all the traffic that the client is using. So next module is regarding the network monitoring tools. So in the network, to mitigate these threats, we install different devices. First, we have the firewall, intrusion detection system, and intrusion prevention system, and some kind of endpoint security software that is installed on our board. So these solutions and technologies work in conjunction and provide automated monitoring, they generate alerts, and try to block and malicious activity. So, but for larger networks, an extra layer of protection is added. We have the SIEM software, where we have the SOAR software, where our SOC analysts just come in. So What is happening in the network is that we have the network flow, we see the bandwidth usage, we see the resource monitoring, and to monitor everything, we need some kind of network monitoring solution. So we have the tools, IDS, packet analyzers like Wireshark, SNMP protocol, NetFlow from Cisco, which can be used for network monitoring. But before our software or hardware can monitor the traffic, they need a copy of the data. So how they are going to get this copy is with the help of some tools, methods. The first is the network taps, also known as test access points, or we can just mirror a port on a switch, which we call it a span port or port mirroring. So what is happening is that if we have the network tap in between, everything that is going from firewall to the router to the network, one copy is being sent to the monitoring device, which may have some IDS software or some monitoring software that will be able to analyze it. So it is a passive splitting device. It is some kind of a hardware that sits between an area of interest in the network. So it forwards every kind of traffic, the complete 7 layers, and a copy of that is sent to our monitoring device. Then we have the other technique called port mirroring. What port mirroring does is that we can just we have some client ports on a switch and we have some trunking ports on a switch, which gather all the traffic and forward it to router or some other switch. We mirror a port. Normally, we mirror a trunking port that has all the traffic from the client devices, and we send it to a spanning port, and the spanning port is then connected to our analysis device. So we have ingest traffic, that the traffic that enters the switch, the egress traffic, the traffic that leaves the switch, and we have the source port, whose traffic is we are going to copy. Normally it is going to be some trunking port. And then we have a destination spanning port where we are actually copying the traffic, where our monitoring device is actually installed. So the association is called a span session, and in one session we can have multiple source span ports that are sending traffic to destination span port. And in some Cisco switches, we can actually send the traffic to multiple destinations as well. If we have some multiple devices, monitoring devices like IDS as well, NetFlow as well, we can just have multiple destination devices as well. So we have some tools. First, we have the protocol analyzers like Wireshark and TCP dump. NetFlow is from Cisco. And then we have the SIEM solution. Wireshark we have already seen. It can just monitor all the traffic and can tell you about what traffic is going on. But as we are getting a lot of traffic, we are getting a lot of protocols, it may seem overwhelming if you are trying to find some normality within the traffic. So if we are going to save the package, they are saved in a PCAP file. We can also use other software to capture the package. The command line, for example, we have the TCP dump utility that can just copy the packets in the background and save it in the PCAP file that we can just open it afterwards with Wireshark. Similarly, in Windows, we have WinDump or T-Shark. Then we have the Cisco technology called NetFlow, but it only works if you have the Cisco switches, and it performs the analysis part and gives you 24/7 analysis of what traffic is going on into your network. It can be used for network and security monitoring, planning, and traffic analysis, and it gives you complete audit trail of the traffic that is being forwarded from every packet or every port in the network. But we must have some ports sending all the traffic to NetFlow collector, which stores this data and then performs the analysis. Is just NetFlow, and then we have the SIEM solution. The SIEM solution is the main aggregator that collects all the logs from all the hosts, all the switches, all the routers in the network, and in larger organizations, SIEM solution is a must. So it records all the logs, it gives you a correlation by correlating the logs from different devices or from different logs from the same device. It generates some alerts, it aggregates that, it gives you some reports, and then you can actually analyze those reports as well by performing some forensic on it and detecting that whether the alert generated is actually correct or some false alert has been generated. So once it generates some alerts, it also gives out additional information such as the user that is logged on the device, the authentication status, location, the manufacturer, the MAC address, the IP address, and all type of information that is there, and why it has been flagged it as an alert. Similarly, to augment SIEM, we have a SOAR solution that is the automation solution that automatically responds to these alerts. For example, if there is some system that generates an alert for a denial of service attack, it can automatically isolate that system from the network part, and then you can actually see in the scene what is happening and what is going on. And then once you have done the analysis part, you have done the forensics, and you are sure that the system is now clean, you can then actually call the system back on the network. So SOAR provides some kind of automation to you and automate security incident response. So it uses AI to detect incidents that aid in incident analysis and response. It automates complex incident response procedures in the security operations staff by executing those books, playbooks, and act on it. And it also gives you some dashboards and reports to document incident response to improve the SOC key functionality. So the other VM that we have, we will be seeing that in a later module, it has one SIEM solution installed that is based on the ELK suite. That is an open source suite for SIEM solution, which has different parts. The Kibana is browser-based analytics. Logstash is how it just collects the log and connects input to the output. And Elasticsearch is the actual search part that gives full text search engine. We have SolarWinds and Splunk and IBM QRadar as the popular SIEM solutions that are actually deployed. The most famous ones, in my point of view, are the IBM QRadar that is installed in most of the organizations. And the second one is the Splunk, but these are the enterprise solutions and cost a lot. And their open source alternatives are this ELK suite and Wazoo. Let's just see a few attacks on the IP and TCP layers. We have actually gone through this IP packet header. What are the different fields here? And now let's see some IP vulnerabilities. So there are a few attacks that can be performed on the IP layer. The first are the ICMP attacks. ICMP is the actual protocol that is used to ping the devices. Once you send a ping, an ICMP code request is sent, and an ICMP code reply comes out. But if you start sending a lot of ICMP pings with a spoofed source request, so what is going to happen if an attacker spoofs its source address and send a ping to a victim? The reply will be sent to a spoofed address. And if you have a victim and you send a lot of these requests to multiple systems, these all systems will start replying to the victim, and the victim will be bogged down, as he will not be able to monitor or to judge all the traffic that is legitimate, and it will not be able to differentiate it. So it is a kind of a reflection and the amplification attack, that you are sending a lot of requests to where, and all the systems are replying back to the victim. Then we have the ARP-spoofing attack, which we use to just perform the man-in-the-middle attack. We send unsolicited ARP replies that with the ARP protocol is used to map the IP address to the MAC layer, and we send a spoofed replies every time. We tell the victim that we are the main gateway, and we tell the gateway that we are the client. So the gateway is also sending us the traffic, and the client who wants to send the traffic to the actual gateway is also sending the traffic to us. So we are sitting in the middle of it with the help of our protocol. Similarly, we have TCP attacks. The first is the UDP one, where we can just flood it. There is no connection-oriented service in UDP. That's why UDP is used for streaming services. For example, watching Netflix, or when you are calling on WhatsApp, UDP protocol is being used. You can just bombard UDP packets to your victim for denial of service attack, and the victim will be bombed down. This is a very small module, just making you understand about the TCP and the UDP ones. Next, we have a few more attacks. This is the attack that we were talking about, that once a client wants to send the data to the gateway, he sends an ARP request asking for the MAC address of the gateway. But what attacker does is that he spoofs this MAC address. He tells the client that he owns that IP address and attaches his own MAC address to it. So now the client thinks that the gateway is the actual attacker PC, and it starts sending the data to itself. Similarly, we can have DNS tag. Similarly, the DNS just translates IP addresses to the website names to the IP addresses. Someone can actually spoof or poison the DNS cache and insert some spoof website over here. Or he can use a DNS server to perform a denial of service attack as well. there are different types of attacks that can be done. Moreover, the attackers can also use DNS tunneling attacks. What is done is that the antiviruses or intrusion detection systems may be detecting the type of traffic that is going out. But as the DNS traffic has to flow out, the attacker may send out the commands to the victim, the malicious command to the victim within the DNS request. The packet will appear as a DNS packet but will contain the command. Similarly, if it is just copying some data from the victim, he may tunnel it through the DNS request and DNS response packet. So he will not be caught with the normal antivirus or intrusion detection system because he is using the legitimate DNS traffic. Similarly, DHCP is used to hand out the IP addresses to all the clients in the network. An attacker may just request a lot of IP addresses and exhaust all the IP addresses that are available with a router or the gateway. What will happen is then the switch will behave as a broadcast and every traffic will be sent to everyone, and the attacker will be able to just listen to all the traffic of all the systems within the network. So there are different HTTP and HTTPS stacks as well, which we saw in ethical hacker course. One attack with dependency is that malicious iframe. Attacker may create a web page and insert a malicious section or a malicious web page within that web page. So now you will see some URL will be seen as a very legitimate one, but as the attacker has inserted some malicious code somewhere within the website that you cannot actually see or interpret, that code will also be run. Similarly, we have the domain shadowing. They compromise a domain, then they create multiple subdomains of that domain to be used for attacks. Then there are the email attacks, which are spoofing, attachments, spam emails. Then there are SQL injection attacks, cross-site system attacks, and there are a number of attacks that attacker can do. Okay, we are going to start with understanding defense. Many of these things are being repeated over and over again, so a lot of stuff is repeated here as well. So first concept is defense in depth, and to understand this, we need to understand the basics. We have already seen these basics, but just let's have a review. The first thing are the assets. Assets are anything that is value to an organization that must be protected, which includes servers, any networking devices, routers, switches, PCs, and most importantly, assets. Asset is the data. So we have to protect the data. And it also includes the key personnel, your reputation of the organization. So anything that is of value will come into an asset. And we do have the vulnerabilities then. And vulnerabilities are the weaknesses in the system or its design that could be exploited by some threat actor or by a hacker. So vulnerabilities are actually weaknesses that are exploited, and the threats are any potential danger to an asset. For example, the loss of data is one of the threats. Someone changing the data or doing some modification is another threat. So exploiting the vulnerabilities, attackers can do some damage, and these damages are classified as threats that can happen to our assets. So how do we identify the assets? So before jumping over to uh, installing the security devices, we must identify the key assets that are in our organization. So there must be some system where we keep or where the organization keeps some inventory of the assets, and there should be some diagram listing where are the key servers, where are the key applications installed, and what protection is needed at what layer. And we also need to develop some policies and procedures to protect them. So we are identifying the assets and then defining some policies how we want these assets to be protected, and procedures will tell us how we actually want them to be done. So, but this task is becoming more and more difficult for organizations because even in small organizations, the number of assets is increasing day by day. There are a lot of users, internal users, external users, mobile workers. Some organizations have shifted their servers to cloud. They are, have established a virtual services. Everything is virtualized. So this task is becoming more and more daunting. Now there is no actual boundary. If we go into the classical sense, the boundaries are expanding a lot. There is no specific boundary we can say that where we can put in some firewall and assume that we are protected. Next, the organizations need to identify where the critical information actually is and where the actual critical systems are installed. Similarly, the threat to each asset will be different. For example, there may be threat to a switch that it can be stolen or it can be burnt by electric fluctuation. This is one of the threats. Similarly, there can be a threat to a physical threat that someone can impersonate another person and get in. So there can be different kinds of threats depending upon the asset. Uh, for data, there is a threat that it can be leaked or it can be stolen or it can be modified. So every asset has varying uh, level of threats or varying threats, and for we need to note down these as well. So in our organization, first we identify the assets, we identify the policies and procedures that are applicable for us, we identify the vulnerabilities of them, we identify the actual threats that are applicable for each asset. So after the threat identification, we try to identify the vulnerabilities. This provides our information that what are the possible vulnerabilities of each system. There may be different kinds of systems installed. There may be some servers still using Windows 7 because the application that they are serving is still not updated. And we need to identify the possible routes which can be taken by the threat actor to exploit these vulnerabilities. Then we also need to identify what will happen or what are the consequences if these vulnerabilities are actually exploited by the hacker. It may happen that there may be some vulnerability, but the chances of it being exploited are very low due to some protection over there, or maybe it is not even connected to the internet, or there is not some sensitive data over that is there. So even if it is exploited, there is not much a hacker can gain because there is no sensitive data in there. So we need to identify if something goes down or something goes left side, then what are the consequences, what are the damages, and how will it affect our organization. So there can be different types of threats. For example, this is an example of an e-banking system. An e-banking system, there may be a threat from internal bank system where some internal employee can try to access some data. Then there is a threat that or a vulnerability that an attacker can steal the personal and financial data of the customer from the customer's database. And then there may be a threat that there may be a full transaction from an external server. An attacker alters the code of the banking application and can fake can do a fake transaction. So these are some kind of we can say threats. Similarly, an attacker can steal the identity of a customer, can steal a smart card, or he can even steal a credit card and try to impersonate the person. Similarly, there may be data input errors that can be done intentionally or unintentionally by the bank employees or by the customers. Then there may be even some natural threats as well, like a data center may suffer severe damage uh, by some kind of flood or electric outages. Uh, Even then, it is a threat and it will cause significant damage to the reputation as well and the availability of data as well. So what the organization must do, they must adopt defense in depth approach. So in this approach, we do not rely on one layer of security. We try to implement security at different layers, at network edge, within the network, or at the network endpoints even. So the first, we can see that in an organization, the first line of defense is the router. Then there may be a firewall like Cisco ASA, and then there may be some systems like end-to-end prevention systems, advanced malware protection system, end-to-end detection systems that may augment this boundary security protocols for us. There may be some email content security systems, network access controls, and many more. So we apply or identify different kind of defense strategies that we can adopt, and we try to implement it in different type of layers. For example, if you see an example, the first line of defense is the R1 router, that the traffic that is coming from the internet, it has to block that over here. Only it should not allow traffic uh, uh, or it does not allow, it should not allow an independent and unchecked route of the traffic to the internal network. So the first check will be done by the router itself. Maybe there is some NAT over there which is also providing us some kind of security. Then there will be a firewall, which will be the second line of defense. So there will be a firewall that will just perform additional checks. It denies the connections. It's where we will write some rules that denies some port connections. Then there is a third layer, which is the internal routers. So these routers may be installed in different departments. So each department will have their router as a line of defense, and it will apply the final filtering rules on the traffic before it is forwarded to the destination. So we often give an example of this as a security onion, that just like an onion, there are different layers, uh, and at each layer there is some kind of security mechanism. For example, the internal most layer is the hardened devices. Then we have authentication services, content filtering, intrusion prevention systems, firewalls. So these all make some kind of protection, and after each layer you face, if you are an attacker, after each bypassing each layer, you are faced with another layer that is also doing some kind of protection. We also just give an example of defense in depth with this security artichoke mechanism. You can see in the diagram here, each we can say that if you peel one leaf, you will get another leaf. So this is also kind of that you have to prevent attacks or threats by having multiple layers. But this example or this diagram is now more relevant to modern scenarios because there is no one boundary wall. We cannot define which is the which will be the edge router, because now there may be different connections that are coming from different sides. There may be a connection from the cloud. There may be from internal employees connected through the branch offices. So now attacker, what needs to do? He needs to clearly identify which layers he need to peel down. He will only remove the leaves, or he will only remove the protection mechanisms that are protecting the asset that he is targeting. He doesn't need to breach all the layers. He will only peel the layers that are more relevant to his target. So to protect all this and to just keep it in some kind of an written form, we have some security policies, regulations, and standards. So first we have the business policies, which are the guidelines that are developed by an organization to govern its actions. And these policies govern what is expected in terms of security of an organization. They set a baseline of acceptable use. If that behavior is violated, then some alert is generated on the business net, generated, and we come to know that some policy has been violated in the network. So there are a number of policies that serve as guidelines uh, for a business to just identify any breaches or to prevent any breaches. So the company policies, they establish the main rules of conduct and responsibilities of both employers and employers. It often contains the rights, the privacy policies, and other relevant stuff. Then we have the employees policies, which are maintained by human resource staff to identify policy staff, to identify employees, their salary, pay schedule, etc. Then we are more interested in the security policies. So they define the security objective of a company. The security objective may be different for different or type of organizations. For example, for healthcare, we may say that availability is the main concern and not the integrity of the data. In some organizations, we regard that availability should be 100%. We cannot lose the availability of the customers. Like in healthcare, we cannot afford any loss of connectivity. Similarly, in banking sector, we cannot lose the integrity. We may afford that banks go down for a minute or two, but we cannot afford that the balance in the customer account is changed. This is a governing document that defines all these our objectives, what are the rules and behaviors that are expected by the from the employers, from the clients. And then in security policies, we have a number of other policies as well. So they are used to identify users, staff, and managers, the requirements of protecting technology, and their this policy should be very comprehensive because it demonstrates an organization commitment to security and it sets the expected rules of behavior. Once an organization goes for some kind of we say certification like ISO 27001 certification, the first thing that they check is that if an organization has a comprehensive policy that is understood by all people and it is uh, actually pasted somewhere where everyone can see it. So the security policy is one governing policy, and in the main security policy, then there are different policies listed that uh, that we can say that a company is the main security policy. And these policies depend upon the type of organization, what kind of organization is there, the policies may change according to that. For example, the first is the identification and authentication policy, that how you are going to authorize a person to use their local area networks or organizational resources. What are the password policies, minimum required length for a password, when should the password change. For example, in universities and schools, we may not bother about students repeating their passwords, but in banks, we are more concerned that the students, or sorry, the customers should change their passwords regularly. Then the acceptable use policy, how anyone can use, is allowed to use the organizational resources. Remote access policies, how the person or the employees can actually use the system, the organizational resources remotely, whether they are allowed to use their own devices or they need to be or they need to have organizational laptop or organizational PCs to connect to the system. Then there is some network maintenance policies, who is authorized to make changes in the network, in the operating systems, or in the PCs. And then we have the incident handling procedures. If there is any incident, how it will be handled. So next is the bring your own device policy. These are become very popular and very essential during the COVID area. Because now the people were working remotely in that at that time. So once they joined back, that they were bringing their own devices. So there had to be a policy that exactly determines that whether you are allowed to bring your own device or not, and who is allowed to bring his device to the company. For example, not all employees may be authorized to do that. Uh, you must remember that once you are connecting your own device to the company's network, you are actually putting down the risk of your device being damaged with malware, and that malware can transfer to the company network. So this policy should be very comprehensive, that who are allowed to bring their devices, which devices will be supported, what access level will be granted if you're using your own device, what can you actually do with that, and what cannot be done, and which regulations must be adhered to once you are bringing your own device. So these are just some best practices, that there should be some kind of password protected access, what should be allowed, that Wi-Fi is allowed or Bluetooth is allowed. It should be updated, the data should be backed up, and Find My Device should be enabled. If some device is lost with a company's data in it, it can be very damaging for an organization. So, Find My Device feature should be on for the laptop, for the mobile devices even. And some organizations go one step ahead and install their specific softwares like mobile device management software that enables the IT team to remotely configure and manage the customer's devices as well. Normally, they are installed in the company's own devices and not the personal devices of the employees. Then there are some regulations that will also be applicable on the employees, for example, or on the organization. For example, if you are working in Europe, GDPR will directly is applicable on the organization. If you are working with the credit card data, PCI DSS standard will be applicable. So the network security professionals must be familiar uh, with these with these standards as well, and with the code of ethics as well, that what should be done and what should not be done, what is allowed as per the ethics committee. And many organizations are mandated to develop and implement these policies. So these are actually forced by the government for the regulatory compliance, that these policies should be made and implemented in the organization. So the next module is the access control. So information security has basically three pillars. I think we actually we studied them in the ethical hacking course as well. These are confidentiality, integrity, and availability, also called the CIA triad. So the confidentiality states that only authorized individuals or entities can access sensitive information. It means that no unauthorized person should be able to access the data. And we are actually ensuring that with the help of cryptography, the symmetric and asymmetric cryptography, we are ensuring that data, when stored, when transmitted, is actually encrypted, and only the person having the right key should be able to decrypt it and should be able to read it. Then there is the other thing, that is integrity, that is the data should be protected from unauthorized editing or change. There should be no change in it. This also means that uh, the business processes must give the accurate results. If in banking transactions $100 are being deducted from an account, then they must be credited in some account in some form, to ensure that the sum always remains the same. The third is the availability part, that whenever you require data, it should be available to you. It should not happen that you are trying to access the data and you get an error message that the data is not available. Thanks.
Zero Trust Security. Zero Trust is a comprehensive approach for securing all access across the networks, applications, and environments. This approach helps secure access from users and devices, APIs, Internet of Things, microservices, containers, and many more. So, and it protects organization workforce, workloads, and the workplace as well. So the principle of zero trust states that never trust, always verify. So assume zero trust anytime someone or something requests access to an asset. You have to make sure that the person always has access or authorization to use that resource. And this, uh, we can say that this pessimistic approach helps us to prevent unauthorized access, contain breaches, and reduce the risk of attackers' lateral movement. It may happen that attacker may have gained access to some resource in the network, but if you are making him authenticate at every layer uh, due to trust security, then he will be caught somewhere. This means that although user or other entity may have successfully passed access control somewhere or previously, but they are not trusted to access another area or resource until they are authenticated again. So, but in some cases, the users may be required to authenticate multiple times in different gains to access to different layers of the network. We have seen that, for example, once you're logged into your Gmail, whenever you are changing some sensitive information, for example, some recovery email or recovery phone, you must have observed that it will again ask you the password. For example, you may have left your Gmail logged into some PC, and that person may be trying to change your recovery email or recovery phone number. So that's why they ask you the password again. That once you are making some sensitive change, they say that we are going to authenticate you again. Just enter your password again. So there are three pillars of trust: the workforce, the workloads, and the workplace. So the first is the people. This pillar consists of employees, contractors, partners, and vendors who have access to the work applications by using their own computers or the company managed computers. This pillar ensures only the right users and secure devices can access applications regardless of the location. Then is the workloads. So this is concerned with the applications that are actually running in the cloud, in data centers or in other virtualized environments that interact with each other. So these multiple applications are actually talking to each other, and they must constantly authenticate each application or each other so that the zero trust security is maintained at all times. Then is the zero trust for workplace. So this focuses on secure access for any or all devices, including Internet of Things, anything that connect to the enterprise network, such as PCs, laptops, other endpoints, servers, printers, etc., or any ICS control system as well. For example, the air conditioning control systems as well. Or in industries, there's maybe some kind of PLCs that are also required to be secured. So how do we actually implement these access control procedures? So we have multiple models for it. So the first model is that the discretionary access control model. So normally we have this one on our PCs that the owner is allowed to dictate who has the access to a document. So there are some access control list, or if you go into your properties of your any file, you will see that who has access to this file. So this is implemented by the whole power is with the owner of a resource. This is the normal thing that is happening on our computers. We can share the data with the other users if we want, if the other users are on the same network or on the same computer. Then there is the mandatory access control. This is like the access control in the military. For each resource, for example, for each document, there are some levels defined that it is secret, it is top secret, it is confidential. And for each person as well, or for each resource as well, these levels are also defined. For example, one person has the security classification of secret, top secret, or confidential. So the person having only the appropriate security classification, for example, if he has the security clearance for secret, only then he will be able to read the secret documents. And it is actually implemented by the system itself. So the task of the admin here is that he has to define which resource has which classification and which person has which security clearance. So, but the mapping of security classification with the security clearance is done by the system automatically. Then there are role-based access controls. Nowadays, there are different groups on the computers as well. You will see that there are different groups. And for each group, some rights are actually defined. And if you are promoted to that group, you get all the rights for that group as well. For example, if you are first a teacher and then you are promoted to a principal, then your user name or the user of the computer will be added into the principal's group. And now you will be having all the rights that the principal group has. Similarly, there are attribute-based group controls, role-based access controls, and time-based access controls. These are actually the fine-tuned controls. For example, we can define that a person can log in from 8 to 3 only. This may be some kind of a time-based rule, or there may be some attribute that these three conditions must be true, only then you can log in. For example, only this person is allowed to log in from only one computer at this time, and he can access only this resource as well. So there may be different attributes as well, the time frame as well, and the rule-based controls as well. Then there is AAA usage and operation. So a network must be defined who is allowed to access what resource. And even once he is connected to a network, what authorization he must have and what anything that he does on the network, it should be logged. So there comes three things. These are AAA, which we normally hear in our security groups. These are authentication, authorization, and accounting. Authentication ensures that it is done using the username and password, using biometrics, that you have some kind of access to the resource. Then there is authorization, that even after you are authenticated, what actions you can actually perform. For example, there can be a restriction that user can access some server using SSH only. He cannot directly log in using RDP. Then there is the third is the accounting part, that should be some logging mechanism that is keeping track what each user is doing, and if there is some incident, then we should be able to trace back who did something wrong that caused some incident. So this is similar to AAA operation of a credit card. For example, once you have the credit card, uh, it means that you are authenticated. The you are actually entering your PIN code, which is authenticating you. Then there is authorization, how much you can spend. There is some daily limit to spend and receive. And then there is the accounting part, that is the bank statement, that is actually keeping a log of every transaction that you are actually doing. So the PIN code is actually authenticating you, authorization is how much money you can spend, and accounting is what did you spend it on, and it is keeping track using those banking statements. So in AAA, authentication can be used to authenticate user for administrative access, or it can be used to authenticate users for remote access as well. So we can define who can actually log in from homes as well, and who can do some administrative tasks. So there are two types of authentications actually, local authentication and remote authentication. So in local authentication, the client establish a connection with the router, for example, and the router prompts the user to enter a username and password, and the user client provides the password, and he is authenticated to the network. Then there may be a central server as well, which is we call it the radius server, or some server that is central server that is providing us all the authentication. For example, some Active Directory server as well, or in some wireless networks we also see these kind of servers where they, instead of entering the password, you have to provide the username and the password for the server as well. So once you are actually connected to the router, your request for authentication is forwarded to the main server, and you are actually entering your username and password to the server, which is actually authenticating you over there. So the main server is actually authenticating you. This centralized AAA authentication is more scalable and manageable than local authentication, and therefore it is the preferred AAA implementation mechanism. So it may independently maintain database for authentication, and it actually shifts the authentication security to a centralized server, so it is easier to maintain. You do not have to save credentials everywhere on the network. So it can leverage Active Directory or LDAP for user authentication, and it can authorize group memberships, accounting databases, etc. And you can communicate with this server using remote dial-in services or the other type of protocols. For example, the most used ones are the Radius and TechCast protocols, and we can implement them on the Wi-Fi network as well. So these are just the differences between them. But the most important thing is that these centralized servers maintain logs, and which are also stored centrally at one location. So the correlation of data becomes very easy, and you can actually do the security auditing where someone has actually tried to log in, tried to log out, and we can actually combine it with AAA authentication, that whenever someone is logging in, send the log to this logging server. So everything is being done centrally at an organization, so which makes life of security professional easier. So this accounting provides more security than the just authentication. It gives a detailed log what the authenticated user does on the device. So everything that you do, you execute something, you install something, everything is logged on. And it helps to trace back if there is some kind of security incident. So there are different types of accounting mechanisms that are required in the organization. So there must be some network accounting, which logs all the packets of different protocols, what protocols are flowing, what data is being transmitted. Then there's a connection accounting, execution accounting, who is making a connection at what, who is executing commands and what commands are being executed on the terminal, the system accounting, command accounting, and the resource accounting. So these are different kinds of logs that are actually being done at the resource level, and that may help us to trace any security incident, what is going on in the network. This was module 19. Let's just move to module 20. Let me load this lecture. Next module is threat intelligence. So there are different type of information sources that helps us to gather information about the recent threats or the vulnerabilities that are being exploited in the wild. So this threat intelligence is actually dealing with that how we can keep ourselves abreast with the latest happenings in the security world so that we are able to ensure that our organization is secure and we are actually having some defenses for the latest vulnerabilities or for the latest threats. So there are a few of these resources. So a security team or a security professional must always keep him abreast with the latest trends, which should include some subscribing to real-time feeds regarding threats, some pursuing security-related websites, following security blogs and podcasts, and more. And secondly, as threats are being upgraded, the more and more complex type of trojans, the viruses and malwares are coming in the market. So he should upgrade his skills accordingly by attending some workshops, conferences, and trainings. So network security has a very deep learning curve and requires a commitment that goes for complete life. It cannot happen that you learn some skill and you just get content with that. Now I have become a security professional. You have to just keep yourself upgrading to stay ahead of threat actors. So these are a few organizations that help security people to stay ahead of these threats. First is the SANS, which is the most reputed organization in the world, and it has a lot of certifications as well, but they are too costly. For example, each training I think costs around $4,000. But these are the most recognized ones in the world. They give you in-person training for example, forensic, malware analysis, and they have resources as well that provide you some real-life early warning systems. They, for example, they have Internet Storm Center, News Bytes, Risk, and Reading Room. They also keep publishing some white papers, etc. So you have to stay ahead and keep following them as well. Then there is the MITRE, which keeps record of all the common vulnerabilities, the CVs which you see, CV numbers that are actually maintained by the MITRE organization, which is also a prominent security organization. Then there is the forum of incident response and security teams called FIRST. So there are, it helps to bring together the incident response responders, forensic analysts, and malware teams to share information insights, incident prevention, and rapid reaction. Then there is Security Newswire that aggregates the latest breaking news pertaining to alerts, exploiting, and vulnerabilities. Similarly, there is ISC2, which also provides certification like CISP and CISA, and it is also a well-recognized organization that also provides uh, these threat alerts. Then there is a CIS, that is Center for Internet Security. It also provides cyber threat prevention, detection, and some threat warning alerts. Then there are Cisco cybersecurity reports as well. Cisco also publishes these reports, which are annual and mid-year cybersecurity reports, and they provide update what is happening in the world, expert analysis of top vulnerabilities that is affecting the organizations and the factors affecting the why these vulnerabilities are actually being exploited in the wild, what we are actually doing wrong. So, as a cybersecurity analyst, we must subscribe and read these reports in detail to learn how the threat actors are targeting their networks. Then there are security blogs and podcasts. There are different type of blogs. Even Cisco has one. Then there is Cisco Talus group as well. There are over 80 podcasts that can be played over the net or can be downloaded as well. But the most important one are the threat intelligence services, which keeps eye on indicators of compromise. It gives you some graphical interface where some threat actor is actually uh, working on and where some incident has actually happened. So the first one is the Cisco Talus. It is one of the largest commercial intelligence teams in the world. It can collects information about active threats, emerging threats, and provides feedback how we can prevent ourselves from these. So it is a very real-time intelligence that is being provided, and there are a lot of free resources, softwares as well, and that are also provided free that we can install and we can gain advantage of. Then there is FireEye. It is also another security company that provides these threat intelligence services as well. It offers also the SIEM solutions for the uh, SOC as well, which can be installed and which is integrated with their threat intelligence platform, getting some real-time threat alerts and ensuring that your security operations center is always updated and know what threats are being faced nowadays. So the FireEye security system also blocks attacks across web and email threat vectors, malwares. So it is an advanced antivirus, you can say, that prevents malware or detects malware with some kind of heuristic approach as well, and is way ahead of signature based detection that is mostly used in the antiviruses. It may be able to even detect zero-day threats by analyzing the behavior of the threat or the file that is running on your system. Then US Department of Homeland Security also offers some automated indicator sharing service. It enables the real-time sharing of cyber threat indicators across federal government and a private sector. It is an ecosystem that you can put in some threat alert as well. The other people are also sharing the alerts, and then these are correlated. And the major one is the CV that is supported by the MITRE. And for whenever some vulnerability is detected in the wild, it is published and it is given a CVE number. So we have a dictionary of publicly known cybersecurity vulnerabilities. They are actually sorted by year, and it makes identifying these vulnerabilities much easier than reading the description. Now, for each vulnerability, we have a number. We can identify those and we can try to patch these. Then there are some standards that are used to exchange data uh, regarding the latest threats. The most common one is the STIX framework. It also has some language which is used to share the alerts, and that can be integrated with different platforms. Similarly, we have this trusted automated exchange of indicator information, and then we have the cybox. But the most important or the most used one is the STIX standard that is used for sharing of this threat intelligence data. Then we have this MIST platform as well, which is supported by European Union and is used by 6,000 organizations. And it enables sharing of indicators of compromise between people and machines by using sticks and other export formats. So sticks is the major format that is used for sharing of information, and you can have any threat intelligence platform running, and you can use sticks to import that information. And these threat intelligence platforms provide you the some indicators of compromise, what techniques, tools are being used by the attackers in the wild. They also provide you the information about the reputation of IP addresses and website domain names. You can just put in some IP address over there, and they will tell you that this IP address has been used in these attacks, and its reputation is not that good, so avoid that. So this was all about threat intelligence.
So today we will start from introduction to cryptography. This is the general layout of what we are going to discuss in the crypto lecture. So we have been talking about the CIA tried that confidentiality, integrity, and availability. So in this lecture, we are going to ensure or we are going to see how confidentiality and integrity they can be ensured with the help of cryptography or cryptographic protocols. And if we remember, confidentiality is ensuring that information is accessible to those who are authorized to have access. It means that if I am sending some document to someone else and I must password protect it. What password protection does is that it encrypts the document, and even if someone intercepts it or if you distribute it widely with everyone without distributing the password, even though they have the document, they will not be able to access it. So the confidentiality is that using some crypto techniques, using some cryptography, we ensure that only the person who has access to it can actually open it or read it or run it. The second thing is that integrity, that if I'm sending some document to someone else, even if a comma or any single letter is changed, the other recipient should be able to make out that something has changed in the document and we can verify its integrity. So integrity is in safeguarding the accuracy and completeness of information and processing methods. There should not be uh, change, it should be complete, it should be received as it was sent. So cryptography protocols that we are going to discuss today are going to target this. Availability is mostly not covered through, uh, we can say, cryptography techniques, and it is mostly done through backups, through some increasing resources, some mechanisms like that. So cryptology is actually the main branch uh, of mathematics that deals with encryption. And normally we hear the term cryptography because we have the algorithms, metric algorithms, asymmetric algorithms, which you are going to see in the lecture, and the protocols in it. Protocols are actually the implementation of these tools, metric and asymmetric. Like we say that internet uses asymmetric protocol for authentication. So HTTPS is using those. So protocol is HTTP, but it is using those kind of algorithms. Then comes the cryptanalysis part, which we are not going to discuss, but it is actually analyzing these protocols and algorithms to find a backdoor in them, to find the weaknesses in them. So in war, like in World War II, we have seen that Enigma was broken. So by the Germans, well, their all communication was being intercepted. So the scientists employed the cryptanalysis techniques to systematically analyze the algorithms, and they made sure that they found some weakness in the algorithm itself. So cryptography is actually where security engineering meets the mathematics. And we have seen that it is mostly called the art of secret writing if we go back in time. And its main purpose was to scramble or encrypt text in such a manner that it is unreadable by anyone except the intended receiver. It has been used in the past by spies, ambassadors, kings, generals for crucial tasks. And what we have discussed is that the cryptanalysis is then the analysis of that algorithm to find some weaknesses in the algorithm. So if we go back into the history, the early evidence of cryptography exists in Egypt. The Egyptians have known to be using some kind of cryptographic techniques. Then we have the Enigma machine that was used in World War. It was used by Germans, and it was actually the first one that was broken by the scientists, and they were able to read every message that was being encrypted by the Enigma, and which was a major success for the scientists to break this encryption. Similarly, the Julius Caesar cipher, Julius Caesar is known to use a cipher that was just shifting the cipher. We will see the cipher how does it work, and it was used to communicate messages to his generals, and it was around 100 BC. So cryptography has been around for centuries, and people have been finding ways and techniques to actually communicate with each other securely. So how this Julius Caesar cipher works was that there was a small key. For example, if the key was 3, it means that each letter in the alphabet needs to be shifted by 3 letters. So if you A will, so A will become the D, B will become E, and so on. And if you look at the bottom of the slide, you will see that Caesar was a smart guy, right? Can be encrypted with these gibberish type of characters. And by seeing the characters, it is very difficult to find out how these are being encrypted. So there was a variation of Caesar cipher as well. Caesar used the key of 3. Now there was a rot 13 as well, where we shift each characters by 13 positions. And using this 13 was very specific. Why? Because in English we have 26 alphabets. If we give a rotation of 13 and then we again rotate it by 13, we come back to the 26th position. It means the encryption and decryption process was same. We have to move ahead of 13 positions. So this kind of ciphers are called self-inverse ciphers. So if the importance of these ciphers is that uh, if you think about hardware resources, you don't have to plan 2 separate circuits. You have to plan one circuit. The same circuit can be used to encrypt and decrypt the message. So now we have seen the 2 ciphers, the key of 3 and the key of 13. So now there are 26 only possible alphabets. So it means that there are only a limited amount of keys. So we can, if you uh, look how we can break it, we can actually try these keys one by one and see the message if something makes sense. So there are a number of tools as well that can help us. There's one decode.fr, cyberset as well, which can help you to break it. Now let's see the types of cryptography. So there are actually 2 types of cryptography, and the difference is very simple. One is symmetric and the other is asymmetric. In symmetric cryptography, only one key is used, meaning that the same key is used for encryption and decryption. Just like that, we enter the password of Wi-Fi device in our mobile device, or the password of Excel or Word files that we encrypt. This is actually the type of symmetric cryptography. But the issue is that we have to share this key with our recipient R size. So we are encrypting the Word document, but what is happening is that we have to tell the recipient what is the password by some SMS, WhatsApp, or something like that. Then the other is asymmetric cryptography. So in asymmetric cryptography, there is actually a pair of keys. You can encrypt traffic with one key, and only the other key can be used to decrypt it. It is only a complete pair. So it is also called the public private key cryptography, this asymmetric cryptography, and it is used in the internet certificates as well, like in HTTPS. So one key is called the public key that is actually distributed to everyone, and everyone can encrypt the data with that key and send it to the recipient. Now the recipient has the other part, the private key, and he can use that part of the key to actually decrypt it and read that information. The same is utilized in the internet HTTPS protocol. Once you are visiting any website, a certificate is presented to you by the website. The certificate actually contains the public key, and the web browser knows that this is the key. It can encrypt the data with it and send it across to the Facebook. Facebook now has the private key to itself, and it can decrypt it. Let's just discuss now symmetric encryption. So symmetric cryptography is also called the private key cryptography or the single key cryptography, and here it was historically before 1970s. All cryptography that existed was symmetric cryptography. People didn't know that it was possible that we can use two keys. Then some mathematical formulas, geniuses came along and they introduced the public cryptography in late 1970s. The sender uses the key to encrypt the message before transmission, and the receiver can use the same key to decrypt and recover the original message. So you can just see the example that Alice and Bob want to communicate with it, and there is some unencrypted channel or unsecure channel, and there is, if someone is there who has access to it, if he can even read that. If it is encrypted, our problem says that even if he intercepts it, he should not be able to read it. So what we do is that the Bob is going to encrypt the data, this E, that is some encryption function. He is going to encrypt the X with E, and a Y is the output, that is actually scrambled text, that is after we receive the encryption message, and he sends it across the insecure channel. And if even she intercepts that, will not be able to read that. And once it reaches the LS, she can input the key and decrypt it. So the main functionality is being established through the keys. So Alice is going to share the key with the Bob, and the Bob is going to share the key with the Alice. So they must have the same key with them. So what happens is that if you look at the bottom of the diagram, we need some other secure channels to distribute these keys. This is the main flaw in symmetric cryptography, the distribution of keys. If there are a number of people, then you must have a separate key for each one. This cannot happen that you use the same key and share it across the complete classroom. If there are, if you look closely at the example of a classroom, if there are 25 students in the class and there is one teacher, and the teacher wants to ensure that no one should be able to read the file of other students, so the teacher needs to establish 25 keys with his students, 25 different keys. How she is going to manage that? This is very difficult task, that to record these keys. This is also going to create a security dilemma as well as the storage dilemma, where she should put the keys and the number of keys will also increase with the size. Then there is the transmission issue, how they are going to share those keys. So we need a separate secure channel for distribution of keys. Normally what we do is that we just send an SMS and include the password of the file, or we do it over the WhatsApp, or we can even physically tell the person that this is the password of the file that I've shared you on the WhatsApp. So what we do normally is that we install the key, like Wi-Fi key, manually onto the system, and the system is only secure till the time it doesn't learn the key. The encryption algorithm is known to everyone. We have been using the same algorithms for last 20-25 years. How this algorithm works is known to everyone around the world. And people have been trying to break the algorithms itself, where the cryptanalysis part comes into play. But the algorithms have till now stood still, and they have not been broken. So what an attacker needs to do is he needs to find out what is the actual key that is being used. So the problem of secure communication, which we had early on, is reduced to secure transmission and the storage of the keys. How we are going to transmit the keys, and how we are going to store these a large amount of keys. And this is an example of the Caesar cipher. So there is a plain text like 5 red balloons, some encryption takes place, a ciphertext comes into play, and here the key is 3. If the attacker knows that the key is 3, he can easily just decrypt it. It is no big deal to him. He can just move back 3 characters and he can retrieve those text messages. Here the key is 7. So how you are going to actually do that in the computer terms or in the mathematical form is that you assign each character a number. Like you start from 0 and you reach 25, and then you just add the key to it. Like A is 0, then just add the key value to it for 7, and the result is the resulting 7, and you can just replace A with age. So this is how actually the computers do it. They represent these alphabets, the numerical values with some number, and then these numbers are actually manipulated with the help of key, and the ciphertext comes into play. These are the mathematical formulas. So we don't need to go into too detail, but in the end, there is the key and the cipher and the text, and we take the mod of total number of characters that are in our text. Like for example, we have the 26 here. So these are the major symmetric algorithms that we are using. Dash 3 dash. Here the key size is 56 bits. Then there are 128 bits. We actually use the dash 3 times. Then it is called 3 dash. Then AES, which is the most modern one, it has different amounts of bits, 128, 192, and 256 bits. There are different flavors. There is blowfish as well. So if the key size increases, the number of brute forcing attempts the attacker needs to make also increases. So the key size is directly proportional to the, we can say, the security of the key. So nowadays, normally we prefer this AES 128 or 256. That is most implemented symmetric algorithm. Now let's just see the asymmetric encryption. So I told you that in asymmetric cryptography, we use two keys. One key is the public one, the other one is the private key. So Bob gives his Alice his public key, which is known to everyone, and the Alice will send the data encrypted with the Bob's public key. And only a person who knows Bob's private key can decrypt it and get the text. And this private key is actually kept very personal, and it remains with the Bob himself. Just another example that if you want to send the data to the Bob, then encrypt it with the Bob's public key. It will be the data will be encrypted with the recipient's public key. You must remember this one. Not your own data will be encrypted with the recipient's public key. So all encryption schemes around from start in 1976 were all using symmetric algorithms. So then some mathematicians, Daffy Hellman and Merkel, introduced a new algorithm for asymmetric encryption, and then we had this asymmetric one. And this algorithm is still being used. Daffy-Hellman algorithm is still one of the most used asymmetric algorithms. But let's now move towards the protocols and how these are being actually utilized. So the majority of today's protocols do not rely on any one or symmetric or asymmetric. Rather, we are using some hybrid schemes. For example, the symmetric ciphers are being used for encryption and asymmetric is used for key exchange. Why? Because symmetric algorithms are very fast for encryption. Asymmetrics are more secure, we can say, because the possibility of having only two keys or one pair just increases our efficiency. We don't need to have a separate key for every single one of the users. Like if you take the example of Facebook, it doesn't need to have a separate key shared in isolation with its millions of subscribers. It only needs to share the Facebook needs to only share its public key, and everyone can just give the data with its public key and send it across. So what nowadays we are doing is we are actually just using this asymmetric cipher to send or exchange a new key for symmetric ciphers, and then we just start using the AES. So we use asymmetric ciphers to solve the problem of key exchange, and then for efficiency we use the symmetric algorithm. So these are some of the tools that you can actually use to actually test, or if you want to have something encrypted, you can download this and encrypt your text or your files with these tools using different cryptographic algorithms. These allow or these support a number of algorithms. So what are the strengths of symmetric and asymmetric encryption? Symmetric is easier to implement, requires less processing power, and can be easily designed onto the circuit. And asymmetric, that distribution of keys is not an issue. In asymmetric, it is a non-security. It also provides digital signature. You can just encrypt the data with your own private key, and uh, people can decrypt the data with your public key and see that this data has been sent by you only. And this and in this manner, your digital signatures can be verified. And what are the weaknesses? Asymmetric is very slow. Even if your private key is compromised in asymmetric, everything is compromised because there is only one key. Messages received cannot be decrypted if the private key is lost. If you somehow lose your private key, you lose your access. And mind you that Bitcoin, Ethereum, these cryptocurrencies are also using asymmetric encryption. The wallets are actually the asymmetric encryption vaults. So if you lose the private key of your vault or of your Bitcoin wallet, you can never recover your Bitcoins. So Bitcoins are actually just create a pair of public-private key, and you share the Bitcoin address is actually the public key of the Bitcoin wallet, and the private key remains with you. But if you lose access to the private key, you lose all your Bitcoin. So this was regarding the ensuring confidentiality part. And now let's just see how we can ensure integrity. So for checking the integrity, uh, it is only used for checking the integrity, not for actually ensuring the integrity. Hacker can still be able to change it, but you will be able to check the change that this file has been changed. And here the hashing comes into play. It converts data into a fixed size of characters. Sometimes once you download some file from the internet, you must have observed that it also provides you a hash value. What is a hash value? It is actually a fingerprint of the message, and these do not have any key. Hash functions are actually the digital signatures. Part can be used to generate them, and other kind of cryptographic applications are also there. For example, uh, as hashes are irreversible, your passwords are actually saved as hash values in the databases. So even if your database is compromised, only the hashes are leaked, and as hashes are irreversible, your passwords cannot be actually retrieved from that. So hashing has actually two properties. There is a variable length input. Anything can be just inputted into it, just a single line or a GBs of a file, but the output will always be the same number of characters depending upon the uh, protocol that we are using for hashing. And a single change in the character will cause a major change in the output. For example, in the last two examples, you can see that one is I am not a cook, and the other is one I am not a cook. And you can see that the hash value of the message digest has changed a lot. So how do actually hashes break them? If they are irreversible, but we can still manage to actually crack them. How? Because we actually do the dictionary function. We just take a dictionary and start taking its hash values, and if and then compare it with the existing hash. If these two match, then it means that we have cracked the hash. As there is no key involved, so there is no actually, we can say that there is no actually change in the hash value. If you uh, take a hash value of a word once, its hash value will remain the same if you take the hash the second time, third time, or the fourth time. And there are some websites as well, like crackstation.net. If you put in the hash, it will try to reverse engineer it and tell you what the word has been used. It is mostly used for cracking the password. So that's why we say that use a complex password that is not in the dictionary, or it is not the most widely used password, so that even if someone grabs your hash, he will not be able to actually decode it. These are a few tools that you can actually utilize to calculate the hash values. So this is just a comparison that in symmetric we have only one key, in asymmetric we have two keys, in hashes we don't have any keys. Most common algorithms are SHA. In symmetric we have AES, in asymmetric we have RSA. Key management is a big issue in symmetric, asymmetric it is easy and secure. And you can check the speed. Hashing is very much faster. Symmetric is also fast, and asymmetric is slow. Complexity is medium in hashing and symmetric, but in asymmetric it is very complex algorithms. And these are just a few examples of the algorithms that are given in the end. You must have heard the term of SHA-256, that is the hash value, the hashing algorithm. AES and DES are the most common ones for symmetric, and RSA and DSA are the most used ones for asymmetric. RSA is used in the internet. RSA is used on the HTTPS. Now let's just see another thing, that is steganography. Steganography is the art of data hiding uh, by embedding information within a medium in an impresentable way. So it is actually the art of secret writing. So what it means is that we can actually embed some information in an image that is not visible with the naked eye. So it is a secret writing. We are actually not encrypting the information, we are hiding the data in some other kind of file. For example, we can hide some messages in the even video files, audio files, or in images. So what is the difference between steganography and cryptography is, in steganography, we are actually hiding the existence of the message. For example, we are using invisible ink, we are using tattoos underneath skin, and the method is itself some secret method, and it is being, we can say that it is being used to actually hide the message itself, the existence of the message itself. And whereas in cryptography, everyone knows that there is some message in there, so existence is not hidden, but no one can decrypt the meaning of the message. If he does not know the key, then he cannot actually know the meaning. So we can say that encryption encrypts the message but do not hide the message. Anyone can see that both parties are communicating and are using some messaging, are exchanging some messages. But in steganography, hides the existence of the secret message, do not use an encryption, and ideally no one can see that someone is talking to someone or exchanging some information. So there are a few tools. This OpenStack or Stack Online is used for hiding the messages in the images, whereas in steganography, in white space steganography, we are actually hiding the messages in Word files by hiding it in the blank spaces or using white, we can say white fonts or white colors. So if you have any message about, if you have any questions regarding this lecture, you can just ask. Otherwise, we can move towards the next module. So the next lecture is the module is regarding the endpoint protection. So we are using some kind of anti-malware or antivirus systems on our devices. So this is regarding that. So the term endpoint is defined in various ways. So we can define endpoints as hosts on the network that can access or be accessed by other hosts on the network. So this includes all computers, all servers, all switches and other kind of Internet of Things and any other sensory devices that you have in the network. It can also be security camera, controllers, or even light bulbs and appliances. So each endpoint is potentially a way for a malicious malware to gain access to the network. So in addition, new technologies such as cloud have expanded the boundaries. So malware can just infiltrate from anywhere. Moreover, the VPNs, you actually bypass the security restriction, you bypass the firewalls, so directly the malware can be injected from the VPN network from your own devices. So there are a lot of malware that we are just receiving. If you see at the diagram, the malicious spam percentage is increasing yearly. So as many attacks still originate from inside the network, we need to secure the devices itself. So without a secure LAN, users within an organization are still susceptible to network threats. It cannot happen that you just install some firewall or intrusion detection or prevention system on the boundary and you just feel that you are secured because you have isolated or you have just protected the actual ingress. But still, the malware is directly being injected onto the host devices, so we need to protect our LAN networks themselves. So if any one of the internal hosts is infected, it can actually become a starting point for an attacker to gain access to the critical system devices such as servers and sensitive information. So we have actually two internal LAN segments to secure. The first one is the endpoints, which are actually the hosts that consist of laptops, desktop, printers, servers, and IP phones, and all of which are actually vulnerable to malware. The second is the network infrastructure itself, and it includes switches, wireless access points, IP telephony services, and most of these devices are susceptible to LAN related attacks, which are just like MAC address table overflow attacks, spoofing attacks, DHCP related attacks, LAN storm attacks, FTP manipulation, and VLAN attacks. So there are a number of attacks that are still possible. So to protect these, we have host-based malware protection. So as the network perimeter is always expanding, people access corporate network resources from mobile devices that uses remote access technologies such as VPN. These devices are also used on unsecured or minimally secured public and home networks. So we have some host-based antiviruses and host-based firewalls that are used to protect these devices. So first we have the antivirus and anti-malware software. This is installed on a host to detect and mitigate viruses and malware. For example, we have the Windows Defender antivirus, we have Cisco AMP, Norton, McAfee, Trend Micro, etc. And how these are detecting viruses is they use actually three different approaches. First is the signature-based approach. This approach recognizes various characteristics of known malware. And actually, this has a large database of malware using their hashes, and it compares those hash values and just check them. Then heuristic-based approach, it is just checking the general features shared by various types of malware. Then there is behavior-based, what is happening or over your computer, over the network, detecting some malicious or suspicious behavior. And most of these antiviruses programs are able to provide real-time protection by analyzing data as it is used by the endpoints. They can also scan the malware that has entered the system before, and these are actually known as agent-based protection mechanisms that are installed on each host. Next is host-based firewall. This software is installed on a host and it restricts all incoming and outgoing connections to the connection stated by the host itself. It means that no incoming connection is allowed, only you are allowed to make outgoing connections. And some firewall software can also prevent hosts from becoming infected and stop infected hosts from spreading malware to other hosts. So a basic firewall is installed in the operating system, like Windows Defender firewall. Other solutions are also available. For example, the Linux uses IP tables and TCP wrapper tools. Then come the host-based security tools. So it is always recommended to install a complete host-based suite of security products on home networks as well as on business networks. So these include antiviruses, anti-phishing, safe browsing, etc. So like McAfee has its own set of tools. Norton has provided its own complete set of tools that you can install. And some host-based security programs will submit logs to a central location for analysis part as well. There are a number of host-based security programs available. For example, the AV test is the testing laboratory that you can actually check that compares different tools and give you advices or reviews of each set of tools. So new security architecture for borderless network address security challenges by having endpoints use network scanning elements. So there are a lot of network malware as well that are just being, we can say, being propagated automatically. So these network-based malware protection devices provide many more layers of scanning than a single point. Now we have next generation firewalls, intelligent prevention system, access control systems, and gateway security. And these set of devices actually work in conjunction with host-based techniques and are able to just stop the spread of malware. So we have different kind of devices and techniques. So we can use advanced malware protection. This provides endpoint protection from viruses and malware. We have email security appliance to protect the security. We have web security appliances or web firewalls as well that can actually filter out the attacks on web applications. Then we have network admission control that restricts the devices joining the network without any authorization. Once you connect your laptop to the switch, it asks for some authorization and only then it allows the device to the network itself. Then we have host-based intrusion protection. So host-based personal, or we can say the personal firewalls are standalone software programs that actually control entering or that can actually control the traffic entering or leaving a computer. So we have these applications also available for Android phones and tablets as well. And these firewalls actually use a predefined policies or profiles to control packets entering or leaving a computer. So they have some rules that you can actually modify or create that allows uh, uh, different type of IPs or ports, and they can also be configured to issue alerts to users if some suspicious behavior is detected, and they can then offer the user the ability to allow an application to actually go through the firewall and being run or not. So we have a Windows Defender firewall that was first included with Windows XP. Now we have it everywhere in Windows 7, 10, and 11 as well. So then we have the IP tables that is used by the Linux system administrators to configure the rules. Then we have NFT tables. This is also a firewall application that is used in the Linux. And then we have TCP wrappers as well that is also used for the Linux. Then we have host-based firewalls. These are standalone software programs that control traffic entering or leaving the computer. A host-based intrusion detection system is designed to prevent or protect hosts against known and unknown malware. So an HIDS is designed to protect will HIDS will frequently include a management server endpoint. There is going to be a server that is actually collecting the logs and generating alerts, and then It is a comprehensive security application that combines the functionality of anti-malware application with the firewall functionality, and it not only detects the malware but can also prevent it from executing it even if it reaches a host. So as host-based antivirus detection system actually run on each host, so we actually call it some agent-based system. So it can be said that host-based security system function as both detection and prevention system because they actually prevent known attacks and detect unknown potential attacks. HIDS system uses both proactive and reactive strategies, and it uses actually the signatures to detect known malware and actually prevent it from infecting the system. How this is strategy? However, this strategy is only effective against known malware. So then comes additional policies or additional techniques that this HIDS actually employs, which are number one, the anomaly based systems. The host system behavior is compared to some base model or normal behavior, and significant deviations from baseline are interpreted as a result of some sort of intrusion. And if some intrusion is detected, it can actually log it, send alerts, and take actions to prevent these kind of attacks. And the measured baseline is actually derived from both user and system behavior. And because malware can cause system behavior to change, anomaly detection can actually detect it and generate some alerts. Then there are policy-based systems as well, where the normal system behavior is described by some rules or the violation of rules that are predefined, and these are actually, we can say, the policies, and violation of these policies will generate some alert, or it will invite an automated action by the HIDS itself. Most HIDS system actually comes with predefined rules, with some baseline rules, and the system administrators can actually tailor those rules or actually add rules according to their requirements. So there are a number of HIDS tools, or we can say products on the market today, and most of these software utilize software that is installed on the host, and there is some central management system that allows integration with the network monitoring system and threat intelligence. So we have Cisco AMP, Alien Vault, and open source at HIDS security. Now let's just discuss some application security. If you remember, a vulnerability is actually a weakness in a system or its design that can actually be exploited by a threat. An attack surface is the total sum of vulnerabilities in a given system that is accessible to an attacker. And it can consist of open ports on the servers or the software that actually run internet-facing servers, wireless network protocol, or even users. And the network surface is actually expanding, and now with the help of Internet of Things, cloud, this is actually expanded a lot. So these devices are being connected through Internet of Things, bring your own devices, etc. So the components of attack surface now include the network attack surface, which the attack exploits vulnerabilities in the network itself. This can include wide and wireless, both protocols as well as the wireless protocols used by smartphones, IoT devices, etc. Then we have the software attack service. The attacks that are delivered through exploitation of vulnerabilities in the web, cloud, or host-based software applications. Then we have a human attack surface. This exploits weaknesses in the human behavior, such as social engineering, malicious behavior by trusted insiders, and users, errors or logical errors. So one way of decreasing the attack surface is to actually limit access to potential threats by creating a list of prohibited applications. So this is known as block listing. Application block list can dictate which users' applications are not permitted to run on a computer. Similarly, allow list can specify which programs are actually allowed to run. In this way, the known vulnerable applications or malicious applications can be prevented from creating vulnerabilities on network hosts. So allow lists are created in accordance with the security baseline that has been actually established by the organization. For example, we may actually disable that all unknown social media is disallowed. The WhatsApp application cannot be installed on the host itself, things like that. So the figure shows actually the Windows local group policy editor, and it has allow list settings. We can actually allow or disallow websites also, and we can actually create these manually, or they can be actually obtained from some uh, threat maintenance security services as well. A block list can be continuously updated by security services and distributed to firewalls. For example, if you have Fortinet in your organization, the Fortinet actually distributes this intermediary, or we can say after a few days, and these lists are updated automatically. And there are also some free services as well, like Cisco Telos or Spamhaus, which are just example of free block list services. So now just assume that you have received some malware. Now you know that this is some malware file and you need to analyze it. So we can use different sandboxes to actually analyze these. And sandboxing is a technique that allows suspicious files to be executed or analyzed in a safe environment. And we have some actually automated malware analysis sandboxes as well that offers tools to analyze malicious behavior. These tools actually observe the effect of running known malware so that the features of malicious uh, uh, behavior can be actually determined and then used to create a signature for it as well. And once we have analyzed that it is some kind of a malicious file, we can actually create some rules for it as well. So there are a few sandboxes that we have. For example, this Cuckoo sandbox is a free malware analysis sandbox. It can be actually run locally and have malware samples submitted to it for analysis. There are a number of online public sandboxes as well. For example, any.run, which can be actually utilized to upload the sample, and it will automatically do the analysis part. So the next is endpoint vulnerability assessment. So in order to detect a security incident, it is important to understand, characterize, and analyze information about normal network functioning. So network, servers, and hosts all exhibit typical behavior at a given point of time. And we can use this network and device profiling to provide a statistical baseline that serves as a reference point. And any unexplained deviation from the baseline may indicate a compromise. So care must be taken while capturing baseline data so that all normal operations are included in the baseline so that it may not trigger some false positive. So there are a number of elements that must be included. For example, it should include session durations, the typical session duration, the total throughput, the critical asset address space, the typical traffic pattern. Then we can also you do the server profiling, and it is used to establish the accepted and operating state of the server. It establishes the network, user, and application parameters that are accepted for a specific server. So, in order to establish a server profile, it is essential to understand the functions that a server is intended to perform in the network. So, it can be an email server, a web application server, so it will vary with each server. And from there, the various parameters like the ports that have been listening, the logged in user, service account, the software environments can be actually chalked out. So the network behavior is actually described by a large amount of diverse data. For example, the features of packet themselves, the telemetry from the other, we can say the nodes, and using techniques like big data analytics. So this is known as actually the network behavior analysis or NBA. This entails the use of sophisticated models for machine learning and statistics to compare behaviors with network performance at a given time. And any significant deviation can be actually indicator of the compromise. So the network vulnerability testing actually includes some kind of risk analysis, vulnerability assessment, and pen testing process. So in risk analysis, we are actually the individuals conduct comprehensive analysis of impact of attack on customer assets, on the company assets, and the normal functioning. Then we have the vulnerability assessment, like how the patches are being implemented, the port scanning, and the vulnerability scans. Then we do the pen testing part, where we actually try to exploit the vulnerabilities and see how well the defensive operations are actually performing. So we know the CVSS system. We have discussed it in the ethical hacker course as well. So it is a risk assessment tool that is designed to convey the common attributes and severity of vulnerabilities. It is vendor neutral, industry standard, an open framework, and we have different metrics, and they're all ways combined to provide a combined score. So it has to actually measure how much a critical a vulnerability is It provides an open framework with the meaning of each metric openly available to all users, and it helps prioritize the risk in a way that is meaningful to individual organizations. So we have different types of groups like base metric group, temporal metric group, and environmental metric group. And so the base metric actually represents the characteristics of the vulnerability that remains constant over time and across contexts. So we have exploitability, how it can be exploited, the impact metrics in terms of its effect on CIA. Then we have the temporal metric group. This measures the characteristics of a vulnerability that may change over time but not across user environments. So the severity of vulnerability may change over time as its countermeasures are actually deployed or the patches are available. Then we have environmental metric group. This measures the aspects of vulnerability that are rooted in a specific organization environment. And these metrics help to rate consequences within an organization and allow adjustment. In addition to the CVSS, we have the CVEs as well. So each vulnerability is actually given a CVE number by year. For example, a vulnerability is given a CVE of 2025-01. So it will be the vulnerability of number 1 that has been published in year 25. So it is actually a dictionary of common names in the form of CV identifiers for cybersecurity vulnerabilities, and it provides a standard way to actually research a reference to vulnerabilities. And once a vulnerability has been identified, a CV number is assigned to it, and then the threat intelligence services uses that CV identifier and publishes it in some kind of bulletins. So even if we have some logs or our scanners identify that identify the particular vulnerability by that CV number. Then we have the mission vulnerability database. So this utilizes CV identifier and supplies additional information on it, such as CVSS threat score, technical details, affected entities. So further, it is just extension of CV database, and it provides an additional information to it. And it is maintained by actually the US government, National Institute of Standards and Technology Agency. Next is secure device management. So in an organization, the risk management actually involves the selection and specification of security controls for an organization. So it is part of an ongoing process that involves the management of risk of organizations or to individuals associated with the operation of a system. So risk management is actually an ongoing multi-step cyclic process, and we are actually just seeing who is the threat actor that wants to attack us, what are the vulnerabilities that they can actually exploit, how we are affected, and such things like that. And we have a few, we can say, ways to respond to these threats. The first is the risk avoidance, that we actually stop performing the activities that create risk. It is possible that as a result of risk assessment, it is determined that the risk involved in the activity overweighs the benefit of activity, so we can just stop the activity itself. Then we can actually reduce the risk, that we can actually take measures to reduce the vulnerability and the risk involved in it. Risk sharing, shift some of the risk to other parties. For example, we can go for uh, uh, we can hire a security as a service organization that is actually that made responsible to ensure that this vulnerability is never exploited or to secure the. Or we can actually go for insurance. So nowadays we have also cyber insurance as well. So this is actually a method for risk saving. Then we have this retention as well. It says that just accept the risk and its consequences, and this is only applicable if the risk associated with vulnerability are very low, and the cost associated with risk mitigation is very high. So then we just accept the risk. Then we have vulnerability management. It is a security practice that is designed to proactively prevent the exploitation of IT vulnerabilities that exist with the organization, and the expected result is to reduce time and spend dealing with the vulnerability and exploitation. And we will try to reduce it. So the vulnerability management requires a robust means of identifying vulnerabilities based on vendor security bulletins and other information such as CVEs. Is it fine now?
Yes, it's much better. Yeah.
Okay. So the security professionals or personnel must be competent enough in assessing the impact. So we have to just first discover them, that we have to compare it against the baselines that we have actually defined early on, that these vulnerabilities exist. Then we have to prioritize the assets as well, that for example the servers needed to be secure first. Then we have to assess the damage that these vulnerabilities can cause, and then we have to actually manage those vulnerabilities or actually patch those. So moreover, we actually need to report them to the top level hierarchy as well. We have to document the security plan as well. If we are receiving, for example, traffic from a certain region, abnormal traffic, we are seeing that we are seeing a lot of traffic from Russia. We need to report that to our CERT, incident response centers, that we see and quantity of traffic from these areas. Then we need to remediate that, and after we have actually removed those vulnerabilities, we have actually to verify that the threat has actually been removed. Then the asset management, it involves the implementation of systems that track the location and configuration of network devices. So in an organization, there are a lot of assets. There are a lot of PCs, laptops, mobile devices. So, and the asset management or the inventory management is actually a quite cumbersome task. And to actually track those assets and to track the configuration for each asset actually just is a huge ask. So asset management not only tracks the corporate assets and other authorized devices, but can also be used to identify devices that are not authorized on the network. So we can just know that this device is connected to the network, but it is not authorized, so this should generate some alarm. We have some NIST policies as well, the publication like NIST uh, 80211 that just describes uh, how this should be inventory should be kept, and we should use some automated discovery and inventory of actual state of the devices, articulation of device state of those devices, whether the policies are installed on them, what are the configuration of them, and how we are going to actually identify the non-compliant authorized devices. For example, we may say that every device that is connected on the network must have some kind of antivirus installed. But if a device is authorized but antivirus is not installed, it should generate some alert that a non-compliant device is connected. Then we must remediate or accept the device state and repeat the process of regular at the regular intervals or just keep it as ongoing activity. So now most of the organizations employ some kind of mobile device management systems, especially in the age of bring your own device beyond systems that present special challenge to the asset management. So these devices, the mobile devices, cannot be actually physically controlled on the premises of an organization. They can be lost, stolen, or tampered with, uh, and they can put the complete network and the data at risk. So this MDM is there to ensure who is responsible for each device, and it is used for remote management of data, encrypting the data, enhancing device uh, uh, access with most robust authentication measures, and due to diversity of mobile devices, so these are less secure than the normal company devices. So the network administrator should assume that all mobile devices are actually untrusted until they have been properly secured by the organization using some kind of mobile device management system. So we have a lot of systems. For example, this is Cisco Meraki Manager that is shown. We have one from the Huawei as well, and one from the Samsung as well that different organizations are employing, which are actually used to manipulate the device remotely. Then we have comprehensive configuration management systems as well that address the inventory and control of hardware and software configuration of the system. Uh, Secure device configuration always reduce the security risk. So the organization actually provide laptops and computers to its employees, and if we have some configuration management systems, so we can actually manage the configuration of each device as per the university rules and regulations. So we have a lot of tools like Puppet, Chef, Ansible, and SourcePack that can actually automate this task. So the patch management is related to vulnerability management. Vulnerabilities frequently appear in critical clients, server, and network device operating systems, application software as well. Uh, Acrobat, Flash, and Java are also frequently discovered to have vulnerabilities. So the patch management involves all aspects of software patching, and it includes identifying the required patches, downloading them, installing them, and verifying that the patch is actually installed on all the devices in our organization. So installing patches is actually the most effective way to mitigate software vulnerabilities, and sometimes they are the only way to do so. So, and this patch management is actually also required by compliance organization, for example, HIPAA as well, the SOC as well. So this becomes one of the necessity of the any organization. And the patch management actually depends upon the patch management data to identify systems and what software they are actually running on. So we have the patch management software from SolarWinds, Landesk, and we have actually a software from Windows as well that you can actually utilize to ensure that patches are actually downloaded and installed in time for all the devices over the local area network. So we have different techniques how this patch management actually works. The first one is the patch management. This is something that is already exposed. It reports the vulnerable software version to the central server, and the central management server actually tells a patch exists. If some application requires a new patch, it installs that patch, and the agent is actually running with the admin privileges that can actually work in the background to install the patch. Then we have the agent and scanning as well. So these servers, the patch management servers can actually scan the network intermediately for devices, and they can actually scan that which software require patching. It is just like that to run an nmap scan that can enumerate the version, the server determines which patches are required, and install those patches on the cloud, on the client. So only devices that are on the scanned network segment can be patched in this way. And this can actually be very problematic. Not all devices report their complete data, and sometimes the data is not accurate. So this is a less preferred way. So the third method is passive network monitoring. In this method, the devices requiring patching are identified through the monitoring of traffic on the network. But this approach is only effective for software that include the versions in the network traffic. You can monitor the traffic and can see the patches or the version numbers of the different software installed on these applications, that you can actually install those. Then we have some ISMS systems or information security management systems. So an information security management system or ISMS consists of a framework that can actually identify and analyze the information or the security risk to an organization. You can actually, it is actually the same thing, that you are actually identifying the assets, the vulnerabilities that exist in your network. You actually plan that how you are going to actually cover that or to patch that, and then you take some action. So there is a standard called ISO 27001 that contains the set of controls that you can actually implement to secure the system. So first you need to identify the risk, the assets, the vulnerabilities to the assets to an organization. Then you need to develop and implement the safeguards. You need to plan those. Then you need to detect that if something wrong is happening, if there is something cybersecurity incident, You devise some incident response plan and see that if something happens, you are going to actually respond it, and then how you are going to recover it. So this is actually defined by the NIST cybersecurity framework. So next is a few technologies and protocols that actually help us to actually identify any malicious activity. So there are some common protocols that can help us to discover or monitor the traffic. The first one is the syslog. The syslog is the standard that is used for logging event messages. So everything that happens on the device, for example, if someone logs in, an event is generated, and if you have some centralized server, syslog server, the device can send the event message to it. So this standard allows for a system neutral transmitting, storing, and analyzing messages. For example, in your organization, you can have multiple vendors like Cisco, Juniper, Huawei, and they all support syslog. So there is a centralized server, they are sending logs to it, and then there can be a central monitoring system which can actually utilize those. And these servers are actually running on port UDP 514. And as syslog is important for security monitoring, so the syslog is actually a target for the threat actors. We have also seen that we are required to actually logs as well, so that we can hide our identity. So some exploits such as those involving data exfiltration can take a long time to complete due to very slow ways in which data is secretly stolen from the network. And the syslog server will contain the information that data is being exfiltrated. So what attackers are actually targeting is that they are actually going to just attempt or tamper with the logs that are stored on it till the time the data is being exfiltrated. There are a few other protocols as well, like syslog NG is being introduced, but it is not actually implemented till now. Next, we have the NTP, which is network time protocol. For the syslog messages are usually timestamped. It is very essential that the time on your all devices in the network are actually synced. So, time syncing, we use the NTP. This allows messages from different sources to be organized by time to provide communication processes. So NTP uses a hierarchy of authoritative and sources to share time information. And the time is not consistent, so we can actually correlate the logs. Threat actors may attempt to attack the entity infrastructure in order to corrupt the timestamps. So if the timestamps are wrong, then the logs cannot be correlated and it may even lose some alert. It will not generate the alert. Then we have the DNS as well. The DNS is used by millions of people daily, and because of this, organizations have less stringent policies in place to protect against DNS threats. Organizations have recognized this, and now we see hackers exploiting DNS tunneling. So what hackers does is that for exfiltrating data, is actually using DNS tunneling, hiding data in the DNS request or responses, and And in this manner, the many we can say that security protections are bypassed. So hypertext protocol or HTTP is actually the backbone of our web or the internet. However, all the information carried in HTTP is transmitted in plain text from source computer to the destination, and it does not protect data from any alteration or deception by malicious parties, which is actually a threat uh, itself. And all browsing history should be considered as a. So there are a number of vulnerabilities as well for the HTTP as well. We have the iframe or inline frame injection. We can inject some malicious scripts, launch servers, and these web servers can actually connect browsers to infected servers by loading files. Then we have the email protocols such as SMTP, POP3 that can also be used by the threat actors to spread malware and exfiltrate data as well, or they can even be used as command and control channels. So SMTP sends data from a host to an email server and between mail servers. And like DNS and SMTP, it is also a common protocol to see in the network and is also not secured much. As there are a lot of traffic for SMTP, it is normally it is also ignored. So Met and POP3 are used to download messages from a mail server. For this reason, there are application protocols that are responsible for bringing the malware to the host. People have been using this POP3 and IMAP directly to just distribute the malware. Then we have the ICMP protocol that is actually utilized in the brain functionality. So ICMP can be used to identify hosts on the network, the structure, and determine the operating system that is being used. However, this can also be used for data exfiltration. So people have been actually encapsulating the data within these ping requests. So as this traffic is on the inside network is actually overlooked, so people have used various varieties of malware that use crafted ICMP packets to transfer files from infected hosts to the threat actors. So now we have some security technologies as well. The first one is the ACN. So the access control lists are actually implemented over routers and firewalls that allow to filter the traffic. So the figure illustrates the use of ACL to permit only specific type of ICMP traffic. We can actually block some protocol, we can allow some port, we can actually deny all the traffic from a source or a destination. For example, if we see that this IP address is involved in some attack, we can actually block it with the help of ACL. So writers can determine which IP addresses, protocols, and ports are allowed by ACL. This can be done either by port scanning, pen testing, or through other reconnaissance. Attackers then can craft a package that use two source addresses. So applications can with reports and other features of protocol traffic can also be manipulated, such as some flags in TCP segments. And rules cannot be anticipated and configured for all emerging packet manipulation techniques. There are So there are a few things that we can do. Not all attacks can be stopped. So in order to detect and react to packet manipulation, more sophisticated behavior and context measures need to be taken, and we cannot rely only on the ACL itself. Then we have the NAT and PAT as well that can complicate the security monitoring as multiple IP addresses are mapped to one or more public addresses. Just like that, we are connected to our home network, and all devices have one public address. So the internet call can only see the public address of the router. So uh, if that is in fact, it can be difficult to log the specific inside device that was actually involved in the attack. For example, if there is a large organization having some PAT or NAT solution installed, it becomes very difficult to pinpoint the actual device that was actually spreading the malware, as we will only see one public IP address. Then we are facing difficulty with the help of systems. We have now HTTPS, cannot actually monitor the traffic that is going on. Similarly, we have now VPN that is also not cannot be analyzed as such. And we have different settling techniques that hackers can utilize to evade the detection and evade the detection and spread of malware. Then we have some peer-to-peer networks where the connections are directly made between two peers. We have the Tor network as well. For example, Bitcoin is a peer-to-peer operation, and BitTorrent, just like BitTorrent, we have direct connection with different peers, and they can be utilized by the hackers or the hackers to actually distribute illegal files that we see in the torrents to and avoid detection. So this type of network is dynamic. It allows different type of connections. Similarly, we have a Tor as well that that is an advanced form of peer-to-peer network, and the internet that we browse over the Tor is called the dark web, and the people now host illegal stuff on it, or this network can be utilized to browse anonymously, and no one will know the source and destination of the traffic that is going on. It is also used by the whistleblowers to post some leaked information. For example, the WikiLeaks, you can say the news agencies use it to hide their identities. Then we have the illegal usage of fraud. There are very hitmans available over there. There are drugs available over there. So as identities are not revealed over Tor network, it is becoming more and more popular. And with the introduction of Bitcoin, the payment system has shifted towards cryptocurrency, so the identities now remain more hidden, and now people tend to tend to buy illegal stuff over the Tor network with the help of Bitcoins, and they can just remain anonymous. So then what web servers are utilizing? They are utilizing a number of servers with some load balancing. For example, Google has a number of servers. There is not, we cannot say that the Google has only one server and it is working. There are a number of servers. There is some kind of load balancing going on, which is redirecting that. And there is some load balancing manager that is actually distributing that load. So an attacker, what he can do is he can just manipulate or attack this load balancing manager itself, or it can just we can say generate some traffic that looks like it is coming from load balancing manager itself, and he can actually manipulate the servers. This is one of the attacks. So this is all for module 24. So the next is the statistical data. So like session data, statistical data is about the network traffic. It is actually created through analysis part. The session data is actually the raw data, and the statistical data is created after some analysis. So there can be some conclusions that we can make that describe or predict network behavior from these analysis. So it can be to just it can be utilized to detect anomalies in the patterns. For example, if there is some bank and there is a particular pattern of traffic during the working hours from 8 to 3, and in the off time the traffic is actually reduced. But if you see a sudden surge in the traffic at off time, it means that there can be some kind of attack that is going on. So it can be used to characterize the normal amount of variation in traffic patterns in order to identify the network conditions that are actually outside the those ranges, and these differences should raise alarm, and then some investigation is required to be carried out. So there are a lot of network monitoring applications that we can install. For example, we have NetFlow or Internet Protocol Flow Information Export, IPFIX, network telemetry data. You can just have these applications on your system, and it can actually generate some stats that can be actually utilized to identify any anomalies. Similarly, we have Cisco Cognitive Threat Analytics as well from Cisco. And this software is actually able to identify any malicious activity that has bypassed security controls or entered network through unmonitored channels, including USBs, etc. So, even if you have some antivirus installed, some IDS, IPS installed, if there is some anomaly in the traffic, it is very difficult to actually capture those. So this actually Cisco Cognitive Threat Analytics actually works in the cloud, and it uses machine learning and statistical modeling to actually create the baseline of the normal traffic, and then it monitors the real-time traffic and it compares it with the baseline, and if there is some anomaly going on, it generates some alerts. Then we have end devices logs. So we have previously discussed as well that we have host-based intrusion detection systems that actually run on individual hosts or individual clients. So these not only detect intrusions, but also act as a firewall and can also try to prevent those intrusions. And these contain some logs, store them on the host. But it is very difficult to actually analyze if we do not get these logs at a centralized location. So many host-based solutions have a way to submit logs to a centralized log server, where the logs can be searched from a central location, such as we can use tools like NFM tools. We have some agents that are actually installed on the machines, and where these agents send these logs to a centralized server. So there are different kinds of logs that these agents are sending. First, we have the application logs. These are created These are the events logged by some various applications. For example, we may have some Apache logs, some web server logs. We may have some system logs. These include events regarding drivers, processes, hardware, login attempts, these kind of events, uh, setup logs, security logs, and command line logs. So these are different kind of logs that we can actually have. So moreover, various logs can have different event types as well. For example, security log consists of audit failures or failure messages. On Windows computer, this is carried out by the LSAS, which is also responsible for enforcing these policies. Uh, and it can actually be the first target of a malware to actually corrupt these processes. So we can actually identify these logs by some event IDs. For example, in Windows, we have each event given a particular ID, and we have then encyclopedia of Windows event IDs that we can actually go over to the Microsoft website and see what each event ID correlates to the event. So these are a few event logs types and their explanations. For example, if we have some error, it means that it is an event that indicates a significant problem, such as loss of data functionality. For example, if a service fails to run or an event log is logged. So these are all logs that are actually logged by the Windows. And then we can have an agent running on our client that is sending these logs to our centralized server. Next is the syslog, and syslog includes the specification of these these log messages that will be sent to the centralized server. It works on the client application structure, and many type of network devices in the computers, switches, routers can be configured to use the syslog standard to actually log these events to a centralized server. So this is a protocol that is used to actually send the logs to a centralized server. So it was defined by IETF in RFC 5424 and is supported by multiple devices. It normally works on UDP port 514 or TCP port 5000, and normally it is sent in the plain text, but there are some we can say implementations of this log where we can implement some certificates and try to encrypt this information as well. So the format of the syslog message is actually shown. First we have the priority, we have the header, and then we have the message text as well. So the next are the server logs. So we have the logs from the client side, and then we have to have the logs from the server side. If we are running some kind of server, for example, if we have some internet server, some DNS server, we need to have these logs, and these are essential for network security monitoring. So network application servers such as email, web servers keep these access and error logs. The DNS proxy server logs will document all the DNS queries and responses that occur on the network as well. Similarly, the proxy, if you have some proxy servers, it is also maintaining some logs, and it is identifying the hosts that may have visited dangerous websites and are identifying and is actually able to detect if DNS tunneling is being used to exfiltrate the data or for some command and control channels. So many Unix and Linux servers use syslog to send this data. Others may use property logging mechanism as well. and the content of these actually events depend upon the type of the server that is actually installed. So the most famous ones are the Apache access logs, because most of the web servers are based on this. And if you have a Windows web server, we will have IIS access log that is also shown on the slide. So once we have all these logs from the network side as well and from the host side as well, then we have the SIEM solution, which is Security Information and Event Management Technology, that is used in organizations to provide real-time reporting and analysis of security events. So it correlates everything. It has logs from IDS, firewalls, host integration prevention system, server logs. Everything is actually ingested and then correlated to give an overview of what is happening in our actual environment. So it combines a lot of different functions. First, we have the log collection. It collects logs from throughout the organization from different endpoints. Then the logs are normalized. So these logs are in different formats. So the format is standardized so that we can actually correlate this. Then in the third step, the correlation is done. These links logs and events from different systems and applications, and then we can speed up the detection part as well and react to security threats. Then the aggregation part as well. If there are a number of logs related to one event, these are aggregated, they are grouped, and then it generates some alerts, some reports are generated, and in the end we have the compliance requirements. So it helps us to monitor that how compliant are we against a particular standard. For example, we can say that we have ISO 27001 implemented in an organization. So it is able to actually identify what rules are there or what controls are actually implemented in the organization or whether they are working fine or not. So there are a number of SIEM software or solutions available, and a popular one is Splunk. We have actually one another from IBM called QRadar. These two are take up more than 90% of the market share in terms of SIEM solutions. So the Splunk is actually made or developed by a Cisco partner, and we can see the Splunk dashboard on the screenshot. So uh, these actually uh, correlate the logs and displays these events in real time, and it actually has a SOAR capability as well, so uh, it can automate threat response at some level as well. So we have a number of tools that help us to identify the events in the real time. Next, we have the network logs, and the first important tool that we can utilize to actually dump all the traffic is TCP dump. It is just a command line, we can say brother of Wireshark. It is a very popular utility. It can actually display packet capture in real time or write packet captures to a file. It can not only capture the packet protocol data or the header information, but also the complete content data. And the Wireshark is actually built as a GUI on top of TCP dump. So if you are working in the command line, you use TCP dump. You are working in the GUI, normally you prefer Wireshark. You can have TCP dump working in the background, logging all the data to a file. Next tool is the NetFlow. It is actually a protocol that was developed by Cisco as a tool for network troubleshooting and session-based accounting. So it can efficiently provide an important set of information about the current running sessions. We see what information is flowing or how much information is flowing between the client and the server. It can monitor if there is a certain surge, if there is some denial of service attack going on, and it provides a valuable insight. Uh, it is not designed to provide a full data capture of the complete traffic. Rather, the insights about the flow, or we can say the metadata, is provided. So the Cisco actually developed this protocol, and then this was made uh, as an input to the other tools like NFDump uh, that is actually utilized that actually utilizes this protocol and shows you the information about the current running session. So we have also some tools that provide the GUI to this interface. For example, we have open source flow viewer tool that works on this protocol. So this is just an example how that data is recorded. For example, we can see that the date is there, data flow, when the data flow started, uh, uh, how much the duration, protocol source, the IP source, and the destination as well. So we have actually the amount, how many bytes were flown, how many packet captures were there. So we have all the information recorded with the help of NetFlow. Then we have proxy logs as well. In large organizations, we see that the proxy servers are actually installed, which is actually utilized to route all the traffic. So these servers contain valuable logs that are the primary source of data for network security monitoring. Normally, we install proxy servers to actually see those logs or to capture those logs. We want to see that which uh, person or which client is actually utilizing or going onto some prohibited website. That's why we have proxies. So an enterprise may configure a web proxy to handle these web requests on behalf of clients, and the request is first sent to the proxy server, and the proxy server requests the resource and return them to the client. So it generates an alert if someone is actually going over to some gaming website using some social media. The proxy server is actually designed to actually block it if you configure it like that, or it can actually log it and send the logs to an admin, which can then know that this client or this client computer is actually browsing some prohibited website. So there can be also data loss prevention solutions that are installed on these web proxies, and see if there is some sensitive file that is going out of the system or out of the enterprise network. It can actually monitor those as well and block it. So we have a lot of solutions. For example, we have Cisco Umbrella that can be used uh, as a DNS server that extends the capability to include security enhancement that can actually block some websites that, or you can configure logging over there that can be sent over to a remote server. Then we have the next generation firewalls. So these extend network security beyond IPv4 or layer 4 port numbers to the application layer as well. So the problem with the normal firewalls is that they cannot actually see the encrypted traffic. So these next generation firewalls are designed in a way that they are built upon the normal firewalls. They have their own certificates that are installed on the clients. So they can actually see the traffic that is going on. And for example, they may be able to detect the web application attacks as well as it can see the web traffic as well. So we have the Cisco line of next generation firewalls that is a 7th layer firewall. It can contain, we don't need to actually have different firewalls for example, normally in enterprises, we have web application firewall as a separate entity and a network firewall as a separate entity. But in next generation firewalls, these two have been merged and it can actually control and see all the traffic that is flowing through our networks. So it can actually see a lot of traffic and can generate logs, for example, the connection logs, who is actually connecting, intrusion logs, host or endpoint events. So every kind of log now can be monitored by only one device, and then it can actually generate the alerts. So these next generation firewalls actually act like a correlator as well or aggregator as well. It can correlate different logs and act similar to a SIEM solution. Some also provide some firewalls from Fortinet also provide a dashboard like SIEM solution, and where we can actually see what logs are there, or we can correlate them and generate some alerts. So we discussed about the Splunk and QRadar. Then we have some free solutions as well. Splunk and QRadar are one of the most expensive solutions that are available to actually monitor the alerts. So then we have open source that are based upon the ELK stack. We will see the components in the next two slides. But in the core resources, you have one free solution called Security Onion that you can have as a complete package inside a VM that you can actually implement on your network. It is good for a network that has a few computers. So it can provide all the core functionalities such as packet capturing and analyzing it, network-based and host-based intrusion detection system, and analyzing those alerts. So it has all the tools that are combined. It can be installed as a standalone installation or as a sensor and a server platform as well. So you can actually have it as a standalone that has all the tools, or you can actually implement that and use some functionality of it. For example, you can use the Snort firewall format and actually route the alerts to some other platform as well. So these are all the tools that are actually installed. For data collection, we have the PCAPs, alert data, syslog data. It is able to ingest all these the data from these resources. And for the detection part, we have different tools like Snort IDS, the Sulcata, Zeek, and Wazoo that can actually detect any event and can generate the alert. And for the advanced analysis part, we have this SQL dashboard that we saw in earlier slides, and we can actually go into detail analysis with this Wireshark or Kibana. So it has CapMe that can actually allow viewing of PCAP transcripts rendered with TCP flow or Zeek tools, the GUI based application. Then we have Snort, which is an intrusion detection system. Then we have the Zeek, which is network-based intrusion detection system. So Snort is host-based intrusion detection system, and then we have the Zeek that is network-based intrusion detection system, and then we have OSEC as well, which is also a host-based intrusion detection system that can actually This can also be look forward to. Then we have the Wazoo that contains the necessary agents that can be installed on different hosts or devices. It can actually alert, it can actually monitor the resources on a system, monitor the alerts, and send those alerts to a centralized server. Then we have the Suricata as well, that is actually a signature-based NIDS. It can also be used for any end-to-end prevention. Then we have the analysis tool as well. First, we have the SQL, that is a high-level console, that is actually a dashboard where you actually see the alerts. And then we have the Kibana, which is also an interactive dashboard that can be used to do the advanced queries on the logs that are saved. Then we have the Wireshark that can be used to open the PCAP file and see what actually is going on if you're going for something for analysis. Then we have the Zeek, that is a network traffic analyzer that will generate some stats, some graphs. It will try to find anomalies. An alert is generated, it normally contains a few identifiers. And the most important identifiers are the source IP address, the source code, the destination IP address, the destination code, and the source code. So these are the actually 5 key elements. And these are mostly the same. These are mostly the same in all the SIEM solutions, whether they are commercial solutions or whether they are open source solutions. So we see these identifiers with each type of alert. Then we have some timing information as well. For example, the current status, which we can see the ST, the count, the number of times the event has been detected, the sensor, which agent actually generated the alert. So this is the actual SQL window, and you can see that we have the source IP, source port, destination IP, destination port, the port number, what the message was actually generated, and then we have the sensor, which actually, which is the agent that generated that alert, how many times it was generated, and what is the current status. We can actually change the status, that whether we have analyzed that or we have not. There are some priority levels as well, for example, very low, low, medium, high, and we can actually change those as well. And by default, these are set on the actually the category of the alert. This is this explanation. The alert ID, the 2-part number is the sensor that has generated the alert, the date, time, the event message. It will give you a brief description why these alerts were generated by the SQL. So we have alerts, and these alerts are actually coming on because we have some rules that are set up in our these monitoring solutions. For example, the network intrusion detection system, the Snowd, Zeek, and Suricata, the host intrusion detection system, OSAC, and Wazoo. And then we have the asset management and monitoring system as well, which is actually monitoring the assets, the HTTP traffic, the DNS traffic, and the syslog alerts. So alerts can come from anywhere. So this is actually the rules. So we can say the structure, how this consists of. For example, we have alert IP any. So if it will generate an alert if there is an IP traffic between any source or any port number that is going to any destination or any port number, and it contains this kind of traffic. Any ID number, the rule options. This is just every software has different kind of structure, which we are not going now in detail, but you will see that we actually write those rules. First, we have the default list, and then we actually modify these rule lists according to our environment, and then we analyze those. So actually, why do we actually need to evaluate these alerts? So threat landscape is actually changing. There are new vulnerabilities identified. So they are actually exploiting our systems in a manner that they are trying to evade these antiviruses and intrusion detection systems. So any software that is working in isolation may not be able to detect advanced attacks. But once we have, uh, we can say that logs from different type of devices, we can actually correlate them. And if an alert is generated, then we need to identify whether it is actually a false positive result or the or it is actually a genuine, we can say, an event that has taken place. There are going to be a lot of alerts, and the role of the security operations analyst, the tier one analyst, is that it will go through these alerts one by one and will try to analyze whether the event has actually taken place or whether it was a false positive. So it can be actually, alerts can be classified into true positive, that whether an actual security incident was taken place, or the false positive, if the false positive is if the alert does not indicate an actual security incident, but the benign activity that results in false positive is sometimes referred to as a benign trigger. Then we have the true negative, no security incident takes place, or the false negative, that undetected incident has occurred. These are actually the four type of events that can take place, and actually we are interested in the true positive, that we are able to identify that once an event is actually taken place, and the false positive as well, that if an alert was generated due to some false alerts, then we have to actually disregard them. So we are security analyst tier one is actually playing in the first two, we can say, the categories. So then there is a deterministic analysis and probabilistic analysis. So in deterministic analysis, the evaluate the risk is based upon what we know about a vulnerability. So we can actually just look into the events that have actually caused this alert. For example, we will actually see that this malware tried to go to a website that downloads a command and control server. So there are a complete chain that we can actually follow, and then we can actually determine the analysis in the analysis part that this is actually a genuine event. Then there is a probabilistic event or analysis part that we are actually playing with the stats. For example, if there is a sudden surge in the traffic, then we are actually doing our analysis, a probabilistic analysis, that as this traffic is against, or there is an anomaly in the baseline traffic, so it should be regarded as an alert. So these security onion and these open source SIEM solutions are mostly based on the ELK stack, or we can say the Elastic stack, and it contains a few core components. For example, we have the Elasticsearch. First of all, that is an open source platform that can be utilized for searching and analyzing organization data in real time. Then we have the log stack. It enables collection and normalization of network data or the events data into data indexes that can be actually searched through Elasticsearch. So it is performing the normalization of the, we can say, the log events. Then we have the Kibana that actually generates our GUI interface. Then we have the Beats, that is the software plugins that are actually enable the ingestion of data from different APIs or from different resources. So the amount of network traffic that is collected by these tools, or we can say this packet capture and log entries, is very much enormous. Even with the recent advances in big data processing, storing, and accessing, these are very large. So we need a mechanism to actually limit the amount of logs that should be stored, or there is a mechanism required that can actually aggregate a few logs into one log, and it can store those efficiently in the database. So we have tools for data reduction, or for, we can say, for aggregating the data and saving it in a manner that limits the amount of data that is required to actually correlate them or to determine whether an event has taken place or not, and we are just disregarding any uh, not required data. Then the data normalization is the process of combining data from a number of data sources into a common format. So we have syslogs, we have some logs from IDS, IPS. So we have the log stack that provides a series of transformations that processes security data and transform it in a unified format before adding it to Elasticsearch. So we may need additional plugins as well. For example, if you are ingesting data from Cisco and you also have devices from other vendors like Huawei, you need special plugins to ingest all type of data. And you need to define a common schema that will be used. Formatting of the data fields can vary between the resources. However, if the searching or correlation of data is required to be consistent, we need to normalize that. For example, we may need to normalize IPv4 addresses, IPv6 addresses, the MAC addresses formats, the date and time format, the timestamps. So everything will be done, or will be normalized and will be kept in a same one format. Then we have the data archiving as well. Everyone would like the security of collecting and saving data, everything, for a longer period of time, but it is not possible always. For example, in CCTV cameras as well, we keep the log of 7 days, 14 days. Similarly, for the network security events as well, we have to keep the log for a certain period of time. We can just set in different time periods for keeping the data. For example, we can have separate time for PCAPs, we can have separate time for the syslog data. Normally, we have in security onion, we have security onion.conf file where we can set these time frames. And we can also identify how much hard disk it is going to take place. We can actually do it, configure it in a manner that it automatically overrides the hard disk space, so that it is utilizing the same space again and again. So once we have the data, then we can actually we can analyze that, or in the SQL. So the primary duty of a cybersecurity analyst is to verify these security alerts. And depending upon the organization, these tools will differ. And normally a ticketing system is used to manage these task assignments. In Security Onion, the first place that a cybersecurity analyst will actually go to verify alerts is this SQL. It automatically correlates similar alerts into a single line and provides a way to view correlated events represented by that line. And in order to get a sense of what is happening in the network, it may be useful to sort out in the count element column as well. So once we have a number of counts, for example, we have a brute forcing attempt and we have thousands of counts of the similar events, it will generate an active attack that is going on. We can actually sort them with a CNT value, and we actually see the latest trends in the attacks that are going on. Then we have the ELK as well. We have the log stash and beats that are used for data ingestion in the Elastic Stack. Kibana is a visual interface similar to SQL. Logs are ingested in the Elasticsearch into separate indexes or databases. How you are going to actually configure that depends upon the you. The best way to monitor Elasticsearch is to monitor the data in Elasticsearch is to build customized visual dashboards. So Kibana can be configured. You can have different dashboards to monitor different kinds of data. For example, in an organization, if you want to alert the web traffic separately, you can have a separate dashboard. So these are the different dashboards that you can see. You can generate some dashboards where you can define which data is to be used and how the alert should be displayed, and you can actually click on one of the dashboard and you can see the visual representation of the alert. Then we have the workflow management. So workflow management are the sequence, workflows are the sequence of processes that how a security incident or an event can be actually traced. So we are actually looking how we can actually increase the efficiency of our cyber operations. For example, in SOC, the first incident responder is actually a tier 1 analyst. He is actually monitoring the SQL dashboard, is looking through the alerts, and if he starts managing one of the alerts, he will generate a ticket. While he is actually going through the analysis part and seeing whether it is actually a genuine alert or a false alert. And once he make out that it is a fake alert, he can actually flag that, and then alert will be disappeared from that, will be marked as analyzed. But if he sees that this is actually an alert and it needs to be analyzed further, it will be marked on the same ticket to a tier 2 analyst that will go deeper into PCAPs and will go into the actual traffic analysis. He will extract the malware from the actual PCAP files and see what actually happened in the network. So there is a specialized kind of ticketing system that is implemented where the workflow of the information or how the information is flowed from tier 1 analyst to tier 2 analyst and the SOC manager is actually determined. So that's all. That is the end of our Cisco course.